Hello and welcome to this full 7+ hour Flutter Clean Architecture course. Now the individual parts of this course were already released, so if you have watched them, you do not necessarily have to rewatch the full course because they are the same parts, just stitched together. However, I know that some people like to see full courses, which take a couple of hours to finish. So if you are one of those people and you would like to learn about clean architecture in Flutter, this is precisely the right course for you. Every single part of this course is also supported by a written tutorial to which you can get from the link in the video description, and over in those written tutorials you can find all of the code written in the videos, links to the libraries, and you can also go over the lessons at your own pace. Before you set out on the awesome journey of learning Flutter Clean Architecture, just keep in mind that some of the libraries which are being used throughout this course have been updated to newer versions. So if you want to follow along with this course precisely, and you definitely should, keep the library versions the same, do not update your packages to newer versions. And also, if you want to see the code, how it's implemented with the newer versions of the packages, you can always go to the GitHub repository associated with this course and check out if there are any changes over at that GitHub repo. And now, without any further ado, let's get right to learning clean architecture in Flutter. Hello, welcome to Reso Coder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. Keeping your code clean and tested are the two most important development practices. In Flutter, this is even more true than with other frameworks, because on one hand, it's nice to hack a quick app together. On the other hand, larger projects start falling apart when you mix the business logic everywhere, which is so simple to do with Flutter because even the UI is written in the same programming language in which you write the actual logic. Even state management patterns like BLoC are not sufficient in themselves to allow for easily extensible codebase. And this is where we can employ clean architecture and test-driven development. As proposed by our friendly Uncle Bob, Robert Cecil Martin, we should all strive to separate our code into independent layers, and that's precisely what you are going to learn how to do in Flutter in this course. Let's start out with the completely finished app which you will have built by the end of this course. We're gonna build a number trivia app because, believe it or not, there is actually a numbers API which provides some nice trivia about numbers. So we can input a number here, for example 1, 2, 3, and then search for the trivia. Let's search for yet another number, for example 42, right? And we can also get random trivia. This is another endpoint on the API. And then also this app will cache the gotten number trivia from the API so that if we should not have internet connection, so if we enable airplane mode here and come back to the app and get random trivia, it's not going to get us any new trivia, it's just going to display the lastly gotten cached trivia. Of course, once we enable internet, we'll be able to again get new trivia just like before. This app has all of the core components which you will be working with in your own apps on day-to-day basis, such as getting data from API, local cache, error handling. For example, if we input ABC with a keyboard, you can do that. So input that, it says invalid input, the number must be a positive integer or 0. It has like input validation and all that good stuff which you should have in production apps. And as for state management, we're gonna use BLoC, but you do not have to use BLoC because, as you will see later on in this course as we progress, it will become apparent that the state management which you choose is really almost inconsequential because everything will be handled in different layers. So the bottom line is, do not worry if you do not want to use BLoC in your apps. You do not have to. Clean architecture works with any kind of state management pattern, even something like simple change notifier with a provider will be just fine. And be sure to check out the written tutorial from the link in the description if you want to really go through this at your own pace, because this first part will be more about theory behind clean architecture, because we cannot progress forward in this course without first understanding the core concepts of clean architecture and why it's actually useful and why it does things the way it does them. And in the written post accompanying this first part, you have all of that available and you can go through it at your own pace. So let's first take a look at the clean architecture as it was proposed by Uncle Bob. So it looks something like this, and really it doesn't tell us much when it comes to Flutter, because like what is a controller, what is presenter, gateway, what is all of that? It just spits out a bunch of abstractions in our face, and all in all it's a bit abstract. Pun intended. Also, while the essence of clean architecture remains the same for every framework, the devil definitely lies in the details, and we will have to adapt this general clean architecture to Flutter. So lo and behold, because now I will introduce to you the ResoCoder's Flutter clean architecture proposal. Yes, it's an official thing now, which will demonstrate something, should I say, more important than just some dependency flow and the onion. It will show you the data and call flow. It may seem like there's a lot to comprehend here, but do not worry, we are going to get through this slowly one by one. So the core thing here is that the whole app, or should I say every core feature of an app, like for example getting number trivia, will be divided into three parts, three layers: presentation, domain, and data. And actually the app we are building, this number trivia app, will have only one feature because it's a simple app. The only thing we do here is to get number trivia. So we'll have only one such division into folders. So let's actually create these presentation, domain, and data folders right now. So let's open up VS Code. We are starting off with a completely new project here, and I will enlarge this so you can see the folders even better. So inside the lib folder, we are going to start off with creating a features folder, because every feature, as I said, will have its own folder, which will be divided into presentation, domain, and data. So let's just create the folders and then I will explain everything more in depth. So the feature name will be simply number trivia. You can have feature like login or registration or something like that. You can have feature settings and so on. If you have those things in your app, we have just one screen, number trivia, and that's it. In here, we want to create domain. Then another folder will be data. And the final one will be presentation. And with this, we have the basic structure, the most high-level structure of our app created. Of course, just having features is not enough, because what if, for example, you have something which can be used across multiple features? Let's just say that you have also settings feature, and even over there you want to do input validation. Well, input validation, for example, just checking if the inputted text doesn't contain any numbers, that's not really feature specific. It can be shared across number trivia, settings, whatever. That kind of functionality will go into the core folder. All right, now that we have the basic folder structure, let's continue on with this awesome diagram. Let's take a closer look at the presentation layer, which is actually what you are already used to in Flutter if you've done any kind of a Flutter development before. So presentation is comprised of widgets. So this is where all of the pages live. For example, number trivia page. And this is also where you will have your own custom widgets. And then it also has something called presentation logic holders, which is either a BLoC, a change notifier, or really anything which you would classify as state management. You can even go the good old stateful widget route, but I would really recommend you to at least go for change notifier. But I really think that BLoC is the best state management option for Flutter out there. But really, presentation logic holders, they're not all that important which you choose. We are going to choose BLoC for this app. And as opposed to what you may be used to, these presentation logic holders, so BLoC or change notifier, will really not do much by themselves. They will only delegate all of their work down to use cases, to the domain layer, and so on. BLoCs or change notifiers will be really lean classes. They will not have a lot of logic. At most, you will do some really basic input validation inside of them, and that's it. Everything else will be delegated to the next layer, which are use cases or the domain layer. Before we continue with the next layer, let's just jump into VS Code and let's create the structure of the presentation folder right now. So we're going to create new folder under that. It's gonna be called BLoC. Again, you can use anything you want. And then pages, and finally widgets, which will be just widgets which we do not want to have directly inside the page because it would just clutter up the UI code. The next layer we're gonna take a look at is the domain layer. As you can see in this call flow arrow, the call flow will happen from the upward layers, so presentation, down. So this presentation logic holder, for example, a BLoC, will delegate its work and call use cases which are from the domain layer. So what is actually the domain layer? This is the inner layer which should not be susceptible to the whims of changing data sources or porting our app to Angular Dart. It should be really platform independent and actually independent of anything else inside the app. It will contain only the core business logic, which will be executed inside use cases, and then also business objects, which we are going to call entities. And by the way, use cases are classes which encapsulate all the business logic of a particular use case of the app. So for example, we will have use cases for getting concrete number trivia right here, which will be executed whenever we press the search button here. So this is get concrete number trivia use case. And then another use case in our app is get random trivia. So those will be two classes, get concrete number trivia and get random number trivia. Of course, in our app, we will not have a lot of business logic, and even the entity which will hold the number trivia, actually, they are gonna be pretty lean classes because we're not doing much in this example app. But in your own projects, when you are building something more substantial, the domain layer is where the bulk of the code will be located. And if you've been listening to me carefully, I've said that the domain layer should be completely independent of every other layer. Well, I know that you probably cannot tell much just from this diagram, but it seems that the domain layer is independent of the presentation layer. But here it gets kind of fancy looking because the repository is seemingly inside the domain layer and also in the data layer, right? So what's up with that? Half of the repository is domain and half is in data? No, that's not how it works. What this nice fancy gradient on the repository signifies is that the repository class is on the edge between data and domain layers. And to allow for the independence of the domain layer, we are going to do something called dependency inversion. So what is dependency inversion? I know that you may be getting some goosebumps because they're just scary words, but dependency inversion is in essence very, very simple and straightforward. It's just a fancy way of saying that we create an abstract class repository which will define a contract of what the repository must do. So for example, in our app, we will have a repository which must provide us with random trivia and concrete number trivia. Those are the two things which the repository just must do. And that goes into the domain layer. The domain layer does not care how the number trivia will be gotten. It just cares that it will be gotten, right? This is all possible with an interface, or because Dart does not support interfaces, we have to use abstract classes. And then the other side of the coin, or in this case repository, is inside the data layer. The data layer will define how the data will be gotten and managed and all of that. We're gonna get to that in just a short while. But the important thing is that the repository in the data layer will implement the abstract class, so it will have to conform to the so-called contract, so that domain can really not care what's going on behind the scenes. It just knows what kind of data it will always receive from the repository. In this case, it will be the random number trivia and concrete number trivia. So let's create a folder structure, shall we? Inside VS Code, the domain layer will have 3 subfolders: entities, which will be the number trivia entity, which will simply hold the text of the trivia and the number of the number trivia. Then we will have also another subfolder, repositories. This is where the contract or the abstract class of a repository will go. And then also the last folder is use cases. So use cases are get concrete number trivia. And as you can see, there was some server failure now. So error handling works correctly, but I don't know why there was a server failure. But anyway, now we have 42. So this is the concrete or get concrete use case. And we also have the random use case. And let's now move on to the data layer. As you already know, it contains repositories which implement the abstract classes from the domain so that they will have to just fulfill the contract defined by domain. And then it also contains remote data sources, local data sources, any kind of data sources obviously go into the data layer. Usually you have one data source for getting remote data from the API, and then you also have another one for getting local data. In our case, we will use shared preferences to cache the data locally. And local data sources are also where you would have your, for example, GPS, location code, and all of that good stuff. Data sources do not have to just operate with databases, they can also operate with the underlying platform or device. And the repository is the brains of the data layer, because this repository will decide when to cache, what to cache, when to get data from the remote data source, when to get data from local data source. So for example, if there is no internet connection, we definitely want to get data, the cached data from local data sources. And you may notice that repositories output entities, which kind of makes sense. And again, entity is just the number and the text of the number trivia, really simple in our case. But data sources do not output entities, they deal with something called models. And this nomenclature is really not all that important. It doesn't matter how you call these things, it's just that you know what those names mean. And the reason behind having models is that transforming raw data, which is for example JSON, requires some conversion logic. Because we cannot work with JSON in our app, we have to convert it to Dart objects. But now let's think about this. We definitely do not want to put our JSON conversion logic, so to JSON and from JSON, as we are all used to, for example, from build value or JSON serializable, we do not want to put those conversion methods into entities. And why is that? Well, entities should be completely platform and data layer independent. So for example, if we switch from JSON to XML or to some binary data craziness, we do not want to change the domain layer at all. We only want to change the data layer when something data related changes, but the domain should remain untouched. Therefore, these models will be simple classes which extend entities and add some functionality on top of them. And because they are subclasses of entities, we can then simply cast them into entities, and the repository will output the entity which does not have any additional functionality or fields added on top of it. In the number trivia app, since we do not have anything really difficult to do, models will have only toJSON and fromJSON methods. But if you are storing something locally in an SQLite database and for some reason you have to have the ID inside the database stored inside the model, you can also add some custom fields to the model, not just methods. In our app, the remote data source will perform an HTTP GET request to Numbers API, which is simply numbersapi.com, and all of these links and all of that which I'm explaining here is also available from the written tutorial, so definitely check that out. But here is numbersapi.com. This is the API we will be using. So as you can see, we can get random trivia, right? This is what we are doing from within the app. So this is what the remote data source will do. It will perform GET requests. And then we have also local data source, which will simply cache data using the shared preferences package. And then these two data sources will be combined, sort of, in the repository, which in the case of the number trivia app, it will do just a simple thing. It will check whether or not the user is connected to the internet. If there is internet connection, it will always prefer to get fresh data from the remote data source. If there is no internet, it will get the cached data. And it will also have a simple caching logic, which is that we always cache everything as soon as it's gotten from the API, so that if there is no internet connection, it will always return the cached data, the last cached data to be precise. Alright, so let's now create the folder structure even for the data layer, because the things below are not actually a part of our app. These are some external things. We do not care about them. It's not a part of our code base. And the data layer will be comprised of data sources, models, and finally, implementations of repositories. So the repositories folder in data will hold the implementations, and the repositories folder in domain will hold the abstract classes or interfaces, which are the contracts which the repositories implemented in data must fulfill. And again, this abstraction is necessary so that the domain layer can be completely independent of every other layer. Alright, so this first part of this test-driven development clean architecture Flutter course was really theory heavy. That's because something like clean architecture requires a lot of explanation, because after all, you cannot just start building a house without first planning how the house will look like. You have to have at least some basic structure, some basic drawings in place. And these drawings were laid down in this first part. So in the next parts, we are going to actually get coding and doing test-driven development, and we're going to start off with this domain layer. If you want to grow as a Flutter developer, go to flutter.education, link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Those resources and news are curated by me, and I really try to pick the best ones which will push you forward on your app development journey. And over there you can also subscribe to my mailing list so that you will get those news and resources delivered weekly right into your mail inbox. In the first part, you learn the core concepts of clean architecture as it pertains to Flutter. We also created a bunch of empty folders, which you can see on the side right now, for presentation, domain, and data. This is for the number trivia app we are building. And now it's time to start filling in these empty folders with actual code, of course, using test-driven development. So of course, whenever you are building an app, you should start with the UI and user experience first, but I've done that homework for you. As you've seen in the previous tutorial, the app looks something like this. The actual coding process, though, will happen from the innermost stable layers, and we'll progress toward the outer layers. So in the case of clean architecture, as it was proposed by Uncle Bob, we can see that we should start from the domain layer, particularly from entities. So we are going to create an entity right now. Before we do that though, before we can create an entity for the number trivia, we have to add some packages over to PubSpec YAML, because we are gonna be using quite a lot of packages to make things easier for us, of course. And with that, I have to tell you to make sure you check out the written tutorial from the link in the description, where you can find all of the code written in this video, all of the links and all of that good stuff, and go through this lesson at your own pace. This PubSpec YAML file is one of the few things which I'm going to just copy and paste over on video so that I don't bore you to death. So let's just delete all of these unnecessary comments, which is clutter up the PubSpec YAML file, and then the dependencies and dev dependencies will be the following. So we have getIt, which is the service locator. I've added all of the dependencies right now so that we later do not have to come back to this YAML file and just lose time on that. So we have getIt. Then we have Flutter BLoC for state management, equatable for value equality. Then we are going to touch on some functional programming concepts. Then for remote API, we have connectivity and HTTP packages, of course. And for local cache, we are going to be using just simple shared preferences. As for dev dependencies, these are the ones which do not get packaged together with your app once you build it. We have Flutter test. This was here even before, I think, by default. And then we have Mockito for creating mocks. We are going to get to all of this as we progress forward with this tutorial, but just so that you have all of the packages already present, we've added them over here. And I'm just going to delete all of the other comments so that they don't clutter up PubSpec. And here we go, the PubSpec.yaml file is completely finished. Alright, so let's now move on to creating the actual entity. The first question we have to ask ourselves is, what kind of data will the number trivia operate with? Well, of course, with number trivia entities. So we can create a new file under the domain entities. Let's call it number trivia.dart, of course. And now we have to take a look at the Json response from the API, because based on that response, we are going to model our class here. So if you go to numbersapi.com/42 or some other number and then $JSON, so it's a query parameter, you will obtain the following response. And of course, this link is also available from the written tutorial. So this is the response which we will be operating with throughout our app, and we need to model our number trivia entity so that it can contain this kind of data. So what do we actually really need from this JSON object? Well, we need the text, obviously, because that's the core, so to say, functionality of our number trivia app, we are also going to store the number, but then we have two interesting fields which are found and type. We are not gonna need those at all because found is completely irrelevant for our case and the type will be always trivia. And why is found completely irrelevant? Well, if I search for a number other than 42, so for example, some complete gibberish long number which doesn't have any entry in the numbers API, and I search for that, you can see that found is false, but we still obtain some kind of a reasonable response that this is an uninteresting number. So we can still display even this message to the user in the app. We do not need to worry at all whether or not the number was found. So the bottom line is that we need the text and number fields to map to properties in our app. So let's create a class, number trivia, which will extend equatable. And let's import equatable here. This is so that value equality is made simple because by default, Dart supports only referential equality. So even two objects which contain completely the same data will not be equal unless they are referencing to the same point in memory. With equatable, this is completely changed. When two objects contain the same values, the same data, they will be equal. And we do not need to override equal operator or hash code, anything like that. Equatable does that for us, so it saves us a bunch of boilerplate. And now we need to store the text and number, so final string text, and then final int number. And of course, we need to put them into constructor, so we can just hit control dot, at least in VS Code, and create a constructor for all of these fields here. But we are not just going to have this kind of a constructor with unnamed arguments. We want to have them named, and of course, we are going to make them required. So we need to import meta package, so meta.dart, and let's just make these required. And also this one will be required here. And we mustn't forget to pass these over to the super constructor because equatable needs to know which properties to make equality happen on. So we are going to pass them in as a list. So we pass in text and also number to the super constructor, which is equatable. And you may have noticed that we didn't do any test-driven development here. That's because this class is really, it doesn't have any logic. There is nothing to test. So that's why we aren't writing any tests for this number trivia entity. Should you have any logic inside your entity, you would write test even for entity, but that's not the case with this one. All right, now let's talk about use cases. They are where the business logic gets executed. And sure, there won't be much logic in the number trivia app because all a use case will do is to get data from a repository. So just so you can see that, here we go with the diagram. We have use case here. It will get data from the repository and they will communicate together through these entities. And we have created just one such entity called number trivia a few moments ago. And we're going to have two use cases in our finished app: get concrete number trivia and get random number trivia. By looking at this diagram, as I've already said, you know that use cases get data from repositories and then they pass that data, which in this case are entities, over to the presentation logic holders and to the whole presentation layer. So it kind of makes sense that when use cases communicate with repositories, the repository should return an entity, right? But because we have to allow for asynchronous operations, we are going to wrap this entity, which in this case is number trivia, into a future. But that's not the actual case of what we are going to do. We have to think about error handling as well, because Is it the best choice to let exceptions freely propagate, having to remember, and when you have to remember something, you know that that's not cool. We have to remember to cache them somewhere else in the code if we let exceptions just nicely propagate at their own peril. I do not think that this is the best choice. Instead, we want to catch exceptions as early as possible inside the repository here, and then return failure objects from the repository methods. So, unlike exceptions, you will not have to try and catch all of these exceptions. You will have failure objects, which are returned as regular objects, return types from methods. There will be no special error flow, nothing like that. It will be just like a regular data flow without any kind of try, catch, finally blocks in the rest of the app from the repository upwards. So to recap, repository and then subsequently use cases will return both number trivia objects, and also they will return failure objects from their methods. So how is something like that possible? How can we return number trivia or failure from the same method? Welcome functional programming, and that's why we have imported the darts package over to our app. This functional programming darts package allows us to simply use an either type. While I will not pretend that I'm some functional programming pro, at least not yet, you don't need to know any really advanced stuff about functional programming either. Speaking of either, the either type, which is a functional programming concept, will allow us to return either number trivia or failure, which we are going to create next. Obviously, we still do not have any failure classes. So let's define them right now. We are going to create an error subfolder under core, and this will hold failures.dart. And the failure here will be really only a simple class. It will be abstract actually, because then later on we are going to create some concrete implementations of failure objects. And again, we are not writing this in test-driven development manner because there is nothing to test in an abstract class. So this will be abstract class, failure. Let's again extend equatable, so that the classes extending failure later on, should they have any fields like message or some error code or something like that, their equality will be able to be checked based on those fields. So for that, to use equatable in this abstract base class, we have to have a constructor here, which will accept a list of properties, which will equal const dynamic, which will be an empty list, and then we will pass this list of properties over to the super constructor. This is nothing really to worry about. This is just what's going on with this Dart analyzer. This is just simply the way that things work with equatable. So we pass in properties over to the super constructor. And again, this is only an abstract class. We are going to create concrete classes in the next parts of this course. Then, as you hopefully remember from the last part, and as is signified by this diagram here, a repository from which a use case gets its data is both inside the domain layer and inside the data layer as well at the same time. Or to be more precise, the definition of a repository, or as we are going to call it, the repository's contract, is present in the domain layer. This upper half of this gradient is pink, or what is this color, whatever. And then the concrete implementation of a repository, this green side of the gradient, is in the data layer. This will allow for total independence of the domain layer, But there is also another benefit which we haven't talked about yet, and that is testability. That's right, testability and separation of concerns go together extremely well. And this is the absolute beauty of clean architecture, because it really complements test-driven development, because without real architecture, you cannot even test anything, because spaghetti code, believe it or not, cannot be tested. How will this allow for better testing? Well, writing a contract for a repository, in this case this will be an abstract repository class, will allow us to write tests, test-driven development style of course, for the use cases even without having an implementation of the repository. Something like this is called mocking, and we are of course going to get to that later on. For now, let's create the so-called contract of the repository. Inside the domain folder, under repositories, let's create a new file, number trivia repository.dart. And inside of here, we will have an abstract class, number trivia repository. And this class will have the following interface. We want to have two methods here, one for getting concrete number trivia, for which we have to pass in a number. And don't worry, I will come back to the return types in just a bit. So get concrete number trivia, int number. Oh, if I could write number. And then of course, it's going to have get random number trivia, which will not have any parameters, so let's just rename concrete to random. And what is going to be its return type? Well, we are going to use that either type, which I have described previously. So let's go bit by bit. It will of course still return a future, because it will be an asynchronous operation to get the concrete or random number trivia from the repository and subsequently from the data sources. And what's interesting is the type which the future will wrap. It will be either, which comes from the darts package, so let's import that, and then either gets two type parameters. One is left, so L, and R for right of course, and the left side is always, for this kind of error handling, the failure. So let's import failure here. And the right side is always the success kind of data. So in this case, it will be the entity number trivia. And we of course need to import even that right over here. And then this return type will be the same for get random number trivia. We will cover this in greater detail later on, how to actually work with this either type. But for now, just know that this function, this method, will return either a failure, which is the left side, or number trivia, which is the right side. And this way we do not have to deal with catching exceptions anywhere else in the app than in the repository, which will convert the exceptions into failures. And let's use the nifty little extension for VS Code to fix import, so they will be in the relative manner. Okay, although this part is getting quite long and information packed already, I do not really want to leave you hanging. So we are finally going to write some tests while implementing the get concrete number trivia use case, and in the next part we are gonna add the get random number trivia use case. So definitely stay tuned for that and subscribe to this channel if you do not want to miss it, and also hit the bell button so that you will get notified about all the new videos. As is the case with test-driven development, we are going to write the test before writing the production code. So this will ensure that we aren't gonna add a bunch of unneeded functionality. This is the Yagni principle, you ain't gonna need it, which is one of the most powerful things about test-driven development, because it forces you to really think about what you write, because you really do not want to test unnecessary logic. It even doesn't make sense. You cannot write unnecessary logic with test-driven development. because you really just do not even think about writing something for future-proofing your code. And that is the perfect thing about test-driven development. So let's get right to it. Writing the test in Dart apps happens inside the test folder. We have a widget test here. We can delete that right now. So move to trash. And usually what we are going to do too is that the test folder structure follows the production code folder structure. So we are going to create all of these folders. So core will go here. Then also new folder features. Inside the features folder will be another folder called number trivia. And right now we are going to write only the use case, so the domain folder would be enough to create here. But we are going to create all of the other folders as well, so also data, and then presentation, just so that we have everything we need for future lessons. So we have data, domain, presentation. Inside the domain, we are going to have the use cases folder. And this is where we are going to write our first test. Tests in Dart are always named the same way as is the production code file, but we append test to the end. So because the production code file will be called getConcreteNumberTrivia, the test will be called getConcreteNumberTrivia test.dart. And again, you can get all of this code from the written tutorial, which is available from the link in the video description. Writing the test requires a bit of a setup. We know that the use case should get its data from the number trivia repository, for which we currently have only the contract, the abstract class. Because we have only the abstract class, we're going to mock it so that we can add some functionality to it only for this test. And mocking something also allows us to check whether or not some methods have been called on that object. And overall, it really allows for nice testing experience. So without further ado, let's create a class, mock number trivia repository, which will extend mock, which comes from the Mockito.dart package. And then it will, of course, implement first. It needs to implement the number trivia repository. Let's import even that. So extending this new class with mock allows us to mock it, of course. And then we implement the interface from the number trivia repository abstract class. Let's now also import the Flutter test package. So Flutter test.dar will go here. And now we have to think about how will the use case, which we currently do not even have a file for, and that is perfectly fine with test-driven development, how will the use case operate with the repository? Well, of course, it's going to get that repository passed in through the constructor, so that later on we can use the getIt package to do some nice dependency injection thingies. This is called loose coupling, and loose coupling is absolutely crucial for test-driven development, because without loose coupling you cannot test anything basically. And to pass this mocked version of a repository into the now not yet existent use case, we are going to use a method called setup, which is available for every test that you write in Dart, and the setup method runs before every single test. So let's first create void main, because all of the tests run inside this main method. And then we have the setup method here, in which we are going to initialize all the objects we need. But first we actually have to create the variables in which the objects in question will be stored. So what do we want to have here? Well, the now not yet existent getConcreteNumberTrivia use case. So we are going to just call it use case. And then also the mock number trivia repository will be stored here so that we can then later on get it and do some mocking on this instance. So inside setup, we're going to first initialize or instantiate, to be precise, the mock number trivia repository. So just let's create a new instance just like that. And then we're going to also instantiate the use case. So getConcreteNumberTrivia use case will be instantiated and the mock number trivia repository will be passed in. Of course, it doesn't make any sense to continue with writing the test because currently it doesn't even compile. So even before writing the actual test, we can do another step in the test-driven development because we have arrived in the red phase. TDD works in red, green, refactor phases. Red phase is obvious because we have red squiggly lines, so we have to fix something in the red phase. And now we want to arrive into the green phase, and then later on we will refactor. And we are going to arrive into the green phase, which is without errors, by creating the actual getConcreteNumberTrivia class. So let's create it under domain use cases here. So new file, getConcreteNumberTrivia.dart. And this will be just a simple class for now, getConcreteNumberTrivia, and it will accept a final number trivia repository called repository into its constructor. So once we import it and create constructor for missing fields and fix import so that they are relative, this is the kind of class we have now. And this is perfectly enough for this test to not complain anymore about non-existent getConcreteNumberTrivia use case. And I probably have a typo here. Of course, getConcrete. So we have to rename that concrete. Now we're talking. So now we can import it over to the test file and we don't have any errors. Of course, we haven't tested anything yet. So let's move on right on to that. The nature of our number trivia app is really simple. So there will not be a lot to test here in the use case, because really all it will do is to just get the number trivia data from the repository, and that's basically about it. It will just get the entity or the failure, of course, from the repository. To start writing a test, you can either just write test and then write should get trivia for number from the repository, or I have a nice little snippet which I have created myself, and that is AAA test, which is the arrange, act and assert test. So this test should get trivia for the number from the repository. And now, of course, we have already the repository instance present in here, which is the mocked instance of the repository. But we do not have the trivia and we do not have a number. So let's create these variables. We want to have final T number, which is the test number, which we are going to try to get from the repository. So T number is equal to just 1. And then final T number trivia is equal to a new instance of number trivia. This is what is going to be returned from the mocked class. We're going to get to all of this in just a little while. So number trivia, we want to have a regular instance of it here. So it accepts a number, which will be the t number, or we can actually just pass one in here. It doesn't really matter. And then the text will be, again, it doesn't matter what the text is. So now in the arrange phase of this test, what we want to do is to provide some functionality to the mocked instance of the repository. So when, and this is really nice, the syntax that is here, because you can really read it as an English sentence and it will all make sense. So when mock number trivia repository get concrete number trivia is called on it with any argument. So it doesn't matter whether or not the number is 1 or 2 or 3. It can be really anything. So any is a matcher. Then answer, because it's asynchronous, so you cannot call then return, but you have to call then answer. And the answer will be asynchronous. And what do we want to answer? Well, the return type of get concrete number trivia is an either, and the right side of the either type is number trivia, and the left side is failure. Well, in the test, it doesn't really matter what we return. We can return really either the failure or the number trivia. In this case, let's return the number trivia. So we want to return the right side of the either type. This is how you really use it. And then later on, you can also check whether or not the side of the returned object is left or right. If it's left, you know that it's a failure. If it's right, you know that it's a successful object returned. So right, let's import darts here. We want to return right t number trivia. So to go through this again, when the mock number trivia repository's get concrete number trivia method is called with any argument, any number, then always answer with the success response, so to say, so the right side of the either with number trivia contained inside of it. All of this is available from the written tutorial, so definitely if you want to learn at your own pace, check that out from the link in the video description. Now we move on to the act phase of the test, which is usually really simple. So we just want to store the result of calling the use case, and we want to call the use case, which is asynchronous. So we want to call await use case dot execute. And of course, there is no such method yet because we have not implemented it, because we are doing test-driven development. So we want to call execute on that use case and pass in the number, the number here. Now comes the assert part of the test. So what do we want to check for? Well, we expect that the result of the execute method on the use case will really be the same thing as was just returned from the mock number trivia repository, because again, the stuff that use case does is really simple. It just gets the data from the repository. And in the case of number trivia app, it doesn't do anything more than that. So therefore, we expect the result to be right. And inside of it, we expect that there will be the number trivia present. And then we also want to verify using the Mockito package. We want to verify that mock number trivia repositories get concrete number trivia was called with the number. This is pretty important because imagine that we pass in the number into the use case. So just to make it more visually concrete, let's pass in number 20. But somehow in the use case, some smart guy decided that he will always pass the number 42 over to get concrete number trivia in the repository. If we did not have this verification here, we would find out about it, of course, because the response would be not correct. But this verification adds another layer of protection to our code against these kinds of errors, which do not just pass the correct arguments to the methods of the dependencies of the use case or any other class there is. So let's again revert back to T number. And finally, we are just going to verify no more interactions are happening on the mock number trivia repository, because once we call execute, the use case should not do anything more with the repository. There is again no point in even running this test because it's not gonna run since it doesn't even compile. We have a compilation error here that execute is not present on the use case. This test really acts like a documentation for the functionality which we are about to implement. So let's jump right into that. We're gonna go to get concrete number trivia and start writing the implementation of execute method. So it will return future either, which contains failure, or number trivia. So we need to import all of these types over here. Once we give this method a name, execute. So let's import darts, let's import failures, and let's import number trivia. Now, based on the test, we know that the execute method should take in a number which is a named parameter. So therefore, we know what we need to do. It will have a named required, of course. So we need to import meta also. Meta.dart required number, which is an integer. And it's going to just call the repository dot get concrete number trivia with the number. And of course, we need to return await whatever was gotten from the repository. So this function needs to be itself asynchronous. All right. So this is the implementation for the execute method. And now all we need to do is to run the test. I have a handy shortcut, keyboard shortcut for running all of the Dart tests. So I will show you how to do that. Just go to, if you are using VS Code, of course, in IntelliJ, this would be completely different, but in VS Code, go to File, Preferences, Keyboard Shortcuts, and now search for Dart run all tests. And for this command, just set some key binding. I have Shift, Alt, and left square bracket. So once you have this shortcut, you can run all of the tests with Shift, Alt, and left square bracket. We have only one test, of course, and it's going to pass. So should get trivia for the number from the repository. This is only a simple test. That's because the functionality of the get concrete number trivia use case is also simple, but it passed. So now we can be confident in our code. And the other way to run a test is to go over to debugging tab here in VS Code. Now tap on this configure or fix launch.json gear icon. Ignore .NET if something like that pops up. And we want to add configuration. So Dart run all tests. All right. And with this configuration present in the launch.json file, you can now select Dart run all tests from the dropdown in the debug tab of VS Code. So once you do that, you can run all tests even by clicking this green start debugging button. And again, it will pass because the same test was run again. Our number trivia app is moving along nicely. In the previous part, we created an entity, repository contract, which is an abstract class, and the first use case, get concrete number trivia, all using test-driven development. Today, we're going to add another use case which will uncover a nice opportunity for refactoring the code. And as usual, be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, all of the links, and go through this lesson at your own pace. First things first, let's refactor this get concrete number trivia which we have added in the last part using test-driven development. So let's actually, in addition to opening this getConcreteNumber trivia file, also open its test file. So over here, you can see that we have a method called execute. But did you know that Dart supports something called Callable Classes? And this is perfect for use cases because when you think about it, if we go over to the test, all that a use case does is that it has an execute method. Wouldn't it be much nicer to just call it something like this? Use case, 2 parentheses, right? Just like a regular method. The execute is really redundant here. Well, this is possible with a method called call. And we are already doing this in the spirit of test-driven development because we have first updated the test code. Now this test code doesn't even compile anymore because there is no such method. And after we've modified this test, we can now move on to the production code. And all we have to do is to rename this execute method to call. It's as simple as that. And now we've made this test to pass because the call method can be either called as a regular call method, but it can be also called without specifying the name of the call method. And now all we have to do is to use the keyboard shortcut for running all tests, which you have hopefully set up in the previous part, or you can also always go here and in the debug tab in VS Code, select Dart run all tests, and it should still pass just fine. All right, but this is obviously not all that we will do in this part, because we also want to add another use case, that is get random number trivia. That's because in addition to getting trivia for a concrete number, we can also get trivia for a random number. And the numbers API we are using for this number trivia app has actually a different API endpoint for concrete and random numbers. So this means we are getting ahead of ourselves a bit because we are not dealing currently with the data sources. We are still in the domain layer, not in the data layer. But just so you know, the numbers API, here is the API URL, so blah, blah, blah.com. And then for getting regular numbers, you have like specified the numbers, so 42, for example, and then that grants you a number. But for the random numbers, you have api.com/random. And it chooses or generates random number for you. So we will not generate random numbers directly in the get random number use case, which we are about to create. We're just going to really, again, just get the data from the repository. Should we have to generate random numbers, that would obviously go into the get random number trivia use case, which we are going to implement in just a bit, because that's actually business logic. Generating random numbers is, really simple business logic, but it's still a business logic. However, we are not going to have to do that because there is a completely different endpoint which does the work for us on the back end, so to say. But before we create the get random number trivia use case, as clean coders, we surely want our code to have a predictable interface. An interface simply means the methods and fields that are public and exposed by classes. So the current interface of the getConcreteNumber trivia use case is that it exposes the call method. And when you think about it, every single use case in our app or in any kind of other app should expose a call method. It doesn't matter if it gets data from a number trivia API or if it sends a space shuttle to the moon or to the Mars or whatever it does, a use case should always have a call method. And one way to enforce such a method or a stable interface of a class is to rely on the implicit, we are going to call it, word of the programmer. Sadly, and maybe it's just me, but I would say that programmers aren't well known for remembering things. Heck, I even watched some of my old tutorials because I've already forgotten how to do things I've made a tutorial on. So I have to rewatch my own tutorials. And with that, there is another way of ensuring that a certain interface is present on a class. And that is through abstract classes in Dart, because Dart doesn't support interfaces, it has only abstract classes. And basically any class can be implemented as an interface. That's something specific to Dart. In Java or in Kotlin, you would have an interface, but in Dart you have abstract class. And that way, when the abstract class, the base class for every use case, will define that it should have a call method, it will be impossible to forget that the method should be called call and instead create an execute method as we did before, because it will be enforced by the abstract class which is implemented. So let's create such an abstract class for enforcing the interface of this class right now. We're going to put it into the core folder under the use cases subfolder, because this applies to all of the use cases across all of the features of our app. That's why it goes into the core folder. So let's create a new file under use cases. We're going to call it usecase.dart, pretty simple. And inside of here, we want to have an abstract class use case. And now bear with me here, I am going to explain everything in just a little while. So it will have two type parameters. The first one is type and then params. So parameters, and this type is the return type of what else than the call function. So as you know from the already implemented getConcreteNumber trivia, the return type should be future, which holds either a failure or number trivia. So we go over here and we are going to call it call. Now let's import it once we've named the function, because before naming the function you cannot import anything. So let's import everything here, but of course it won't return number trivia, but it will return type. Because we are in the core folder, we cannot rely that all of the use cases will work with number trivia. We have to let the use cases which implement this base use class specify their own return type, whatever that may be. The failure can be sort of hard-coded here, so to say. It's not really hard-coded because failure is also an abstract class. Now this params type is something peculiar to this abstract base use case class. It's not all that needed right now because we aren't actually gonna add any functionality to this use case class just yet. So we technically do not need this params. But why it's actually a good idea to leave it in here even though we do not need it currently is that if you wanted to do something with the parameters, so for example this int number is a parameter for the call method, and you wanted to log them in this call, so you would have a call looking something like this. So it would not be completely an abstract class without implementation, but it would have some sort of an implementation. So you would just want to log it, so print. And how would you access the number parameter passed into the call method of the getConcreteNumber trivia? Well, you would have a problem. You cannot access the parameter passed into the concrete class. That's where these params come in. When we specify params, you can now operate with these parameters. And of course, we do not entirely need it just yet. We're not going to be really utilizing it in this app. This is probably the only thing which we are gonna do which we don't currently need. We are not going to follow the you ain't gonna need it principle because we are not really trying to future-proof an implementation, which is a bad thing, but trying to future-proof an interface is actually, in my opinion, a good thing. All right, so now let's go to getConcreteNumber trivia. And we do not need to change anything in the test for this class because we are just really going to only implement use case and specify that the type should be number trivia. And what's up with the params? Well, we know that the params of the call method is just a single integer called number. So we technically could just specify an int here and it would be cool. And then of course, because the parameter in the use case base class is not named parameter and not optional named parameter, we would have to change this to be also non-optional non-named parameter. And let's also add the override annotation for good measure. So that would work just fine. But to make it a bit more clean again, we're going to just create a dumb data holder class, which will be called params. And this will be the case for all of the use cases. And the params class will hold all of the parameters for the call method. So in this case, it will hold only the integer number. So let's create class params, which will extend equatable. So let's import equatable, and it's gonna have just one final int number, and it's gonna be in the constructor, and it's going to be a named parameter. So let's do it like that. Let's make it required. And then let's also pass it to the super constructor of equatable. So super number, what's going on with Dart analyzer? Let's restart it. So super constructor and pass in the number. And now before we modify the code which can be actually tested, because up until now we've been only dealing again with code which cannot be at all tested, we're going to go to the test. And now the use case should be called with params and specify params, which come from the getConcreteNumberTrivia.dart file, and it gets a number. So again, it will be the T number. This does not compile. So let's go to the implementation. We are going to, instead of a number, accept params here, params. And then to make it all work, we are going to call the repositories method getConcreteNumberTrivia using the params.number, which is present over there. Now the test seems to be hopefully fine, but it's not. Oh, that's right, because we have made these params to be a named argument, but in the class, in the production code, we do not have it named. So actually, let's make it not named, because it doesn't really need to be named when there's just one argument params. Naming it doesn't make any kind of sense, it's just redundant. And with that, we have the test passing. We can run it. Or not passing just yet, it's just compiling, but it's also passing, as we can see. It passed just fine. And now we have a stable interface, which every single use case in the app must conform to. With all of this work done, creating another use case for getting the random number trivia will be extremely simple and straightforward. So in the spirit of test-driven development, let's create the test first. So under test and use cases, under the domain layer test, we're going to create a new file, get random number trivia test. And what we can do is to just copy the test for get concrete number trivia. You should never copy code in production, but for tests, that's different. Tests do not really have to be all that refactored. You can have some duplication in tests, but in production code, that's exactly the opposite. Of course, you should strive to not have duplication even in tests, but it's not as bad as with production code. You can have a certain amount of duplication. It doesn't really matter. So it will still have the mock number trivia repository. We are not going to deal with get concrete number trivia, but instead get random number trivia. Again, we're going to get errors right off the bat because this class doesn't currently exist yet, but that's fine because we are doing TDD. Then get random number trivia will accept the repository as a parameter. And when it comes to the test, we do not need the test number because it's going to operate with a random number. We do not need to specify it ourselves. We're going to leave the type returned by the repository to be the T number trivia. That's cool. We're going to also rename the test because it should not get trivia for the number from the repository because there is no number to get the trivia for. It's gonna be gotten for random number. So the test will just say should get trivia from the repository. Then the method called on the repository will not be get concrete number trivia, but get random number trivia, which doesn't accept any parameters or any arguments. And it's still going to return the successful right side of the either, because left side is failure, right side is success, so to say, and this successful side of either will contain the T number trivia. And when it comes to calling the use case, now it gets a little interesting because we have params, right? But get random number trivia use case will not get any params passed in because there's no point in passing in parameters when it doesn't need to know about the number for which it should get the trivia because the number will be generated in the API. So it seems that we can just delete these params from being passed in and we do not get any errors, right? But that's only because the use case is dynamic. That's because the use case doesn't currently exist. So before we continue, let's just create the blank class of get random number trivia use case under domain use cases. So create new file, get random number trivia .dart, and it's gonna be really simply a class get random, which will implement use case, which will return number trivia. And now comes the interesting stuff, because use case's second type parameter is params. So what are we going to specify as the type for params when get random number trivia will not get any params because it doesn't need to get any number for which it should get the trivia? Well, we can create a class no params. And let's just also make it extend equatable, just so that two instances of no params will be always equal because they don't contain any fields. And now we can specify no params here. And now it writes here that we have an error because we do not override one method. And before we implement this method, of course, we are going to finish writing the test. So in the test, we can now see that after we import get random number trivia, we can no longer just have an empty call for the use case because it expects one argument and that will be no params, which specifies that there are no params, of course. The assert part of the test can remain almost unchanged because we still expect that the result will be the right side of the either, so the success containing T number trivia. But what we should verify instead of get concrete number trivia on the repository, it should verify that get random number trivia has been called. And then before we can run the test, which will of course fail completely, we have to get rid of this error that get random number trivia use case cannot accept the repository as an argument for the constructor. So let's go to get random number trivia and let's fix that. We're going to have a repository. Let's actually copy that from get concrete number trivia because it's gonna be exactly the same. So it's gonna have the repository in here. And of course the constructor's name will be get random number trivia. And now this use case test does not have any apparent errors. So we can run it, but it's going to, of course, fail. And if we take a look at that, obviously the failure will be that expected right dynamic, but it received null. That's because we don't currently return anything. So let's actually implement the production code for which we have written this test. So inside get random number trivia, we know that we want to return await. So let's make this asynchronous. So await repository.get random number trivia. And with that, we can rerun the test and it should pass, and it definitely does. So that's awesome. The last thing which we are gonna do is, by taking a look at this noparams class, it's probably a good idea to move it over to the use case core file. This kind of a thing can be shared across multiple features, because surely this get random number trivia use case is not the only use case which will not need any params. So because of that, we're going to cut this no params out of here and paste it over to the use case core file, import equatable there. And now all the code will still hopefully work. We just need to import no params in the test. If we rerun the test, we can see that it still works as it did before. And now let's just fix all of the imports. So we're going to hit F1, fix imports. This is just fix import extension for VS Code. You can find it over here. So Dart import, just download that and you will be able to also convert all of the imports to be relative imports and not absolute imports. And with that, we've just successfully implemented the whole domain layer of this number trivia app, because we have the entity, we have the repository contract abstract class, and we have all of the use cases fully implemented, and what's most important, fully tested. In the next part, we're gonna start working on the data layer, which contains the repository implementation and also data sources. While the domain layer is the safe center of an app which is independent of other layers, the data layer is a place where the app meets with the harsh outside world of APIs and third-party libraries. It consists of low-level data sources, repositories which are the single source of truth for the data, and finally, models. You may have noticed that we always start working from the inner parts of the app and work our way toward the outskirts. After all, we started with the completely independent domain, and even there we first started with the most center thing which there is, and that's the entity. Now we are gonna start with the model and only then go ahead and implement the repository and the low-level data sources. Why is that? Well, the entire clean architecture is predicated on one basic principle, and that is that the outer layers depend on inner layers, as you can see signified by those vertical lines on the diagram, which is right now on the screen. So it makes sense to start at the center, because otherwise we would have really a hard time implementing, for example, the use cases if we did not have any entities with which these use cases could work, right? And the same thing applies to the data layer. We cannot start working with the repository or the data sources, which get data either from the API or from local cache, before we have some models which can convert that data from or to JSON. Because after all, the API will return only a JSON string as the response, and we will have to parse it into some manageable Dart object. And be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video and go through all of the explanation at your own pace. Going from the center of the architecture outwards is only possible because we are using contracts, which in this case are abstract classes, because we are in Dart and Dart doesn't have the concept of an explicit interface. But regardless of how it's called, we define contracts, and that allow us to progress from the center outwards. Because think about it, we have these get concrete number trivia and also get random number trivia use cases already fully implemented, and yet all that we are working with is only a contract of the repository, right? This repository does not do anything real yet. All we did is that we mocked it inside the tests. And speaking of repository, we already know because of the contract how its public-facing interface will look like. It will have two methods, getConcreteNumberTrivia, which accepts an integer, and then getRandomNumberTrivia. And this interface must be fulfilled by the implementation of the repository, which is actually going to do something useful. And this way, by implementing the interface, the use cases can really not care what's going on behind the scenes in the repository as long as it fulfills its number trivia repository contract or interface. They're all cool. But of course, the data inside the repository, which it should then subsequently pass over to the use cases, cannot just be pulled out of thin air. So before creating the repository implementation, we will have to make the remote and local data sources first. And again, we are not going to create their implementations right away. We're going to create just the contracts of the remote and local data sources, similar to how we first created a contract for the repository. But before we can do even that, we have to take care of another thing, and that is a model. Why do we even need a model? Because we already have number trivia entities, so isn't this enough? As I've already briefly explained in a few previous parts, the domain layer should really be completely independent of any outside forces. So that includes JSON serialization and deserialization. Because what if we decide that we no longer want to work with a JSON API, but instead choose an XML API, right? What's going to happen then? We would have to touch the entity which is inside the domain layer here. We would need to touch this class just because we've changed the outside interface, so to say, from JSON to XML. But when you think about it, switching from JSON to XML doesn't really change anything we are interested in the domain layer. It doesn't change the data held inside number trivia. It only changes the mechanism by which we convert some raw data, either JSON or XML, into Dart objects. And this kind of functionality should really not go into the domain layer, but instead into the data layer. And inside the data layer, we are not going to have entities, but we are going to have models which extend entities and add some additional functionality like the conversion from JSON and to JSON on top of those entities. You may have heard the word logic come out of my mouth, and that should immediately start blinking red lights in your head, because logic means we're gonna have to implement the models doing test-driven development, because we cannot write any logic without writing the test for it first. That's the core tenet of TDD after all. So let's go ahead and create a file for the model first under the features, number trivia, data, models. It will be called number trivia model.dart, of course. And also let's create an accompanying test for it, which will be under the mirrored location, so to say. So under number trivia feature data, let's create a new folder models. And we are going to create a new file, number trivia model underscore test.dart. Let's just import Flutter test.dart, and let's start off in the void main. The first test will be kind of a special one, because here it's really necessary that the model will extend the entity class. So number trivia model should subclass the number trivia entity. And we're going to test that with a special matcher. But first, let's create a number trivia model, which will be used for all of the tests inside this file. So we will prefix it with T for test. So T number trivia model. And it's gonna be equal to number trivia model. Of course, this is not going to compile it because we do not have that class. And we're going to be able to set a number on it, just like on the number trivia entity classes. So number will be 1, for example, and text will be test text. Of course, this is not going to yet work, but let's continue on with the actual test. So we want to test that it should be a subclass of number trivia entity. Or actually, it's not called like that, it's just number trivia and entity is just what it is. In this test, it's enough to leave in the assert part of the arrange act assert paradigm of testing. And all we want to check for here is that we expect the T number trivia model to be of type, so is a, and it should be a number trivia. So let's import number trivia here, and we can just, for the fun of it, run this test, but it's obviously going to fail because like it doesn't even compile. So that's kind of obvious. So let's try and implement this test. We're going to go over to number trivia model and let's create a new class, number trivia model, which will extend number trivia. So let's import number trivia here, and inside its constructor, so number trivia model, we'll want to take in the number and the text. So let's just take in the text first, maybe. It will be a required named parameter, so let's put the required annotation here, and we therefore need to import meta.dart, so required string text, and then also required int number. And we do not want to do anything special with these two parameters inside the constructor. We just want to pass them over to the super class, so to the super constructor of number trivia entity. So text will be text and number will be number. All right, now when we try to run the test after we import number trivia model, of course, so now when we run it, it should pass just fine, and of course it does pass, so that's cool. The first actual conversion logic we're gonna implement will be the from JSON method, which should return a number trivia model instance with the same data as is present inside the JSON string, or basically not a string, it will accept a map of string dynamic. So it's already decoded JSON string. But we aren't going to test with the JSON string gotten from the, so to say, live API. Instead, we're gonna create a fixture, which is a regular just JSON file used for testing. That's because we want to have a predictable JSON string to test with. Because think about it, what if the JSON numbers API is under maintenance, right? Even in such case, we still want to be able to run our tests just fine. Or what if we do not have an internet connection? Under such circumstances, we still want those tests to pass, even though we cannot really access the remote API because there is no internet connection. If we go ahead and look at the JSON response from the API, and of course, link to that is in the written tutorial, to which you can get from the link in the video description, this is how the response looks like. There is a regular integer 181, for example, which is also present as the number field, and then there is the text field, which contains the actual trivia, and then two more fields in which we are completely not interested. But we have to watch out for some edge cases of the data which this API can return. And you should always watch for edge cases because that's where most of the problems stem from. If I refresh this enough times, hopefully I will be able to catch such an edge state. Here we go. So for example, this. 1e plus 40 is the Eddington Dirac number. So what is this 1e plus 40? Well, this is just 10 to the power of 40, if I'm not mistaken, in this computery writing of exponents. But either way, regardless of what this number represents, it's really an integer. It doesn't contain any real decimal places, but the Dart compiler will regard this integer literal or number literal as a double, although it's really an integer. So we have to account even for numbers to appear like this one, which is really an integer, but it will be regarded as a double. We're now going to take these responses and freeze them in place, so to say, by creating two fixtures, trivia.json and also trivia.double.json file. So let's just copy this thing here and let's go to VS Code. Fixtures will go right into the core test folder. So let's create a new folder under test fixtures. And inside there, we are going to create a new file, trivia.json. And let's paste this in here. As you can see, VS Code automatically somehow formatted this to remove the plus symbol from here. So it automatically just removes it for some reason. It doesn't really matter. But this trivia.json will not contain this crazy 1e plus 40 number. Instead, it will have just a regular 1, because we do not need these JSON fixtures to really represent real data. It just needs to have the proper structure. It doesn't need to contain actual strings which are present in the API. We can just, for example, say test text, and this will allow us to test with these fixtures more easily. So just always make sure that the structure of the response is always the same in the fixture as is in the real response, but the data can be, of course, simplified as we've done here. But we're going to create yet another fixture, which will be trivia.double.json. And inside here, we again do not need to include this crazy 1e plus 40 just to make it into a double in Dart's eyes. Instead, we can just say something like 1.0. This is still technically an integer because this 0 doesn't do anything. It's still just 1, but the Dart compiler, when it sees it, it's gonna determine that, oh, this is a double, not an integer. So we will arrive in the same situation and we do not need to add any exponents over here or any such craziness. And again, it will just say test text. Now that we have basically these fake JSON responses inside the two files, we're going to have to come up with a way to read these files, because after all, our test code for the model or for any other classes which we are going to test in the future parts, the test code cannot work with files. It needs to have strings. So we somehow need to read this file and output a string out of this content of the file. For that, we're going to create a Fixture Reader, which will be only a simple file containing a top level function. So let's create it under fixtures, Fixture Reader, .dart, and inside here we're going to create just one string returning function called fixture, and it's going to accept a name of the file which should be read, so string name, and we're just going to simply return a file and the location which starts at the root folder of our whole project. So if you look at this, the root folder is this Clean Architecture TDD course in my case. So it's going to start here, and then we need to navigate over to test and fixtures, and then to the name of the fixture, which is gonna be passed into here, into this function. So let's actually first import Dart.io, and now the file will be located under test, fixtures, and interpolated name, and we want to read this file as string synchronously. That's all there is to reading the files as strings from our tests. So let's finally, with all of these fixtures and this fixture reader in place, do some more testing with the number trivia model. We're going to create a new group for the method from JSON, which, as is a custom in Dart, should take in a JSON map, which will be a map of string dynamic, and it should output the number trivia model instance. So let's test. AAA test should return a valid model when the JSON number is an integer. Because remember, in the edge case, so to say, the number will not be regarded as an integer but as a double, and that test will come next. But let's first deal with this simpler case where the Dart compiler doesn't do us any craziness. So in the arrange part, we want to get the fixture to simulate the JSON and convert it to a map string dynamic. So final map string dynamic JSON map, and it's gonna be equal to json.decode because we wanna convert a string to this map string dynamic. So this comes from the Dart convert library, JSON decode, and we want to obtain a string from the fixture which we have just created. So let's import fixture reader.dart, all right. And the name of the fixture will be the one which contains a number as an integer. So that's just the simple trivia.json. So it's this one. We want to get this and convert it to a string using this fixture reader, and then convert it to a map string dynamic using JSON decode. So now we have a JSON map which mimics the actual data which we will get by using the HTTP package by calling the actual live API endpoint. But we aren't calling anything. We are completely within the constraints of our own app. We aren't reaching out to any outside forces. So that's definitely a good thing. You never want to reach to some outside world from within your unit tests, which are for TDD. When it comes to integration tests and all of that stuff, now we're talking a bit differently, but when it comes to unit tests, you should really just test the unit which you should be testing and not really communicate with anything outside of it. So now let's store a result of the from JSON call inside this variable. So we want to call number trivia model dot from JSON. Of course, this is not going to work because we do not have this from JSON method yet. So we want to pass in the JSON map, and we want to expect that the result is the same as the number trivia model. We could also say equals. That would be exactly the same thing. But whenever you just want to say equals, you can always omit it and just place the actual variable to which it should be equal directly inside the expect method. Again, there is no point in running this test because we know it's going to fail because it doesn't even compile yet. So let's go straight off to the number trivia model implementation and let's add the from JSON method, or in this case, it's gonna be actually a factory. So we're going to add a factory number trivia model dot from JSON, which will accept map string dynamic, and it's gonna be called JSON. And here we want to return simply a new number trivia model, which will get its text from the JSON map under the key text. And similarly, the number will be from the key of number. All right. And now, once we run the test, it should pass just fine. And surely the first test of the from JSON group passes. But now we will come to the next test, which is dealing with the pesky edge case where the number will be regarded as a double and not an integer. So let's just copy this test, which we already have here. We're going to paste it below and we're going to change a few things in it. So should return a valid model when the JSON number is regarded as a double. And now we're no longer going to get trivia.json, but trivia_double.json, and the rest can stay as it is now. So let's run the test again, and it's not going to pass because it says here that type double is not a subtype of type int. So we have a casting error. Let's take a look at that. We're going to go to the implementation of number trivia model.dart, and the problem happens right over at this line where we are dealing with the number. So what's happening here? Well, the number is dynamic, but this dynamic type will want to be cast into a number field of the number trivia model, which is of type integer. And whenever such an implicit cast happens, Dart will first determine the type of the dynamic value, because even though it's dynamic, it in fact really has some underlying type. In this case, it's a double. And what's going to happen is that an implicit cast from double to an int fails. So we have to make an explicit cast or explicit conversion. First, we cannot just say to int directly like this, because this is dynamic, it's not really a double. But we cannot first cast this dynamic to double, because what's gonna happen, so as double, is that when this number is in fact an integer, which is gonna happen with this first fixture, for example, right? So trivia.json here, this first fixture, the number is not double, it's really an integer. And after I've run the test with this as double cast here, you can see that now the second test passes, so that's cool, but the first test does not pass, because now it says that type int is not a subtype of double. So we have a reverse problem, right? Similar to how you cannot cast a double to an integer, you cannot cast an integer to a double. So what can we do here? Well, thankfully, really thankfully, Dart has a data type, a basic data type called num. And num can be both an integer and also a double. And because of that, no matter what this number is in reality, casting it to num will always succeed, and then we can always convert it to an integer. So once we run this, all of the tests will pass. And that's definitely a good thing to see. So now we have the from JSON completely successfully implemented, and we can move on to the to JSON method, which will be actually a bit simpler because there is no integers or doubles to worry about, because we control data which is converted to JSON, whereas the data converted from JSON is not controlled by us. So we have to do some more testing with that, but to JSON will be a lot simpler. So again, let's create a group, to JSON, and inside this group we're going to have a test that to JSON should return a JSON map containing the proper data. So what's gonna actually happen here? In the arrange, we are not going to have anything because there is nothing to arrange. Or you could say that we have already arranged something because we already have the tNumber trivia model variable up top of the main method. But anyway, we are just going to act on the tNumber trivia model instance, and we want to call toJSON, which is going to, of course, fail because there is no such method yet, and we're going to put the result into its own variable. And now let's assert that the result is expected to be a map. And let's go over to the trivia.json to see what it should contain. So it should contain text and number fields, because the two other fields are not actually gonna be converted to JSON because they are not present in the model nor in the entity. They are completely ignored. So we can copy just these two fields, text and number, and this should be present inside the map. But this is not all that readable, so let's actually get this map out of here and put it inside its own variable, final expected map. And it's going to be equal to precisely that map. And we can expect that the result is the expected map, of course. And now running the test will, of course, fail because there is no toJSON method. So let's go ahead and implement it right now. ToJSON will be only a simple instance method. So it's going to return map string dynamic. We can copy it from here. ToJSON. And let's just return a map containing text, which will be text from the text field of the class, and similarly number, which will be from the number field. All right. And once we run this, it should, of course, pass. And it does. So from JSON is successfully implemented, ToJSON is successfully implemented, and also we can be sure that the model is the subclass of the entity. Now that we have the model in place, which can be converted from and to JSON, we are going to start working on the repository implementation and also on the data source contracts. Repository is the brain of the data layer of an app. It handles data from remote and local data sources, decides which data source to prefer, and also this is where data caching policy is decided upon. In the previous part, we've gone over the basic structure of the data layer, and today it's time to start implementing the data layer right from its core, from the number trivia repository implementation, all the while creating contracts for its dependencies. You know, interfaces, abstract classes, it doesn't really matter how you call it. What's important is that those things define contracts. And we already have a contract which the repository implementation must fulfill, and that contract is located inside the domain layer. Every repository needs to have getConcreteNumberTrivia and getRandomNumberTrivia methods. This way, the use cases communicating with this repository don't have to really think about how it operates, they just know it has to fulfill this contract. And be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video and go through all of the explanation at your own pace. Now that we have the model in place from the previous part, let's finally create the repository implementation class, or at least we are going to start creating it in this part. It will live under the repositories folder of the data layer. So let's create a new file there. It's gonna be called number trivia repository IMPL for implementation. .dart, of course. And this will be a class number trivia repository implementation, which will implement number trivia repository. So that's the abstract class. So let's import number trivia repository over here. And for now, we're just going to use VS Code to create two missing overrides, which are for the getConcreteNumberTrivia and getRandomNumberTrivia. And even though I am at the risk of sounding like a broken record, I will say it again. The repository needs lower level data sources to get the actual data from them. Similar to how we first created a contract for the repository and we used exclusively that contract, we mocked it in the tests for the use cases, we are similarly going to create only the contracts for the data sources and mock them while testing the repository. But the question is, are data sources enough? Because after all, we will cache the latest number trivia locally to make sure that the user sees something even when he's offline. And to decide whether we want to get some live data from the remote API or we should just get the cached data, we are also going to have a way to find out about the current state of the network connection. And since we want to keep our code as independent from the outside world as possible, we aren't just going to plug any third-party library for connectivity right inside the repository. No, we're going to abstract even that simple network connectivity check into a separate network info class. So before creating the contracts for the data sources, remote and local, let's first create this network info contract. It will go under the core platform folder, which we are going to create right now. That's because this can be shared across multiple features, so it needs to go into the core folder, because checking for connectivity is something which is really not exclusive to the number trivia feature. And it's inside the platform folder because it deals with the underlying platform, of course. On Android, the process of getting network info can be different than on iOS. But of course, we are going to use a library which will just streamline this process into just one method call. But should you not use a connectivity library and you would implement it yourself, you would have probably a bit different code for each platform. So that's why it goes over here to the platform folder. Let's create a new file, networkinfo.dart. And it's going to have just really simple abstract class, because remember, we are just creating contracts in this part, network info. And inside of here, we are going to have one future bool returning method, or actually it's gonna be a getter, but basically getters are also just methods when it comes to how they are implemented. So isConnected will be its name. Now let's move on to the remote data source. The public interface for this remote data source, which will be called number trivia remote data source, will be almost identical to the interface of the repository, meaning that it will also have get concrete number trivia and get random number trivia methods, but the difference will be in the return types. It's not going to return future either of failure or number trivia, but instead it's just going to return a simple future containing number trivia model, and it's not going to be dealing with failures. Instead, it's going to throw exceptions as any regular old Dart code. We're doing this because the remote data source is at the total boundary between our own app code and the outside world of third-party libraries and APIs. So that's why it's going to throw exceptions, and then it will be the job of the repository to catch those exceptions and to convert them into failures. So let's go ahead, and without any further ado, we are going to create a new file under data sources. Let's call it number trivia remote data source. .dart. And inside here we're going to have an abstract class called number trivia remote data source. I know those names are long, but it's still better to have expressive long names than short names which don't really tell you much. So number trivia remote data source. And this thing, we can actually copy the methods from the repositories abstract class, and we can just plug them in here after I hide the sidebar because it's getting in the way. So after we paste them in here, we're going to make them return only number trivia model without the failure. So let's import number trivia model here. And the similar thing will happen for the get random number trivia. So future number trivia model is returned. And let's actually also add some documentation over here. I'm just going to copy and paste it from the written tutorial, to which you can get from the link in the video description if you want to learn at your own pace and also get all of the code. So just a quick documentation here. Documentation in Dart is, by the way, created by using 3 slashes. So this will call the number endpoint for the concrete number, and it will throw a server exception for all error codes. So for example, when usually the successful OK code is 200 for the response, but you all know probably that 404 means not found. So when the response code will be 404 not found, we're going to throw a server exception from this getConcreteNumberTrivia method. And a similar thing will happen for getRandomNumberTrivia. The thing is, we currently do not have any server exception, so let's create it right now in order to use it later on in the tests of the repository. So we're going to create exceptions inside a new file under the error folder. We're just going to call it exceptions.dart. And some people have been asking me whether or not we should pluralize this or make it a singular, so exception instead of exceptions. It doesn't really matter. Like those naming conventions, they can go out of the window. What's really important with this architecture is that you have independent layers, and as long as you follow that, the naming conventions are completely irrelevant. Actually, in the blog posts, I probably use the singular version, so exception, whereas in this video, I am using exceptions, but that doesn't really matter. Don't let that confuse you. So anyway, we want to have a class server exception here, which will extend exception, or actually should implement exception so that we do not have this error saying that there should be some generative constructor. It doesn't really need to be extending exception, it can be only implementing an exception. And similarly, let's just, while we are at this, create a cache exception, which, as you can probably tell, will be thrown from within the local data source whenever some cache error happens. So cache exception goes right over here. And of course, we are keeping this simple by not having any fields inside these exceptions. But of course, you can, in your own projects, create a field final message or string message if you want to convey some more information about the exception. So something like this. We're keeping it simple, so we are not going to have any messages passed around inside the exceptions. And while we are dealing with these kind of errors, let's also create failures, because remember that the repository will catch these exceptions and it will transform them into failures, and then they will be returned using the either type, more precisely as the left side of the either type. So because of that, usually failures map exactly one-to-one to exceptions. So let's just copy these exceptions. Let's go to failures.dart. Let's comment in that these are some general failures. And we're going to have 2 of them here. So this one will be server failure. The bottom one will be cache failure. And they will both implement failure. Or actually, these ones can actually extend failure, because now when we implement it just without extending, we're going to be missing concrete implementation of getterEquatable.props, because we are extending equatable for simplifying value equality should these subclasses contain some fields. All right, so let's get to the local data source, which will be the next data source apart from the NumberTrivia remote data source. Up until now, we've been always dealing about getting data, whether the entity inside the repository or the model inside this remote data source. And this data which we've been getting was always split into concrete and random number trivia. but this will all change with the number trivia local data source. Why? Well, because it's a local data source dealing with the local cache, we will also need to get data into the cache and not only get it out of there. And also we're not gonna care whether we are dealing with the concrete or random number trivia, because the caching policy, which will be implemented inside the repository here in the next lesson, the caching policy will be very simple. That is always to cache and retrieve the last trivia gotten from the remote data source. So whenever we have internet connection, we are always going to cache the lastly gotten trivia locally. So let's go ahead and create a new file under data sources, number trivia local data source. .dart. So it's going to be abstract class, number trivia local data source, which will have again two methods, but this time they will be a bit different as I've already outlined. So the first one will be for getting, but not concrete or random, but just for the last number trivia. So it will return number trivia model, because even the local cache will operate with JSON, because we are going to store a JSON string inside shared preferences in later parts. So this will be called get last number trivia. And let's import number trivia model here. And then also we're going to have future void returning method. So basically it's just void, but it operates with futures so that you can await until it has completely run. Let's call it cache number trivia. And it's going to get number trivia model instance trivia to cache. All right, I am again going to paste the documentation for the first method in here. So this will get the cached number trivia model, which was gotten the last time the user had an internet connection. And in an instance where there is no cache data present, it's going to throw no local data exception, which should actually be called cache exception, because I have renamed it prior to recording this tutorial series. So it's going to throw cache exception if there is no cached data present. And over here you can see why it's not cool to use only some written documentation as the only documentation for your code, because it gets out of sync pretty quickly. Whereas if you document your code with tests, as we are doing usually, the tests are not gonna get out of sync that easily, because if they get too out of sync, they will simply fail and you will have to check out what's going on in those tests, fix them, fix your code, get those tests to pass, and that way you will really never have the test documentation go out of sync. And also notice that neither of the data sources, whether the local or remote data source, contains code which seems to be dependent on some outer layer of the app. For example, the URL of the API will of course have to be a string, yet we get a number as an integer into the getConcreteNumberTrivia method. And also in the local data source, even though we already know that we are going to use shared preferences to implement it, nowhere in here is a mention to something specific to shared preferences or any such things. And also I'm getting ahead of myself a bit, but shared preferences work synchronously, yet we have these futures everywhere. So that's because usually some local cache, for example, Sambast, about which you can check out the tutorial from the card in the corner, works asynchronously. And even though the caching system which we are going to use is not asynchronous, we still pretend like it is. So we are really trying to not get entangled in the intricacies of the outer third-party classes which we are going to be using within these data sources. And this coding practice allows you to really easily swap these low-level packages. For example, in the remote data source, we're going to be using the HTTP package, but with this coding practice of really keeping our code package agnostic, we would be able to swap the HTTP package to something like Chopper very easily without much effort. And if you want to learn about Chopper, which is something like retrofit for Flutter and Dart, you can check out the tutorial from the card in the corner. So let's finally set up the repository, because currently it doesn't have anything very useful in it. It just contains these two not implemented methods coming from its contract. While we are not going to write any actual logic in this part, that's coming in the next one, so definitely stay tuned and subscribe to this channel if you do not want to miss it. We will at least set this repository up to work with all its dependencies we have already created in this part. And since we are doing test-driven development, we will also prepare the test file for the next part. So let's actually create the test right now. It will again be a mirrored image of the lib folder. So we want to go over to test, then mirror the implementation file. So we want to go to data, new folder repositories, and now new file within the repositories test folder. It will be called number trivia repository impl test. .dart, of course. And let me just steal some of the imports from some other test file, for example, from this get concrete number trivia test, because we again need Mockito and Flutter test. And we know that the repository should take in all of the classes which we have created in this part. So that is the remote and local data sources, and also the network info object. Because we are inside a test file, which we are preparing for the next part, let's create mocks for all of these dependencies right off the bat. So class, the first one will be mock remote data source. It will extend mock, and it will implement number trivia remote data source. All right, so let's import everything we need. Now let's copy this, and down here we are going to have mock local data source, which will implement number trivia local data source. And finally, we are going to have mock network info. So let's again paste that below. Oh, so mock network info extends mock and implements network info. So let's import that. And now once we have all of these mocks in place, we're just going to set up the main method of this test for the future part. So what do we want to have here? Number trivia repository should be inside this test. Or actually its implementation. So this will be called repository. And let's import this class. And then we are going to have all of the mock instances in here. So mock remote data source, we're going to call it mock remote data source. Then mock local data source will be called mock local data source with a surprise. And finally, mock network info will be called how else than mock network info. So now inside the setup method for this test, we are going to set it up so that the mock remote data source will be equal to a new instance of mock remote data source. Similar thing will happen with the local. So mock local is equal to mock local data source. And finally, the mock network info is equal to mock network info. All right, and the last step in here will be that the repository should be equal to number trivia repository impl, which should be able to take in all of these three dependencies. So they will be done as named parameters. So remote data source should take in the mock remote data source, not local. But of course, it does not work because currently there are just no such parameters inside the constructor for the repository. But let's actually finish up. So this will be local data source, should take in mock local data source, and finally this will take in the mock network info called network info. All right, and now it's not really a test, but it would definitely not even compile because these arguments cannot be taken into the repository's constructor. So let's go ahead and add all of the needed fields and constructor parameters over to the number trivia repository. So let's create a final number trivia remote data source, and we are just going to copy those names from within the test file because they are pretty long here. So final number trivia remote data source, then similarly number trivia local data source, it will be called local data source, and finally we are going to have final network info called network info. Let's import everything we need here. So all of the classes will get imported. Let's fix the imports so that they are relative, not absolute. Now let's hit Control and dot to create constructor for final fields, at least within VS Code. And what we want to have here is that the constructor will not have them as required unnamed parameters, but instead we want to have required named parameters. So let's put the add required annotation everywhere, and we need to import meta. So let's go ahead and do that. Meta.dart will be imported, and now this required annotation will be present before each and every parameter. And now if we take a look at the number trivia repository implementation test, it does not pass because we are not really testing anything yet. That will come in the next part, but surely we can now create the number trivia repository implementation with all of its needed dependencies, which is definitely a good sign. So there's already quite a lot to digest from this part because we have created 3 contracts for the repository's dependencies, namely the remote data source, local data source, and also network info. And because we always implement things from the inner parts outwards, in the next part we are gonna implement the repository, and then only later on are we going to implement these data sources and network info. After the previous part, we now have all the contracts of the repository's dependencies in place. Those dependencies are the local and remote data sources and also the network info class, which will allow us to find out whether or not the user is online. Mocking these dependencies, which we've already prepared a bit in the previous part, will allow us to implement the repository class using test-driven development. So again, if you need a refresher from the previous part, we have the mocked dependencies, remote, local data sources, and also the network info inside the test file, but overall the test file does not contain any tests. All it contains is the repository, which is set up with all of its proper dependencies. And in this part, we are going to fully implement the repository so that the functionality of get concrete number trivia and get random number trivia will not be just return null. And be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video and go through all of the explanation at your own pace. Let's first start out with get concrete number trivia. And as you know, it's the job of the repository to get fresh data from the API when there is an internet connection. And then also we are going to cache it locally whenever we get it from the API. But also when we find out over here that there is no internet connection, we're going to get the cached data so that the user will always see some trivia displayed on the screen. So therefore, getting to know the network status is the first thing that should happen from within getConcreteNumberTrivia, which we are currently implementing. So let's write a test where we are going to describe this functionality of first checking if there is an internet connection. For that, we're going to use the mocked network info, which has a method or a getter called isConnected. So we are going to mock this isConnected getter. So let's create the test, or actually a group first, because we want to group our tests based on the tested method. So this one will be getConcreteNumberTrivia, because that's what we are testing. And we are going to test using the arrange, act, assert pattern, so to say. So it should check if the device is online. So how are we going to do that? Well, in the arrange part of the test, we need to tell the mocked network info to always return true for isConnected. So when mock network info dot isConnected, whenever this is called, we want to always answer because it's asynchronous, returning a future. Whenever you return a future, you need to call then answer and not then return. Then return can only happen from non-asynchronous, so synchronous functions. And we want to answer with an answer containing true. So it will be async true. All right. Then we want to act. So we want to call the repositories method that getConcreteNumberTrivia, and we need to pass in a number. And again, we could just pass in some integer literal like this, but to keep our tests manageable, we are going to instead create a variable for it. So final tNumber is equal to 1. And while we are at it, let's also create all of the other variables which we are going to use throughout the tests. So we will also need final tNumberTrivia model, which will be equal to NumberTrivia model. So let's import it if we can, which will contain a number of tNumber from the above variable, and then text will be test trivia. And then let's also create final tNumberTrivia, which will be the entity, which is going to be equal to tNumberTrivia model, because remember that model is only a subclass of the entity, so we can make it be the entity once we of course provide a type of number trivia like that. Now this tNumberTrivia model will be cast into the entity type. Alright, and now with all of this set up, we're going to use the tNumber for calling the repositories method. And what do we want to check for here? Well, we want to just verify that the mock network info isConnected getter has been called. So let's run the test now. And we can see that, of course, it fails because nothing happened inside the actual implementation of number trivia repository implementation. So let's fix that. We are going to, as it says in the test, call network info dot isConnected. That's it. Let's run the test again. And it's going to pass. That's all we are going to do in order to pass this test. You should never write more code than is sufficient for the test to pass, even though what we've written really seems like nothing much, right? It doesn't do anything useful. We're going to make it into something useful with tests, which we are going to write later on in this part. But for now, all we want to do is to make this test pass, and this code sufficiently makes the test pass. So we are not going to do any more implementation for now. Now, as you already know, the functionality of the method will differ based on whether or not the device is online. So we're going to create two subgroups basically inside the getConcreteNumberTrivia test group, one for the device being online and the other one for being offline. So let's create a group first for the online functionality. So device is online, which will have a setup method in which we're going to set up the mock network info to always return true. So we can copy the line from the above test, and this setup method only applies to the tests within the device is online group. We can actually right now create another group, device is offline, just so we don't forget about it. And from there we are going to return false. And this setup only applies to the device is offline group. So this way we do not always need to set up the mock network info in each and every test inside the online or offline group. We can do it just once here. So what is the first functionality which we are going to test for in the online group? Well, whenever the device is online, the repository should return remote data when the call to the remote data source is successful. So test, or actually AAA test, that's my code snippet which I use for all of the tests. And here we should return remote data when the call to remote data source is successful. All right, and notice that the naming or the string within the test is always in the following format: should do something when something. So always should, action, what it should happen, and then when the circumstances are fulfilled. In the arrange part now, we're going to mock the remote data source. So mock remote data source, and whenever getConcreteNumberTrivia with t number is called, or actually we can just do any with any number is called. It doesn't really matter for the mock with which number it is called. We're going to verify the proper number calling in the verify in the assert part. So then answer, and again we're going to answer with async, and we're answering with the number trivia model, because that's what should be returned from the remote data sources method. Future containing number trivia model. So we are returning our instance of the model which we have set up above here. So now in the act, what should happen is, of course, we are going to call repository.getConcreteNumberTrivia for t number, and we will actually want to store the result of this call inside final result is equal to this call. And then this is where we are going to verify that the remote data sources method for getting concrete number trivia has actually been called with the proper parameter. Because what could happen is that we pass, for example, 1 to the repository, but the repository decides to get concrete number trivia from the data source for the number 20 or something like that, some crazy number, right? We mustn't let that happen. So because of that, we're going to test whether or not the remote data source was called with the proper number in the argument. So we want to verify mock remote data source that get concrete number trivia that it has been called with the same t number. And then we also expect that the result from calling the repository will actually be equal to the right side of the either type, because repositories return either a failure or the actual thing which we want out of it, and number trivia is on the right side of the either, left side is reserved for the failure. So we want to check that the result is the right side of either. So let's import darts in here, and it should contain t number trivia, not the model anymore, but instead the actual entity, because while the data sources return models, the repository should cast it into being an entity which does not have the to.json and from.json conversion methods, because it's in the domain layer, not in the data layer after all. And here we can omit this equals, as we've been doing in the previous tests. But here I think that when you are already dealing with something like this, which contains a right side and left side, like the either type, it's beneficial to just place the equals explicitly in here, so that when we are reading this test, we immediately know what's going on and not have to guess like what we are expecting here. We're expecting it to be equal, so let's put it explicitly here. All right, now when we run this new test, of course, it's going to fail miserably. So let's go ahead and implement it right now. In the implementation, what we should do, if we check out the test again, we should return remote data when the call to remote data source is successful. So what we should do is just return the right side of either containing remote data source dot get concrete number trivia for the same number. That's important, and we of course need to await it. And let's also make this function asynchronous, therefore async, and with that we no longer return null from here afterwards. And again, this is all that's needed to make this test pass, hopefully. And it does not pass. That's interesting. So let's see why it does not pass. It writes here that, what? Of course, that's right. Expected the right side of either, but instead gotten future. That's because we have not awaited over here for the result of the repository call, because after all, the either type is wrapped inside a future. And if you do not await the future, you just get the future instance. But if you await it, it's going to be unwrapped, and it's going to be the either type as we should expect here. So let's run this test again. And now it's going to pass, and surely it does. The next test in the online group should be for checking if we actually cache the data locally when the call to remote data source is successful, because we will always cache every single number trivia which comes out of the API, so that whenever there is no internet connection, we can always show the latest number trivia to the user. So let's actually copy this test, paste it below, and we're just going to change a few things in here. So should cache the data locally. So the thing which it should do will change. Cache the data locally. And the circumstances of the test remain the same when the call to remote data source is successful. So that does not change. So the mock remote data source will again return t number trivia model. That does not change. We are again going to call the repository here to get concrete number trivia. We actually do not even need to store its result, because we are not going to expect anything in here. Instead, we are just going to verify a second thing in here, that the mock local data source dot cache number trivia has been called with the t number trivia model. So running this test will again fail miserably, because there is no such caching going on right now. So let's go ahead and implement it. So we're going to store the result of the remote data source call inside an intermediary variable. So final remote trivia, and let's set it equal to that call. And then we're going to return write remote trivia, which is the model which we've gotten from the remote data source. But also we want to cache this number trivia model instance in the local data source. So cache number trivia, and the trivia to cache is remote trivia. All right, now when we run the test, it's going to pass. So things are going nicely, but nowhere are we handling exceptions and returning them converted to failures, right? So that's what we need to test next. We need to be able to handle the server exception, which is thrown by the getConcreteNumber trivia from the remote data source. So let's test that right now. Let's again copy the first test in the online group. We're going to paste it below. And now we should test that it should return server failure when the call to remote data source is unsuccessful, which means it throws an exception. So instead of answering with the number trivia model from the data source, we are instead going to then throw, and we want to throw the server exception. Make sure you instantiate that. So let's throw server exception. And what should happen? Well, the result should no longer be of the right either type, but of the left, which will contain a server failure. So let's import failures.dart. And also we want to make sure that nothing is cached, because there is nothing to cache after all if we do not get a proper successful response. So we want to verify 0 interactions on the mock local data source. So nothing, no methods should be called on the local data source whenever there is an exception thrown from the remote data source. So let's test it again, and it's going to fail, of course. So let's go ahead and implement it. We need to wrap this code inside try catch. So try, all right, let's highlight all of that. We're going to move it upwards, and then on server exception, we are going to return left server failure. All right, but we need to import exception. For some reason, VS Code does not want to cooperate whenever you are inside this on clause of a catch statement, basically. So we are going to import it manually from exceptions.dart. All right. Now when we run the test, it should pass. And it does. So that's cool. This means that now we are going to move over to the offline group, because when the device is offline, we want to return the cached data. And I just want to remind you that you can get all of this code and go through this lesson at your own pace from the written tutorial on resocoder.com, and the link is available from the video description. All right, so let's create a new AAA test here. And I should probably make a nice VS Code extension providing you with these code snippets. I will see what I will do. So if you want them, you can also create code snippets yourself if you really want to, or you can also write all of these tests manually without these snippets. But regardless of that, this test will test the functionality of should return last locally cached data when the cache data is present. Because if it's not present, of course, the cache exception will be thrown, and we will need to handle that somehow. Of course, by converting the cache exception into cache failure, but that will come only in the next test. For now, let's concentrate on when the cached data is actually present inside the cache. So in the arrange part, we want to mock the local data source. So when mock local data source, get last number trivia on it is called. We want to answer with a sync and arrow function here, which will return simply again t-number trivia model. We are still testing the getConcreteNumberTrivia on the repository, so we are going to steal this call from the method above, or from the test above to be precise. So we again call repository getConcreteNumberTrivia for the test number, and we store the result inside the variable. And now we want to check that there are no interactions with the remote data source, because after all, if we are online, nothing should happen with the remote API. So verify 0 interactions mock remote data source. Then we want to verify that actually the mock local data source dot get last number trivia has been called once. And then we're going to expect, and we are expecting that the result is equal to right side of the either type, containing again t-number trivia entity. So let's test it. Of course, it's going to fail again, but this test is really groundbreaking because it will actually make us do something useful with this value of network info is connected. Because now, in order to have different functionality for when the device is online and different for when it is offline, we need to provide an if check here, checking with the value of is connected, which we of course need to await first because it's asynchronous. And when we are connected, we're going to do whatever we've done before. And of course, because we have written test for this functionality when we are online, now whenever we rerun the tests and should something break because we have added this if statement, we're going to get notified by the tests failing. Of course, no test will fail because we are not doing anything really special with refactoring or with changing the code. But whenever you are changing code and you have tests in place, you can be really confident that nothing will break, because if something breaks, you can always revert back to the code which you had before modifying it. And you are immediately going to know if you broke something because the tests will fail. So that's definitely awesome when it comes to test-driven development. So else here, if we are not online, we just want to call local data source that get last number trivia. And we of course need to return it from this method. So we could return it either directly by passing it into the right side of either, but actually I am immediately going to put it inside its own separate variable. Final local trivia is equal to that, and now we're going to return right local trivia. So let's rerun the test, and now the device is offline group should be passing, but still we are not yet handling the cache exception. So let's do that right now. We're going to create another test. So let's just copy that, paste it below. And whenever the device is offline and when there is no cache data present, cached, it should return cache failure. Or I guess we can also write it like cache failure as the type is written, so cache failure. So what should happen here? Again, we are going to throw, so then throw, we want to throw cache exception and also instantiate it over here. We are again going to call getConcreteNumberTrivia on the repository. And now we want to still verify 0 interactions with the remote data source. It should still indeed call local data source get last number trivia, but the result should not be equal to the right side of either, but instead left side, and it will contain cache failure. All right, let's test it again. It's going to fail. That's because we need to wrap this code inside try catch again. So try, wrap this in here, move it up, and then catch, so on cache exception, we are going to return left cache failure. Now let's rerun the test, and it's going to pass. Alright, now this part is already getting quite a bit long, and it would be really exhausting to implement the getRandomNumber trivia in the same way as we implemented getConcreteNumber trivia, especially because getRandomNumber trivia will really differ from the ConcreteNumber trivia in only one call, precisely in one call, and that is that we are not going to call getConcreteNumber trivia from the remote data source, but instead getRandomNumber trivia, and that's basically the only difference there will be. So while test-driven development really says that you should never write more than one test, let it fail, then implement the functionality until the test passes, and only then you can move on to another test, we are going to break that in the name of keeping our sanity in check, because really when you are dealing with such similar functions, there is really no point, I think, in test-driven development like from the scratch. You still want to write tests though, so we are going to test fully even this getRandomNumber trivia method, but we are just not going to do it bit by bit, because the difference between this code, which we have already implemented, and the getRandomNumber trivia will be absolutely minuscule. But first, let's actually refactor even the test, because as you can see, we have these groups. Device is offline and also device is online. And we're going to do the same device is offline and online groups even for testing the random number trivia. So let's put this grouping code inside its own function. So let's just copy that, and above all of the tests, even above the group here, we're going to create void run tests online, which will accept a function body, and here we're just going to paste that group code over here, and after the setup we are going to call the body function. So let's just invoke that. Now we're going to copy run tests online, paste it below. It will be for running tests offline. So offline, and instead of true, we're going to return false, obviously, from the mock network info is connected. And now we're going to use these helper functions instead of setting up all of this group code. So where we are writing group device is online, we are going to delete the setup, delete the name of the group directly from here, and instead call run tests online. And similarly, we want to have run tests offline here. So again, remove the setup code, remove the name of the group, and let's say run tests offline. And we can now check, of course, because we are doing test-driven development, if what we've currently refactored, the test code, will not make our production code broken. So let's test it. And hopefully we have not broken anything. Surely we didn't, so that's cool. We can now move on to getRandomNumber trivia. Actually, as I've said, we're not going to do it bit by bit, because I think you would get crazy, I would get crazy, we would all get just complete craziness out of implementing it bit by bit. So let's actually copy the whole getConcreteNumber trivia group. Let's copy all of it, all the way down, and we're going to paste it below, and we're going to change the code bit by bit, but it will be much faster than if we had written all of the tests bit by bit. So getRandomNumber trivia will be the group name. Of course, we no longer need tNumber because it will be for random number. So we do not need to pass in any number to the calls to the repository. So instead of t-number, in the t-number trivia model, we are going to specify some random number, for example, 1, 2, 3. And now, should check if the device is online. We are no longer testing for the getConcreteNumber trivia, but instead getRandomNumber trivia, which does not accept any number. So that's it. That's it for the test. And of course, we should now run the test, implement the functionality needed for this test to pass, and only then go ahead and write all of the other tests. We are now going to do it like that because of reasons. All right, so now run tests online. Should return remote data when the call to remote data source is successful. So that's still true. But instead of remote data source getConcreteNumber trivia, we are going to mock getRandomNumber trivia, still returning t-number trivia model. Repository will call getRandomNumber trivia. And we're going to check for getRandomNumber trivia being called on the remote data source. And the rest can stay the same. Then next up, should cache the data locally when the call to remote data source is successful. Still, this is true. So getRandomNumber trivia will be called on the data source. It will be also called on the repository. And we should verify that it has been called on the data source. All right, the next test should return server failure when the call to remote data source is unsuccessful. So again, getRandomNumber trivia, getRandomNumber trivia instead of concrete. And again, we're going to check for what else than getRandomNumber trivia. And again, all of this code is available from the written tutorial, to which you can get by clicking on the link in the video description. It's boring, I know, but sometimes development is really boring. So I'm not going to skip this just because it's boring. And next, we are finally getting to run tests offline. So should return last locally cached data when the cached data is present. All right. So getLastNumber trivia, this call will not change because remember that local data source does not distinguish between random and concrete trivia. It treats them all the same. So we are going to call getRandomNumber trivia on the repository, and the rest of the test can hopefully stay the same. Then should return cache failure when there is no cache data present. Of course, we are again going to call getRandomNumber trivia on the repository, and the rest can stay the same. And now let's run the test. They're going to fail, all of them. So getRandomNumber trivia, everything is failing in here. Of course, that's expected sort of. But look what we are going to do right now. We are just going to copy all of the contents of the getConcreteNumber trivia, paste them into getRandomNumber trivia. Of course, we need to make this async. And look what's going to change. Only this call. We are not going to call getConcreteNumber trivia, but instead getRandomNumber trivia. And that's really it. So let's rerun the tests. And they should all pass, and they do. So everything is working just fine. Really what we changed was just this one single call to the remote data source. And if we look at it now, I myself at least get seizures because the code duplication is just tremendous. Every single bit of code in here is completely duplicated between these two methods, except for this single call to the remote data source. So how are we going to solve this? Well, we are going to solve this with beautiful higher order functions, which Dart provides to us right out of the box. So let's create a private method called getTrivia, which will return similar to all of these public methods. It will also return future of either failure or number trivia called getTrivia. And what we want to do in this method is somehow return the same thing as from the getConcrete or getRandomNumber trivia, but we should be able to change this line of code, basically, this thing here, the call to remote data source. We should be able to change this to either call getRandomNumberTrivia or getConcreteNumberTrivia as we wish. So as I've briefly mentioned a few moments ago, we are going to do it with higher order functions. What we could do is to define a function right over here. So function which returns future number trivia. It could also return number trivia model instead of the entity, but we can also just cast it right away. Let's call it getConcrete or random. And of course, we also need to indicate that this function does not take any arguments in. And now we can just call this getConcrete or random in place of actually calling concrete or random. So we are going to decide on what is called here from the calling methods of getRandomNumberTrivia and getConcreteNumberTrivia. You'll see in just a bit if you are not yet sure what I'm talking about. So we're going to call getConcrete or random, this higher order function. And now from within the public methods, we are just going to simply call return, await, getTrivia, and pass in the call as a function. So that's an awesome feature of Dart, that it supports functions as first-class citizens, so to say. I hope I said it right. But anyway, regardless of how this functionality of a programming language is called, we can pass in a function to a function, as you probably already know because you are a Flutter developer after all. So we are going to return remote data source from here. Because we are within the random number trivia method, we are going to call getRandomNumberTrivia, and that's it. Now we can copy this, paste it into getConcreteNumberTrivia implementation, and in here we are just going to call getConcreteNumberTrivia and pass in the number. All right, so now we have refactored the code quite a bit, and we may or may not be sure that it's going to work as it did before. Thankfully, we have all of the tests in place, so to check whether or not we have broken something, we can just run the tests again. So let's run them, and they all pass, so we know that this refactoring did not break anything. But I am just going to refactor it even further because, as you can see, this getConcrete or random is really just completely ugly, this function definition within a method parameter. So what we are going to do is create a type def. Type defs in Dart currently only support type defing, so to say, functions, but I have already seen on the GitHub for the Dart language that they are working on type defs for all types. So you would be able to give a nickname to, let's say, list. If you wanted to make list of int be called int list, or something like that, you could do that with the feature type defs, which is currently being implemented in the Dart language. Currently, this is not possible with anything but the functions. So what we want to do with the type def right now is to create it above the class. So type def, and it's going to be for a function returning a future containing the number trivia. And let's just call it concrete or random chooser, and with an underscore so that we cannot use this type def from other parts of the code, only from within the number trivia repository implementation file. So concrete or random chooser. And it's not going to accept any arguments. And now we can use this concrete or random chooser name in place of this monstrosity. And immediately we know what we are talking about. So let's run the tests again. And even with this type def, the tests still pass. So that's cool. All right, so this part was quite long, but we finally have the repository fully implemented. And next up, we're going to start working on the lower level parts of the data layer. So implementing data sources and the network info class. Now that we have the repository implementation in place, we're going to implement its dependencies, starting with the network info class used for finding out if the device is currently connected to an active network. This part is where we will finally do test-driven development with third-party packages, which means we are going to mock third-party classes. Let's jump right onto network info. As usual, we already have the network info contract or abstract class already done, so we can open it up and we can see that network info implementation should have one public getter is connected. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, all of the links to different libraries, and overall go through this lesson at your own pace. Now, in the second part, I told you that we are gonna use the connectivity package to find out about the network status, and actually we already have the connectivity package imported inside pubspec YAML, so here it is. However, we are not really going to use connectivity because of some findings which I have found out. While the package is definitely useful for determining if the device is running on mobile data or on Wi-Fi, it's not that great to check for an actual internet access, as it writes actually right on the package page. Note that on Android, this does not guarantee connection to internet. For instance, the app might have Wi-Fi access, but it might be a VPN or a hotel Wi-Fi with no internet access. So basically, the user could still be connected just to a local network, to LAN through Wi-Fi, and we would not be able to find out. We would still regard him as having internet access, all the while we would just get exceptions because we would still not be able to access the remote numbers API. So that's why we're not going to use connectivity, but instead we're going to use data connection checker. So here we go. This is the package which we are going to use. So actually, while we are here, let's just copy this thing, and I'm going to explain how it works in just a bit. But let's just for now replace completely the connectivity package because we are not going to use it at all with this data connection checker. This package does not rely on the underlying platform at all. It does not check if the Android device or iOS device is connected to a Wi-Fi or to a mobile network. No. What this thing does is that it opens a socket to a certain address or addresses, multiple ones, and determines the real connection status based on whether it can actually connect to some IP addresses. And also because of this, it's completely platform independent, so it's going to run even if you were doing Flutter web development. And now let's actually take a look at what the data connection checker package does. If we are going to open the dependencies tab, at least in Visual Studio Code, and go to data connection checker, open it up, and scroll somewhere, we can see here that here are the default addresses to which it tries to connect to determine if the device is connected actually to an active internet connection. And those addresses are Cloudflare, Google DNS, and also Open DNS. So let's just say that these three services combined have a 100% uptime because after all, it's Cloudflare, Google, and Open DNS. So you should not be worried regarding if the online status of the device will be truthfully determined because really these three servers here, they will always be running. Also, now that we know that we are not going to use the connectivity package, so that means we are not going to really access the underlying platform for checking connectivity, it's also wise to rename the platform folder to network. So let's just do that. And also with that, we have broken some code. So we need to go to repositories and rename platform to network. And also do the same in the test file. So let's go over to number trivia repository test, and all the way upwards, we're going to rename even this import. And now we are good to go. We've renamed the folder because it really doesn't make sense since it doesn't access any platform at all. So to implement network info, let's first create a test file for it, again under a mirrored location, so to say. So it's going to be under core, then network, so new folder, And inside of that, we're going to create a new file called network info test.dart. And over here, we again want to just import all of the usual packages. So let's go to some other test here, for example, repositories test, and let's just import Flutter test and also Mockito so that we do not need to type out those imports once again. And how will the network info class find out about whether or not we are connected to internet? Well, it's going to have to depend on the data connection checker. So let's also import here data connection checker here. And we're going to create a mock for it because it's going to be passed into the network info implementation as we are already used to. So class mock data connection checker, which will extend mock and implement data connection checker. And this thing will be also instantiated inside the void main. So let's create mock data connection checker. Mock data connection checker will be its name. And then let's also actually create the network info implementation variable, which is currently, of course, not gonna be able to be imported because we have not yet created it. But let's move on. Let's continue with the setup. So in the setup, we will want to, of course, instantiate the mock data connection checker to be a new instance of it, and then pass it over to network info implementation instance. So let's do just that. Now, in order to make these tests compile, we are going to go over to network info, and we are now going to create a separate implementation file like we did, for example, for the repository, where we have the repository implementation in one file, which is in data, and then the contract is in another file, which is over inside the domain layer. We're now going to do that with network info because it's really just in the data layer. But of course, because it can be used across multiple features, it's also inside the core and not inside the feature folder. But basically, we are going to create the actual implementation right below the contract. So let's create a class network info IMPL for implementation, which will implement, of course, the network info from above. We will need to have one override, which will be for the is connected. And finally, we're going to add a dependency so that it can be passed in this final data connection checker. So let's import it. After we call it connection checker, we should be able to import it, and surely we can. And now we're just going to create a constructor for final fields. And here we go. Now the test compiles after we import the network info implementation, of course. Since the network info has only one property is connected, we're going to have only one test. And this test will be really simple. It may seem that it's not necessary, but I'm going to explain why it actually is necessary and why you should test even this kind of simple functionality. So we're going to have group called isConnected, and inside the group's body, we're going to have only a single test. So let's add it. It will be the AAA test. So this isConnected property should forward the call to data connection checker that has connection, because the data connection checker actually really has connection property. So all this isConnected will do is basically nothing, because it will just get its value from calling another single property on another class. So what are we going to do here? Well, inside the range, we are going to do something very, very interesting. Of course, first we are going to set up that when the mock data connection checker, which is the dependency of our network info class, has connection is called on, that it should answer. But what should it answer with? Well, the is connected, as it writes here inside the test, should forward the call to data connection checkers has connection property. So how can we test if a call is only forwarded? Well, has connection is a future returning function, and this future contains a boolean. So what we would usually do here is that we would say then answer async, and we would answer with, for example, true, just for testing purposes, right? And this would return a new instance of future, which we would then be able to await. Then usually we would get the result from calling the actual network info implementation that is connected. Actually, let's just rename this network info IMPL to just network info to keep it simpler. So we would call our own network info is connected, right? And we would of course await it. This is what we would do usually. We are not gonna do it this way, but let's just follow along for a while, and then I will show you how we are actually going to do it. And then, as usual, we would verify. So verify that actually the mock data connection checkers has connection property has been called, and then we would expect that the result is true. Because of course, if the is connected should only forward the call to data connection checkers has connection, when the has connection returns true, the result of the is connected of our own class should be also true, right? So fair enough, that's pretty simple. Let's actually just run the test. It's going to fail again, which makes sense. And let's also implement it. So we're gonna go over here to network info, and its implementation will be connection checker that has connection. We do not even need to create an async here and await it, because we can really just forward the call so that even the future will be the same returned. We're not going to await it here and create a new future. We can just return the same future, which comes from the has connection call. So now when we test it, it's going to pass, right? So, I mean, this is fair enough. But what we can also do here is that if we are really clever and we are really trying to break our code, we can also just call has connection, not do anything with it, and then return true, for example. Of course, wrapped inside a future. So future value would be true. And now when we run the test, it's again going to pass, because we have actually followed everything which the test has prescribed. We have called has connection, so this verification returns like it's good. Then the expected result is in fact true. So what's up with that? Well, now we have two options. We can add another test, which will test when the mock data connection checkers has connection returns false. And in such instance, our own is connected property should also have the false to be the result. So we would need to basically just duplicate all of this test code, and that's just not cool. But the another option, what we can do is not to duplicate the test code, but to actually really check if the call is only forwarded and nothing more. We can do that by storing the returned future inside a variable. Let me show you what I mean by that, because this can be really confusing at first, but it's not going to be confusing anymore. We are going to create a final T for test, so T is just the prefix, has connection future. This will be equal to future.value true. And now what we are going to do, which is the important step here, is that we're not going to return async true from here. Instead, we're going to return or answer with T has connection future whenever the has connection property is called on the data connection checker. So we're going to answer with a future for which we have a variable which stores it. And now we're going to utilize the Dart's default referential equality for our good, because usually we want to override the referential equality with packages like equatable so that it becomes value equality. But here we are actually going to really use it for our benefit, because now we can check if the result is the T has connection future, and we're going to also remove the awaiting of the future. So the result is no longer a Boolean because we are not awaiting the future to complete. The result is now a future holding a Boolean. And this future, if the call is truly only forwarded to has connection on the data connection checker dependency, the resulting future should be the same as the future returned from the has connection property. In other words, those two futures are really just the same future, the same object, so to say, pointing to the same location inside the memory. So now what we actually cannot do is run successfully the test with what we have just created this monstrosity over inside the implementation file, because the test will no longer pass because the future instances will not be the same, right? We're creating a new future instance which points to a different location inside the memory after all. So now really the only way which this test can use to successfully pass, or this implementation rather, to successfully do what the test prescribes, that's the better description of what we are trying to do with test-driven development, is that the isConnected should really just forward the call to has connection. And now when we run the test, it's going to pass again. All right, now you may be saying that why are we doing things like this? Why are we just hiding one call, really just one single call behind a custom class with a custom contract? Why are we not just going to plug in the data connection checker directly into the repository implementation and call it a day? Why do we need to create a network info class? I know it may seem that this call forwarding is just a waste of effort, but it's quite the opposite, because imagine that you wanted to swap the data connection checker package for something completely different. If you use the data connection checker package classes right inside the number trivia repository here instead of the network info, and chances are if you are building more advanced app, you will have many more repositories than just one number trivia repository. So you would basically stick this data connection checker third-party class into multiple places throughout your code base. So if you wanted to swap that package and use something different, you would need to change a lot of code, and you would also need to retest that connectivity checking code because it's contained in multiple different places, so you don't know if those tests will work again, and you would need to just change a lot of production and also test code in order to make sure that the app works as before with the data connection checker package. But if you hide the data connection checker package or whatever other package you have under a custom contract and also under a custom implementation of that contract, now if you decide that, oh, I'm not going to use data connection checker package anymore, I'm going to implement it myself, or I'm going to use completely something different, now what happens is that you have just one point at which you have to change the code should you decide to swap the data connection checker package. So that's really beneficial. In the next part, we are going to fully implement the local data source, for which we also have a contract already. So it will be able to get last number trivia and also cache number trivia into the cache, which will in our case be shared preferences. The next dependency of the repository is the local data source used for caching data gotten from the remote API. We're going to implement it now using shared preferences. There are plenty of options to choose from when it comes to local data persistence, but as I've said, we're going to implement the local data source using shared preferences. That's because we do not store a lot of data. After all, we are just caching a single number trivia instance. We can take a look at that actually inside the repository. We are just caching one instance. Always whenever we get data from the remote API, we cache it inside the local data source. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. We already have the contract for the local data source in place. So let's now set up the test file for creating the implementation of number trivia local data source. Let's go to test, then data sources, and under that, let's create a new file, number trivia local data source test. .dart, of course, and these names are really long, but they are descriptive, which is better than short and non-descriptive names. Now, let's open up another test so that we can just import some things which we need. For example, I've opened the wrong test, but for example, the repository test should contain Mockito and Flutter test. So let's import that so that we have it even inside number trivia local data source test. And as usual, we are just going to start out with setting up the actual test so that we will pass the dependencies, which in this case are shared preferences, into the implementation class, which we have yet to create. So let's create a class which will be for the mocked shared preferences, which are going to be a dependency of the local data source. So mock shared preferences, which will extend mock and implement shared preferences. So let's import shared preferences.dart, which we have already added to our pubspec.yaml file a few parts back. Now, inside the main of the test, inside void main, we of course want to hold the instances of number trivia local data source implementation, which we are about to create. So IMPL for implementation, which will be called simply data source. And then also we want to have an instance of mock shared preferences. Let's just call it mock shared preferences. And now inside the setup, we're going to set it up so that the number trivia local data source implementation will get its dependency passed into the constructor. So let's first construct the mock shared preferences like that. And then let's also construct the non-constructible yet number trivia local data source and pass in the mock shared preferences. With this setup, we now know how the number trivia local data source implementation class should look like, at least what it should take in inside its constructor. So let's jump into number trivia local data source file. And again, we are now going to create a separate implementation file, but we are just going to create an implementation class below the contract, just so that we do not have a bunch of files which are not all that necessary. So let's create a class number trivia local data source implementation, which will implement number trivia local data source contract or abstract class. So now we can also just hit Control Dot in Visual Studio. In IntelliJ, I think it's Alt and Enter, and we're going to create two missing overrides. So now we have not implemented, but at least it's fulfilling the interface. And what we are now going to do is, of course, set up the constructor, which should accept an instance of shared preferences. So let's actually create an instance of it here. So final shared preferences. Let's import shared preferences package. And now we're going to create constructor for final fields. And let's just, for good measure, make this named, optional, but also required. And because we are saying required, we also need to import meta package. So let's import meta.dart. All right. And let's fix all the imports so that they are nicely ordered. And with that, now the test should be not passing, but at least the setup of the test should be good to go. Of course, only after I change the parameter to be named. So shared preferences, we can move on to the first actual test. First, we're going to focus on the getLastNumberTrivia method, and actually let's move it upwards so that it's first, similar to how it's first inside the contract. Let's just make it also appear first inside the implementation class. All right, so let's focus on this. Calling this getLastNumberTrivia method should return number trivia model. Of course, only given that it has been previously cached. If it was not cached before, so for example, if the user opens the app for the first time, we're going to throw an exception, which we are of course handling inside the repository. As you can see, if you remember from the previous parts, we are handling it right here, cache exception. But the question is, how are we going to store and then later on also retrieve number trivia models inside shared preferences? Well, we cannot just store a class inside shared preferences just like that. We have to first convert it to JSON. And good thing is that we already have a tested implementation of toJSON and from JSON methods on the number trivia model, because we are using that. We're going to be using it also when we get data from the remote API. We're going to also convert it from JSON, and we're going to do the same thing when we get the data from the shared preferences, where it's also going to be stored as JSON. So now we have to have a way to test with some JSON, because we have to test that calling getLastNumberTrivia will really convert the JSON string present inside shared preferences into our beautiful number trivia models. And you already know from the previous parts what we have to do whenever we test with JSON. We're going to test with fixtures, and we already have some fixtures from the previous parts. If we take a look at the test folder, over in fixtures, we have trivia_double.json and trivia.json. But can we use these fixtures inside the test for number trivia local data source? Because now we are using these fixtures for the test of the model, right? If we take a look at that, we are reading the fixtures here for the model. Well, the thing is, we could use them even for local data source tests, but that's not really a good practice. It's not going to break anything, but still we should strive to keep our tests as close to real data as possible. If we take a look at the model, which is going to be converted to JSON, which is going to be stored inside the preferences, we can see that the toJSON method of the model outputs only two fields, text and number. So this is what's gonna get stored inside the shared preferences. If we take a look at the fixtures which we currently have, they, in addition to text and number fields, they also have the found and type fields. This is going to be returned from the API, but it's not going to be present inside the local cache, in this case shared preferences. Similar thing goes to trivia double, and also of course the double will get converted to an integer before it's stored inside shared preferences, because of our logic which we have inside the from JSON method. The model will only store integers, not doubles. This is all from the previous part, so if you need a bit of a recap, just go and rewatch those parts regarding the model of the number trivia. Because of this, to really keep it as close to real data as possible, we're going to create another fixture which will be containing only the text and number fields. So let's actually copy this trivia.json fixture and let's create a new file, call it triviacached.json, and paste that fixture JSON in here, and we're just going to simply remove the font and type fields. I know it's not all that necessary because of how we've set up the from.json method of the model, but still, just to be safe, you should always keep your data as close to the real one as possible. Now that we have this fixture all set up, we can finally move on to test the getLastNumberTrivia method. So we're going to do test-driven development as always. Let's first create a group inside a test file for the getLastNumberTrivia method. And inside it we're going to have the first test, which will be again arrange, act, and assert kind of a test, saying that getLastNumberTrivia should return number trivia, or we could also say number trivia model, but it doesn't really matter what kind of a thing we say inside the test. From shared preferences, when there is one in the cache. Because of course, when there isn't a cached number trivia inside the cache, we are going to throw an exception, but that will come in the later test. So let's just focus on when everything is nice and dandy and everything is present inside the cache. Under such circumstances, we're going to arrange the mocked shared preferences. So when mocked shared preferences dot get string, because the number trivia models are going to be stored as JSON strings, and now we need to provide a key for the string. And when we are just mocking it, we are going to say that any string. And when a string with any kind of a key is gotten from the mocked shared preferences, we're going to return, not answer, but return, because getString does not return a future, it returns a string directly. And we're going to simply return a fixture. So let's import our Fixture Reader, beautiful thing, which we have created in the previous parts. And we're going to read a fixture, the cached trivia, so trivia cached.json. Now we can move on to the act phase of the test, in which we are going to store the result of the getLastNumberTrivia call inside a final result. So let's await and call data source.getLastNumberTrivia. And now, what are we going to check for? Well, we first have to verify that we've actually gotten the number trivia, the result, from shared preferences. So we are going to verify that we've called something on the shared preferences. So mock shared preferences dot get string, and the string which we've called should have a precise key, and we should be getting a string containing the cached number trivia. We're then going to use this key also inside the implementation file. And after we've checked for that, we also expect that the result equals. And what should this result be equal to? Well, it should be equal to the number trivia model converted from the trivia cached JSON fixture. So what are we going to do? Well, of course, we're going to set up a final variable inside the group. We're just going to call it tNumberTriviaModel. And it's gonna be equal to numberTriviaModel. Let's import that class over here. And we're just going to say from JSON and read it from the very same fixture which is being returned by the mocked shared preferences. So those things should be equal. And of course, this fixture call returns a string, so we also need to convert it or decode it to a map, because from JSON accepts a map of string dynamic, as you can see. So we're just going to call json.decode this fixture string, and also let's import Dart convert from which the JSON comes. And now we're just going to expect that the result is equal to the T number trivia model. So after running this test, it's of course going to completely fail. So let's go ahead and implement it inside the implementation file. We're first going to get the JSON string from the shared preferences. So final JSON string is equal to shared preferences, which is passed into the number trivia local data source implementation class, dot get string, and we should get the same string as we have specified inside the test. So let's just for now copy the key from the test file and paste it into the production file. And now we have the JSON string, and we have to realize that we have really the JSON string and not the future, because getString and all of the other methods of shared preferences are completely synchronous. They do not return futures. But the problem is that our interface of this class expects us to return a future of number trivia model, not a number trivia model itself. This is because probably all of the other local persistence packages work with futures asynchronously, and it's just that shared preferences are probably the only one which works synchronously. So we have kind of future-proofed our interface to work with other packages outside of shared preferences as well. And the way we can convert a value to a future is by returning future.value. It's that simple. And now the value should be the number trivia model converted from this JSON string. So let's just say number trivia model from JSON, and we're going to say JSON.decode, and we're going to decode the JSON string. So let's import .convert even to the implementation file. And now let's run the test again. And now it should in fact pass, and it does, which is definitely a good thing. So we've gone from the red phase, where the test does not pass, over to the green phase, which is signified by this green check mark, which means that the test passes. And now we're going to refactor our production code, because I really do not like to pass around some magical strings. Let's just put this cached number trivia string over to a constant. So we are going to extract this string and create a constant above the class. So const cache number trivia is going to be equal to cache number trivia string. And now we're going to use this constant in place of the string literal inside the getString call on the shared preferences object. And in fact, we can also go over to the test file and change this to use also the nice constant instead of the string. And I know that this refactoring was really trivial, but still we have to retest our code just to make sure that it still passes. And it does, of course, but if you are doing some larger refactorings, it may as well not pass. So make sure that always after you refactor something, you rerun all of the tests. Now let's move on to the next test, because of course, we're not just going to always have some instance cached inside the shared preferences. It can also happen that there is nothing inside the shared preferences, in which case we will throw a cache exception. This will usually happen when the user first launches the app, in which case the shared preferences will simply return null when we try to get a string from it. And this could lead to many problems and also possibly an app crash. And you definitely do not want to greet your first time user with an app crashing on him. So definitely this is a really important test which we are about to implement. So let's just copy this previous test and paste it below. Oh, I just see that I have a typo here. It should not be should return number trivia. The should be there only one time, of course. And this next test should throw a cache exception when there is not a cached value. So instead of mocking the shared preferences to return fixture, we're going to make it return null because that's what in fact happens whenever you try to get something from shared preferences which is not present there. Now, because we are trying to test for an exception, we are not going to store the result here or do something like that. Now we are trying to test if an exception is thrown from the getLastNumberTrivia method. So we can remove the verify call because we no longer need to verify that since it's already verified above here. We could also leave it in there, but it doesn't really matter. And now we want to expect not that the result equals some value, but we in fact have to check that this call throws, so throws a is the matcher, throws a, and it should throw a type matcher cache exception. So let's import cache exception over here, and probably also the matcher package. So let's just do that. Above here we're going to import matcher.dart, and this should fix this error. And what are we going to do here? Well, again, we are going to store the method actually inside the reference, inside the variable, which will be called call. So this call is in fact a reference to a function which returns a future number trivia model. And now we're going to expect that calling this method from a higher order function, so call, throws this cache exception. We could of course just also call the getLastNumberTrivia directly from the expect like that, but it becomes quite messy and quite long. So I just like to always create an intermediary variable which holds the method, and that intermediary variable is called call, which we then call from the expect. All right, so let's now run this code. Of course, it's going to completely fail, and let's now go ahead and implement it. So what we want to do here is that we are of course going to check for the null value of this JSON string. So basically, if this JSON string doesn't equal null, we are going to return this future.value and convert the JSON string to number trivia model. Otherwise, we're going to throw a cache exception. So let's just do that. And let's import cache exception, of course. Now let's rerun the test, and this time it should pass. And this is basically it for the getLastNumberTrivia, because it's all that it will do. Return a number trivia model or throw a cache exception, which is then subsequently handled inside the repository, which of course converts it to a cache failure, which is returned not through a special kind of data flow of exceptions, but is returned as a return value of a method. That's what the repository is doing. But because we do not depend on the repository from the data sources, we do not care at all what the repository is doing. And that's the beauty of clean architecture. You can always work on just the piece of code that you are working on currently, and you do not need to worry about all of the other places from which the code will be executed, worry about side effects. No, you just do not care because everything is so nicely separated. Now we're going to move on to the next method, which is cache number trivia. This will be for putting data into preferences. So let's create a test for that. We're going to create a new test group, cache number trivia. The cache number trivia method should call shared preferences to cache the data. So let's create a test, which will be actually an AAA test, should call shared preferences to cache the data. And this is actually really the only thing which we can test for, because we cannot test if the data is actually present inside the preferences, at least not in a unit test. But of course, with the power of mocks, we'll be able to verify if the data passed into the preferences is the correct data, which should be passed over there. And then we have to just rely that the shared preferences package is written correctly and that it will cache the data properly. and then it will be also able to retrieve it properly, but that's outside of our control. What we can only control is if we pass the correct data into the shared preferences, and that's it. So because we really cannot test if the shared preferences contain something, we're just going to remove the arrange part completely, and we're only going to act. And we're going to act by calling data source cache number trivia, and now we have to provide a trivia to cache. And of course, we're going to create a variable final t-number trivia model, which will be equal to number trivia model. But this time, it's not going to be from JSON. It's not going to get converted from a fixture, but instead we're just going to create it ourselves. So number will be 1 and text will be test trivia. We could also just create it from a JSON fixture as we are doing in the previous test, but that will not be the case with the actual implementation, because the implementation of cache number trivia will get an already converted instance of the model. So let's just keep it as close to the real code as possible and instantiate it using a constructor and not the from JSON factory. So the trivia to cache is this precise t-number trivia model. And now inside the assert part of the test, we will want to verify if the mock shared preferences was called with the proper JSON string. Because after all, setting a string, so calling set string, with the proper key, of course, which is cached number trivia, should happen with the same data as is present inside the number trivia model instance here. So the value of the string being cached inside the shared preferences should be the JSON representation of this t-number trivia model, which is being passed in to the cache number trivia call. So let's create a final expected JSON string, which will be equal to JSON again dot encode, because we are trying to encode a map over to a string. So we will just call t-number trivia model dot to JSON. And now we're going to verify if the set string contains the expected JSON string inside its call. All right, so let's run the test. And of course, it's going to fail. Now we can, of course, go and implement this test. So inside the implementation, we're going to call shared preferences dot set string, and we're going to set it at the key of cached number trivia. And the value will be, of course, again, JSON.encode trivia to cache, which is the parameter dot to JSON. All right, now let's just somehow keep this nicely formatted. And if we now try to run the test after I format it even more, so let's rerun the test. And it's going to pass. We can cache number trivia successfully, or at least we can call the shared preferences set string successfully. Whether or not it's actually cached somewhere, that's the thing which shared preferences has to take care of. But we also have a warning here, because this method returns future void, but doesn't end with a return statement. Well, we could also change this to void, but just to keep it returning a future, let's just return this shared preferences set string call, which actually returns a future bool. So that's interesting. I didn't even know that. So setting a string returns a future, but getting a string returns not a future. Well, that's definitely interesting. But anyway, if we now even rerun the test after we have added the return statement, so we have to rerun the test, everything still passes, which is definitely a good thing. So in this part, we implemented the number trivia local data source doing test-driven development. And now we have only one part of the data layer remaining, which is the remote data source. Of course, we're going to implement it in the next part. The last remaining part of the data layer, for which we currently have only a contract, is the remote data source. This is where all of the communication with the remote numbers API will happen, for which we're going to use the HTTP package. And all of the implementation of this remote data source will of course be done doing test-driven development. As always, we already have the contract of the number trivia remote data source, so we know that it should have two public methods: get concrete number trivia, which accepts a number, and also get random number trivia. And actually, we are already even providing a documentation here saying that the first method, get concrete, should call http://numberapi.com for a particular number, while the get random number trivia will call basically the same URL but with a random endpoint. And both will be, of course, get requests. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. So now, as usual, let's create a test file for this production file. So let's scroll down to the test folder under features, number trivia, data, and data sources. We are going to create a new file, number trivia remote data source test. .dart. And let's jump into the local data source test just for a while, which we have implemented in the previous part. And let's just grab the Mockito, matcher, and all of that good stuff, even Dart convert. Let's just grab all of the imports in here. So all of the imports, we're going to copy them, paste them into the remote data source test. And of course, we aren't going to need shared preferences, neither the local data source file, but otherwise we're going to need everything. And while we are at it, let's also import the HTTP package as HTTP. We are first again going to set up the test file so that we know which kind of dependencies should be passed into the number trivia remote data sources implementation. And of course, the dependency which is going to be passed in is an HTTP client. So let's mock it because we are inside the test file. So we're going to create a class mock HTTP client, which will extend mock and implement http.client. And now inside the main method, so void main, we are going to first get hold of the number trivia remote data source instance, or rather its implementation, which currently does not exist. So let's create number trivia remote data source. Let's call it data source. And also an instance of mock HTTP client will be held inside its own variable. Let's just call it mock HTTP client as usual. And then inside the setup, we are going to instantiate the mock HTTP client first, and then subsequently pass it over to a newly instantiated data source implementation. So let's pass it in, and it's going to be a named parameter client, and let's pass in the mock HTTP client. Of course, we first need to create such a class with this kind of a constructor which can take in an HTTP client. So let's do just that. Over inside the remote data sources production file, we are going to create number trivia remote data source implementation class. So just suffix it with impl, which will implement from number trivia remote data source, which is its contract. Now, because it's implementing from the contract, we also need to provide two missing overrides, which we're just going to leave empty for now with these to-do comments. Of course, we are going to get them all implemented by the end of this tutorial. And now we know that the constructor should be able to take in an HTTP client. So first, let's actually import HTTP package as HTTP. So we can just copy it from the test file, paste it in there. And now we're going to create final http.client. Let's call it client. And this thing will be inside a constructor. So we are going to populate it, but we want it to be a named parameter. So let's wrap it inside curly braces. And also let's provide the required annotation, which of course has to be imported from the meta package. So let's import meta, and let's also fix the import so that they are properly sorted. And now this test will be set up properly. All right, we can move on to the first real test, which will test the functionality of getConcreteNumberTrivia. And of course, similar to how there was a lot of overlap between concrete and random number trivia methods inside the repository, which was implemented in the 6th part, the same will be true now as we are implementing the remote data source, because there will be really a lot of similarities between the concrete and random number trivia methods. This means that once we have the getConcreteNumberTrivia all properly implemented, getting random number trivia will go like a breeze. So let's first really focus on the first getConcreteNumberTrivia method. So just to recap, we are working with the numbers API, and in this case we are gonna be calling the concrete number endpoint. So if we take a look at how the response looks like, for example, for the number 42, even inside the browser, just call numbersapi.com/42. And the problem with this response is that it's plain text. But of course, we do not want plain text, we want JSON. That's what we are preparing to work with from the start, because like we have the number trivia model, which can convert JSON to our Dart object. So how can we get JSON? Up until now, we've been providing a query parameter JSON. And when we call it like that with the JSON query parameter, we're going to get out of the API a JSON response. And of course, we could do it like that even from within the app, but there is another way, and that is to pass the application JSON content type header over to the API together with the request. So that's what we are going to be doing. We're going to be passing in some headers. And since it's very important to get the headers and the URL just right, we are going to create a test just for testing if we are calling the HTTP package with the proper URL and header. So let's create a new group under our main method, which will be for the concrete number trivia method. So get concrete number trivia. And inside this group, we are going to first create a final T number, which will simply hold the number for which we are going to be trying to get the trivia, because we are operating with a concrete number after all. And the first test will test that the getConcreteNumberTrivia should perform a GET request on a URL with number being the endpoint, because if we are inside the random number trivia method, the endpoint would be simply /random, but now we want to have the endpoint be / the concrete number. And what's also important to test is that the header will be application /JSON. So should perform a GET request on a URL with number being the endpoint and with application /JSON header. Right, that's a really long name for a test. And actually, we can make this a multi-line string because it doesn't fit the screen at all, at least not when I have the text enlarged for tutorials. So we can make this a multi-line string here by doing triple single quotation marks. And now we can break this string apart somewhere in the middle. So number being the endpoint, now it's going to work just fine, and we can see everything properly on the screen. So in the arrange part of the test, we want to mock the mock HTTP client. So when mock HTTP client dot get, and since we are only mocking this right now, we are arranging things. The URL can be any kind of a URL, but also it's important to have headers, which will be any headers, any named headers. This is just a thing with Mockito and named parameters. You cannot just say any for a named parameter like that. you have to say any named and provide the name once more, because just Dart is written in such a way that Mockito cannot infer the name of the parameter. That's sadly how it is. But regardless of that, whenever the get method is called on the mock HTTP client, we want to answer with an answer containing an HTTP response, which comes from the HTTP package, of course, so response. And the response class's constructor takes into its constructor string body and then a status code. Those are the two necessary arguments which we need to pass in. And the body of the response will of course be from a fixture, because we get a JSON response and we already have JSON fixtures. So let's do just that. We're going to read it with the Fixture Reader, which we have already imported. And the name of the fixture will be simply trivia.json. We are also going to make the response be successful, so the response code will be 200. Now inside the act phase, we are not interested in storing the response inside a variable. All we want to do here is just call data source.getConcreteNumber trivia with the t number. And then what we want to check for inside this first test is only that the mock HTTP client has been called with the proper URL and with the proper headers. That's it. Other checks will come in the test which we are going to write in just a little while. But for this test, we just simply want to verify that mock HTTP client.get was called with the URL http://numbersapi.com/ and then interpolate t number, because we are trying to get trivia for a concrete number after all. So we need to pass in that number. And then, of course, as I've said, we could do something like JSON, but no, we are going to instead pass in headers. So let's say headers, which is a named parameter, and it's going to be a map. The name of the header or the key of the map will be content type, and its value will be, of course, application JSON, because by default it is text plain, and we do not want text plain, we want application JSON. And with that done, after we format it properly, of course, once we run the test, it's going to fail completely. So let's open up remote number or remote data source here. We can see that everything has failed. So let's implement it now. We are simply going to write as little production code as possible for the test to pass. That's always what you should be doing with test-driven development. So we are not going to return anything. We are not going to convert the JSON to number trivia model. We are just going to call client, which is the HTTP client dependency, .get, and the URL will of course be, let's actually copy it from the test. It will be just like this. So the URL will be not for t number, but just for the number parameter passed in. And the headers will of course be the same as we've done in the test. So content type application JSON. And now when we test this, it should pass. And it does, so that's cool. You may be wondering that since we aren't doing anything with the response, we are not returning it, we are not even putting it inside a variable, why do we then need to provide a mocked functionality for the get method even inside this first test? Because we are making this get method return a response containing a fixture and a 200 response code. It's true that this mocking is not needed for this test. If I comment it out and run the test again, it will pass just fine. The thing is that inside the subsequent tests, this would cause a lot of problems. That's because as we add functionality to the method implementation, not arranging the mock HTTP client to return a valid response object would cause all kinds of errors, because a method on a mock which is not set up to return anything will always return null. So calling HTTP client.get from the first test would return null if this was not present here, if this was, for example, commented out. And in such an instance, what would happen that if we store this inside final x and then we try to get something from the x, because after all, it's a response. So we can check if x.response code, of course, we need to await it and provide async. So we can now check for response code or status code actually. So for example, is equal to 200. But what would this cause inside the first test? Well, it would of course cause a null pointer exception because x would be null. So that's why we are providing a mocked implementation for the get method even when we do not necessarily need it in this first test. All right, so now let's revert this method back to how it was previously. Remove the async, or actually we can leave the async in here. That's not going to change any functionality of the method. Now let's move on to the next test, because we also need to test if the return model will of course contain the proper data. So when everything goes smoothly and the status code is 200, the model which is returned from getConcreteNumberTrivia should contain the data, which is the same as from the fixture here, from the trivia JSON fixture. So let's create a new instance inside the group called tNumberTriviaModel, which will be equal to NumberTriviaModel dot from JSON, and we want to decode a JSON string. So JSON.decode, and we're going to decode this fixture. So let's copy it and paste it down there. And now we can use this tNumberTriviaModel inside the next test, which we are about to write. So it will again be an AAA test. It should return number trivia when the response code is 200. Otherwise known as success, of course. The arrange part of this test will be the same as of the previous test, so let's just copy it and paste it. We're going to return a fixture trivia.json with the response code 200, or status code. Inside the act phase, we are going to again call data source getConcreteNumberTrivia, but this time we are of course going to store it inside final result. So let's again call await here, because this call is asynchronous. And now inside assert, all we want to do is expect result equals the variable which we have just created above inside the group. So tNumberTriviaModel, because of course, if the response contains trivia.json fixture, the data inside the model returned from the data source should be the same as if we directly instantiate the model from this fixture inside the group. And of course, we could have joined these two tests together, so we would have just one long test. But of course, it's not just bad to have long production methods, it's also bad to have long tests. So you should always try to keep your tests as small as possible to test only the smallest amount of functionality that they can. So now let's go ahead and implement this test. We're going to store the response inside final response and of course await it. And then we are simply going to return NumberTriviaModel from JSON and pass in a decoded version, which will produce a map. So JSON decode, let's import .convert, and we're going to pass in the response's body. All right, so now when we run the test, it should pass. And it does, so that's cool. Finally, we mustn't forget to account for a case when something goes wrong. For example, if the response code is not 200, but 404 not found or some other error code. In such a case, a server exception should be thrown, which then is subsequently handled inside the repository. Whenever a server exception occurs, we handle it and return server failure through the left channel of the either. So let's create a new test, which will be again arrange, act, and assert test that the method should throw a server exception when the response code is 404 or other error code. Basically, whenever it's not 200, it's going to be erroneous. So we again want to mark the HTTP client, but this time it's just going to answer with simple something went wrong. It doesn't really matter what we put in here. And of course, the status code will be 404. And since we are again testing for the method throwing an exception, we are going to just store the method inside a variable. So final call, just like in the previous part. And this call variable will be equal to data source dot get concrete number trivia method. And now inside the assert part of the test, we're simply going to expect that from a higher order function passed into expect, which in turn will call the method, which we are storing inside a call variable. And this call requires us to pass in the test number. And this thing, calling of get concrete number trivia, should in this case throw or actually throws is the matcher. And the thrown exception should be of type server exception. So we are going to add a type matcher, which will have a generic parameter server exception. All right, now let's test this. And it's going to fail, of course. So let's go ahead and implement it inside the implementation file. We're simply going to check if the response.status code is equal to 200, in which case we are going to return what we are returning now, the number trivia model converted from JSON. And otherwise, if it's some different status code, for example, 404 or something different, we are going to throw server exception. So let's import exceptions.dart and rerun the test. It will pass. But let's go back to the test file and talk about being a bit dry. That's right, even the tests require us to show some respect to them by keeping them dry. In other words, we should not repeat ourselves. Do not repeat yourself is the acronym for dry if you're not familiar with that. And as you can see, we are surely repeating ourselves because we have the same setup of the mock HTTP client in the two first methods. And since we are also going to be testing for the get random number trivia method, and tests inside that group will be very similar to the tests inside this concrete group, this duplication would be even more prevalent. Because of that, let's move this mock setup into a special named function right inside this void main. So we're going to just cut it out, this code of setting up the mock, and below the setup, we are going to create void setup mock HTTP client success 200. And with that, we can now just paste the code which we have cut out over to this method. And we're going to call this method from the arrange part of the first test and also from the second test. So let's just do that. And while we are at it, we are also going to extract the functionality of setting up the mock even from this server exception test, because we are going to do the same thing from the random group. So let's just copy or actually cut out even this. And we are going to create another method, which will be called setup mock HTTP client failure 404, and just paste that cutout code over to there. And now we're going to call this method from within the last test. And of course, all of this code is available from the written tutorial, to which you can get from the link in the video description. Let's now move on to the getRandomNumberTrivia method. Similar to when we were implementing the repository in the 6th part, the difference between the concrete and random methods will be really minimal. In fact, all we will need to change is the endpoint being called. Instead of this number, we will simply call random. And that's it. And because of this immense similarity between the concrete and random methods, I hope that you will forgive me for not fully following the test-driven development practices of first writing only a single test and then implementing it, and only then writing another test. I'm again just going to copy and paste all of the tests for the getConcreteNumberTrivia and modify them to work with random number trivia, just to keep your sanity and not to make this tutorial so long that nobody will even watch it till the end. Oh, and of course, because we have modified the tests, just now I have realized that we have now retested. Because we have refactored the tests, we should retest if everything still works, and of course it works, just to be safe. So back inside the test file, we're just going to copy the whole group for the getConcreteNumberTrivia, and we're going to paste it below and call it getRandomNumberTrivia. And we are basically just going to replace any reference to concrete numbers with random numbers and random endpoints. So random number trivia will be here. Of course, we are not going to need the T number here because we aren't going to be calling a number endpoint for a precise number. Instead, from this first test, we will want to verify that the mock HTTP client was called with the random endpoint. And of course, inside the act phase, we do not want to call getConcreteNumberTrivia, but rather getRandomNumberTrivia. And the headers and all of that will stay the same. And we are still going to respond with the same success response as we did from the concrete test. Now moving on to the test below, it's going to be absolutely the same. We're just going to change the call to be to getRandomNumberTrivia. Otherwise, we are not changing anything. And the same goes here. Inside the last test, where it should throw an exception, we're going to call, or actually get a reference to the getRandomNumberTrivia method, which doesn't accept any arguments again. And that's basically it. So just let's run these tests. And they are all going to fail, of course. But once we go over to the implementation and just copy the contents of getConcreteNumberTrivia implementation and paste them into the getRandomNumberTrivia method, which we of course need to make asynchronous. And now we just change it to not call the number endpoint, but rather random. And now we run the tests again. They're all going to pass. So that's basically it. But of course, this code duplication is horrible and we can make it much cleaner. This time, getting rid of the duplication will be actually a lot simpler than it was inside the repository, because now we are just passing around a string. We do not need to pass in some method references or anything like that. So let's just create a new private method returning a future number trivia model. Let's call it with an underscore because it's private, get trivia from URL. And it's going to accept a string URL. And of course, it's going to be async. And inside of here, we are going to just copy and paste the content of the random method, for example, but instead of passing in a URL explicitly, we are rather going to pass in the URL from the parameter over to the call client.get. And now we're going to get rid of the bodies of the getRandomNumberTrivia method. We can actually get rid of the async keyword as well. And we're just simply going to call getTrivia from URL and pass in the random URL, which I should have probably copied, so that doesn't matter. Let's just copy it from the method above, and the URL will be simply /random. And of course, after we add a semicolon at the end, that's really it to this method. And now, similarly, inside the getConcreteNumberTrivia method, we are going to delete the body of the method together with the async keyword, and instead we are going to call getTrivia from URL and pass in the URL with the interpolated number. And with that, we can now rerun the tests, and they should all still pass because we have not changed the functionality, only we have removed the code duplication. So we are moving along pretty quickly. We've just finished the whole data layer, and with the domain layer already implemented, the only thing which remains is the presentation layer. In the next part, we're again gonna keep the tradition and start off from the center of the presentation layer, which is the BLoC, or in other words, the presentation logic holder, because of course you are not just bound to be using BLoC with clean architecture. Presentation layer contains the UI in the form of widgets and also the presentation logic holders, which can be implemented as a change notifier, BLoC, reducer, view model, mobXstore, you name it. In the case of our NumberTrivia app though, we are going to use the Flutter BLoC package to help us with implementing the BLoC pattern. So now we have the whole data layer implemented. In the last part we finished with the NumberTrivia remote data source, and now comes the time to create the files needed for the BLoC, which will go into the presentation layer. But before creating the files and classes needed for the BLoC, it's a wise idea to hand over the repetitive work of creating all of those files over to some extensions in the case of VS Code, or plugins in the case of IntelliJ or Android Studio. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, links to the libraries, links to the extensions, and also go through this lesson at your own pace. So we want to search for BLoC and just make sure that this is installed. The first one, not the second one. I don't know what that even is, but the first one from Felix Angelov, this you should have installed. And also, if you want to find out which extensions you should definitely have as a Flutter developer, check out the video from the card in the corner. In addition to adding the option to create new BLoC files in just a few clicks, this extension also adds a bunch of code snippets which you can use. So definitely that's also a good thing about this extension. Let's now move on and create new BLoC files inside the presentation folder. Actually, we now currently have the BLoC folder, which is empty inside the presentation folder, but we are going to delete it because it's gonna get created by the BLoC extension. So let's just delete the BLoC folder, move to trash, yes, and we're going to right click on presentation and select BLoC, new BLoC. We're going to give it a name. In our case, it's gonna be called number_trivia, all in lowercase, of course, and we're going to select that we do want to use equatable, and it's going to create a new BLoC folder with 4 files: NumberTrivia BLoC, event, state, and also an export barrel file, which simply exports all of the 3 other files. Let's go through the concepts of BLoC bit by bit. BLoC is an abbreviation for Business Logic Component, and following the clean architecture, it should actually be called PLoC, so Presentation Logic Component, but I just think that we are going to stick with the official abbreviation. But really, inside clean architecture, all of the domain, the business logic, is already contained inside the domain layer. So the BLoC will in fact hold only some presentation logic of transforming the input data and all of that kind of stuff. Now, if you are completely unfamiliar with BLoC, you should definitely check out the video from the card in the corner for full in-depth explanation. Right now, I'm just going to explain the BLoC in a nutshell. It is a reactive state management pattern, which means that the data flows only in one direction. and the flow of data can be separated into 3 core steps. Signified by the schematic, it looks like this. Events are dispatched from the UI widgets, and they arrive inside the BLoC. The BLoC receives events and executes some appropriate business logic. In the case of clean architecture, it's just going to call a use case. And then, once the use case spits out some data, that data will be put into a state, and that state will be emitted from the BLoC back to the UI widgets, which will do something useful with that state and the data contained inside the state, and they will display something nice to the user on the screen. Events can be, for example, something like get concrete number trivia or get random number trivia in the case of our number trivia app. And the events are dispatched whenever, for example, a button is clicked, or whenever a text is entered, or whenever a user does some action. Usually that's when you dispatch events. If we take a look at the number trivia event.dart file, currently it contains only a single base abstract class, which extends equatable, which is definitely a good thing. So as I've already briefly outlined, our app will have 2 events. Those events will be dispatched from the widgets. If we take a look at the UI, how it will look like, we can see that we really have just 2 buttons which can dispatch events. And those buttons are for showing trivia for a concrete number, the search button that is, and then another button is for a random number. So those events will be get trivia for concrete number and get trivia for random number, and they will be dispatched whenever the button is clicked. And I know that inside the repository and inside the remote data source, we've been implementing the random and concrete cases of getting the data very similarly, but this time inside the BLoC with these 2 events, there will actually be some difference in their implementation, and it will not just be changing one part of the string. It will be actually quite a profound difference that there will be. So we're going to have some fun while implementing that. But let's just for now create 2 classes for those events. The first one will be get trivia for concrete number. And of course, it's going to extend number trivia event, and it will have one final property, which will be of type string, and it will be the number string. Now, you may be wondering, why are we not passing around an integer, since it's for getting a concrete number, and everywhere else we are passing around integers, not strings representing integers? Well, that's because the number string will be taken right from the text field from the UI widget. And a value held inside the text field is always a string. It's never going to be an integer. And the reason why this event will hold a string is because converting a string to an integer directly inside the UI, so inside the widgets, or even inside this event class, because if we really wanted to, we could create final, I don't know, maybe int number, which would simply, or it would be actually a getter, so int get number, which would simply get int.parse number string, right? We could do that, sure, but this is a presentation logic. And this would go against everything what we were trying to accomplish by implementing clean architecture. Because clean architecture is all about maintainability, readability, and testability. Oh, and also, just by the way, we would violate the solid principles, more precisely the first one, which is the principle of single responsibility. Because events should not be converting data. Events should be just passing data to the BLoC. And if we were to put this conversion logic into the UI widgets, we would also violate single responsibility principle, because UI Flutter widgets should only display data and dispatch events. They should not have any presentation logic inside of them, even as simple presentation logic as this one of parsing an integer. And also, if we would want to expand on this so that we will actually have some limitations, that the integer cannot be negative, for example, which we are going to do in this tutorial, in this part, like this business logic, which is now simple, would get more and more elaborate. And also this can throw an exception, right? So what's going to happen then? How are we going to handle it? That's why it's absolutely crucial to never put any kind of logic inside classes where it doesn't belong. And that goes most definitely for the UI widgets and also for something like events. Follow the single responsibility principle and you'll be good to go. And in Flutter, this is absolutely necessary because, as you know, UI is written in the same language as the logic is written in Dart. So it's really easy to put logic throughout your UI widgets. But by doing that, you get rid of any benefits which the clean architecture and test-driven development provide. So I hope I have scared you enough. So let's add another event here, which will be get trivia for random number. And then we are going to move on to input conversion. So random. And this will not contain any fields because it's for a random number. As I've said, we're now going to create the input converter for this number string, which will convert the string to an integer, and it will also provide some limitations as to, for example, that the string cannot be representing a negative number. We're going to create it under the core folder. Let's create a new folder here called util. So it's nested under core, and we're going to create a new file under that called input converter. .dart. And of course, this is holding presentation logic, so you could also just create another subfolder under core called presentation and move that util folder under presentation, but I think we are just cool without this deep nesting. We're gonna break our tradition a bit and create a class for doing the conversion without first creating an abstract class contract, as we are used to by now. Personally, I feel that creating contracts for simple utility classes is an overkill, so we can just create a class input converter, and we are still gonna be able to easily mock this input converter because every class in Dart exposes its interface and every class can be implemented as an interface, so the mock creation will not be a problem. We're gonna, of course, mock this input converter inside the test for the BLoC, which we are going to implement in the next part. The purpose of this input converter is actually very similar to the purpose of the model. Because just like the model, if I could find it right here, just like the model is responsible for shielding the domain layer from the influence of remote APIs and from JSON, the input converter will in the very much same way shield the domain layer from the influence of input conversion, because the domain layer should not care that the text input field only operates with strings. When something is a number, it should be an integer, not a string. The domain layer should not care. And the domain layer not caring is precisely possible because of these kinds of conversion classes which live on the edge between layers. The model lives inside the data layer, and this input converter lives inside the presentation layer. Of course, it's inside the core folder because it can be possibly shared between multiple features of the app. So, enough talking. This will have one method returning an either type, because either is amazing, which will hold failure, of course. And in the case of success, it's going to return int. And let's call this method string to unsigned integer, which will accept a string, str we are going to call it, and let's just put a to-do comment over here. Let's import failure, let's import darts for the either type, and the failure which we are going to return whenever something goes wrong will be invalid input failure. Of course, it's going to extend failure. Oh, and also, just now I have realized that because we are extending number trivia event from the getConcrete getTrivia for concrete number event, we need to also pass the property to the super constructor in order for the equatable to work properly. So let's pass number string over to the super constructor inside a list, of course. Now we are talking. All right, let's move back to input converter. Just like any other class which contains some logic, we are going to create a test for the input converter. So let's create a new file under test core. Let's create a new folder, util. And inside of here, we're going to create a new file called input converter test.dart. And let's just import darts. Then also Flutter test.dart. And inside the void main, we're just now going to set up the test, of course. We are not mocking anything because the input converter is probably the only class inside, or one of the only classes inside this project, which does not have any dependencies. So we want to have an instance of input converter. Call it input converter. Let's import input converter class. And now inside the setup, we are simply going to instantiate the input converter and pass it over to, or actually store it inside the variable. And while we are at it, let's also create the first test. It will be for the string to unsigned int method. So we are going to create a group, string to unsigned int. And inside that, we're going to have arrange, act, assert, test. This method should return an integer when the string represents an unsigned integer. So this is the case when everything goes smooth as butter. So we should return an integer when the string represents an unsigned integer. And of course, inside the arrange, we're just going to create a string here. Final str is equal to something which is a valid positive, so unsigned integer, for example, 1, 2, 3. Inside the act phase, we are of course going to store the result of the call to string to unsigned integer. So input converter that string to unsigned integer and pass in the string. And then we will expect, of course, that the result is equal to not just 1, 2, 3, but instead to write 1, 2, 3, because that method returns an either, and when everything goes successful, it should be the right side of either, which means success. Because if something goes wrong, if the string is, for example, negative, or if it contains some letters, we're going to return failure on the left side of either. So of course, once we run this test, it's going to fail, as always doing test-driven development, but we don't need to be sad because we can now fix this implementation so that the test will pass. So inside here, removing the to-do comment, we are just going to return write and wrap the int.parse and parse the str string. Because again, we are implementing only the least amount of functionality in order for the test to pass. And this should make the test to pass, I think, because everything goes smoothly, right? But of course, not everything will always go smoothly. The string can contain letters, or the string can contain a decimal place. And of course, a number with a decimal place is not an integer, so even when something like 1.05 is passed into the int.parse method, it's going to throw an exception. So we need to handle that and return an invalid input failure. So let's move on to another test. The next test should return a failure when the string is not an integer. So let's just actually copy the code from the above test, but instead of the string being 1, 2, 3, it's going to be ABC. But this is the same case if this were 1.0 because int.parse method, which is implemented in the Dart language, I think, will just throw the same exception as if the string were ABC. So it doesn't really matter. And now we will expect that the result is the left side of either, which will contain invalid input failure. So if we now try to run the test, it's going to fail. And what actually happens whenever an invalid string is parsed in the parse method? Whenever this thing happens, a format exception is thrown. So what we need to do here is to wrap this code inside try catch. And we are not going to catch any particular exception, or actually we are, but we are just not going to store it inside a variable. So on format exception, whenever this exception happens, after calling parse, we are going to return left containing the invalid input failure. Now when we run the test once more, it should pass, and it does, so that's cool. But this is not everything which we want to do inside the input converter. Because while the API can in fact work with negative numbers, it's just always, at least for now, going to return that the number was not found. So it doesn't return any error status codes, it still responds with 200 success status code, but it doesn't give us any meaningful data for the number trivia. So that's why we're going to limit the range of numbers to be only positive integers. Let's first create a test then. We are again going to basically copy the whole previous test, and now it's gonna say that it should return a failure when the string is a negative integer. So now when it's minus 123, 123 of course, and we call string to unsigned integer, it should still respond or return left side of either with invalid input failure. So how are we going to implement that? And of course, when we run it, it's going to fail as usual. And the way to implement it is of course very simple. Inside the try block, we're just going to store the result of int.parse in an intermediary value. So final integer is gonna be equal to int.parse the string. And of course, if integer is less than 0, we're going to throw format exception. Of course, we could just return left invalid input failure right from here. That's also possible to do, of course. But since we are already returning left invalid input failure whenever a format exception happens, we're going to throw format exception, which will be caught immediately down in this catch block. We are doing this because if the exception handling was more elaborate, if we were doing something more than just returning left containing invalid input failure, this way we wouldn't need to duplicate that more elaborate code in two different places. And now, of course, when the exception is not thrown, we are going to return right, wrapping the integer which was parsed. So in this case, we know that the integer will never be negative, because in such case we're going to return a failure. So now when we run this code, it's of course going to pass. We are going to use this input converter as a dependency inside the BLoC right here, which we are going to implement doing test-driven development in the next part. Let's now take a look at the states which will be outputted from the BLoC, and the states will hold the data to which the UI will react and show something nice to the user. For example, it will show the loading indicator or the actual number trivia. So inside number trivia state.dart, we currently have only initial number trivia state. We're actually going to rename this, so hit F2, and we're going to rename this to empty, because that's what it is. It represents that no trivia is displayed. Then we also want to have a loading state to which the UI will react by displaying a circular loading indicator. And these two states are completely empty because they do not need to hold any data. And now we're getting to the interesting stuff. The next state should be loaded, which will actually hold a field, because whenever a number trivia is loaded, it should hold the number trivia entity. So final number trivia. Let's import number trivia. Let's just call it trivia and import it here. And let's create a constructor, but it will be wrapped inside two curly braces to make it optional named, but let's also make it required. And we mustn't forget to pass the trivia property over to the super constructor inside a list, because we are implementing equatable from the base class. So this will make it equatable by value equality and not just by referential equality. And then finally, let's just copy this loaded state. And then we also want to have an error state. This error state will be emitted from the block whenever some failure happens. For example, if the user inputs an invalid input, like -123 or ABC, this invalid input failure will trigger the block to output the error state, which of course should contain a string containing the error message, which will tell the user what went wrong. This will also be triggered whenever the cache exception happens, and then the cache failure is returned from the repository, which subsequently is returned from the use case. Of course, we are chaining these calls. We are of course going to get to that in the next part, so definitely stay tuned for that. But basically, whenever something wrong happens, this error state will be emitted to the UI. So this will get the message passed in to the constructor. And also we're going to pass the message into the super constructor. And that's basically it for the states. We're going to have just 4 of them: empty, loading, loaded, and error. All right, so we've created the events and states for the block together with the input converter, which contains the presentation logic for converting a string to an integer. And hopefully I have also completely scared you from ever putting some business or presentation logic into widgets or even into some classes where it does not belong. In the next part, of course, we're going to implement the BLoC. This means that we're going to do test-driven development with streams, because that's what BLoC pattern is built on top of. So it's definitely going to be very, very interesting. The presentation logic holder we are going to use in the number trivia app is BLoC. We've already set up its events and states in the previous part, and now comes the time to start putting it all together, doing test-driven development with Dart's streams. Testing with streams is actually quite a bit different than all of the tests we've written up until now, so there is really a lot to learn. We have events, which is get trivia for concrete number and also for random number. We have states, empty, loading, loaded, and error. And also we have the BLoC, which we are about to implement. Sure, the BLoC can already work with these events and states, but in addition to that, we also have to think about which dependencies will the BLoC have. And since BLoC or any other presentation logic holder, so for example, mobXstore, reducer, change notifier, whatever, since presentation logic holders are at the boundary between the domain and presentation layers, it will depend on use cases we have in our app. So those are get concrete number trivia and also get random number trivia. And of course, it's also going to depend on the input converter we've made in the previous part. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. We've usually created the test first and only then created the constructor, but in fact that's not really necessary because constructors do not hold any real logic. So we can go the other way and create the fields and the constructor first and only then use it from within the test. It's not breaking test-driven development because again, there is no logic, and actually it's easier to write the test once you have the constructor in place. So we're going to depend on get concrete number trivia use case. So get concrete number trivia will be its name. Then also we're going to have get random number trivia. And let's rename even the field to get random number trivia. Let's import these use cases over to here. And the last dependency will be, of course, the already mentioned input converter. So let's import even that. And we're going to create constructor for final fields. And this constructor should in fact be optional, but also required, so that these will be named parameters. So let's add a curly brace to wrap the constructor contents and then annotate every single parameter with required. So let's import meta.dart. And after every single parameter is required, we're going to do something which we haven't yet done in this tutorial course because it's quite time consuming, but you can do it always when you have some sort of a constructor. Because Dart does not support non-nullable types yet. It's on the horizon, but as of now, Dart does not support non-nullables. You can ensure that nulls are not passed into the constructor by asserting. So after a constructor, after the colon, we can assert that getConcreteNumberTrivia doesn't equal null. But this getConcreteNumberTrivia is quite a long name to have in a constructor, especially since it's a named parameter. Whenever we are constructing a new instance of NumberTrivia BLoC, we will have to specify this whole name inside the constructor invocation. So let's actually change this to just concrete. So we're going to need to specify the type and then concrete. But what this will do is that we are no longer using the shorthand of assigning the field directly in the constructor. So we will have to assign this field like this. We have to set the field. So getConcreteNumberTrivia is its name, to be equal to concrete, which is a parameter of the constructor. And now we are also going to use this concrete from within the assert. Similarly, we want to shorten the parameter name of the getRandomNumberTrivia. So we are going to just copy getRandomNumberTrivia type and call it random. We also want to assign getRandomNumberTrivia to be the random parameter. And also for all of the other parameters, we want to assert that they are not null. So random should not be null, and also input converter should not be null. And this way we have a somewhat more safe constructor, a safer way to construct our NumberTrivia BLoC instances. And this constructor structure applies obviously to all of the other classes which we have created up until now. It's not really needed, but if you really want to make sure that null values are not passed in, this is the way to go until Dart supports non-nullable types. All right, now we have the constructor in place together with the fields for the dependencies. So we can go over and create the test. As usual, it will be present inside a mirrored location. So inside the BLoC folder, we're going to create a new, not folder, but new file, which will be called NumberTrivia BLoC test.dart. And inside it, as usual, we are going to import all of the usual packages. So those are going to be copied from our tests, for example, from the repository test. We're going to copy Mockito, darts we can copy as well. So let's just copy that and paste it into this new test file. And of course, we're now going to mock all of the dependencies, which are getConcreteNumberTrivia. So we're going to just copy this type because it's quite long to type out manually. So class mock get concrete number trivia extends mock and implements get concrete number trivia, which we of course need to import. Similarly, we're going to have mock get random number trivia use case. So let's just rename concrete to random. And also it will be implementing get random number trivia, which we again need to import over here. And lastly, we're going to have a mocked input converter. So again, extending mock, implementing input converter. Now inside the main method, as usual, we're going to set everything up. So we want to have the instance stored of the actual block which we are testing. So number trivia block. BLoC is going to be its name. So let's import our number trivia block, or we can actually import the barrel file. So we're going to import block.dart, which in turn also imports the events and states. Then we also want to have instances of those mocks, which we have created above the classes for them. So mock get concrete number trivia, mock random number trivia, and also mock input converter. And now inside the setup method, we're going to instantiate all of the mocked dependencies. So mock get concrete is equal to mock get concrete, and so on and so forth. Sadly, Dart's tests simply do not support some shorthand annotations. Maybe someone will create something like that in the future, I don't know. But it's just what we have to do with Dart. We have to be repetitive in our tests. So mock input converter will be equal to mock input converter. All right, and that's about it for these mocks. And whoops, now we need to pass these mocks over to the blocks constructor. So we are also going to instantiate our block and use the name parameters. As you can see, we do not have get concrete number trivia name, but instead we just call it concrete to make it shorter, which is definitely a good thing. We're going to pass in the mock random, again pass in the random mock, so mock random. I cannot even type these long names anymore. And input converter, we're going to pass in the mock input converter. And after this line of horrendously long code is formatted, we have the test successfully set up. The first test we're going to write will be for a functionality which is actually already implemented. Because what's the first thing that a BLoC should do? Well, the first thing that BLoC does is that it emits its initial state. And as you can see inside the number trivia block, we already have the initial state implemented, and the initial state will be emitted to be empty. That's not something we've implemented. It's been implemented by the code generation, by the VS Code extension in the previous part. But I mean, it's already implemented, so we're not going to delete it just so that we can have proper test-driven development experience, right? So we're going to write the test for code which is already implemented in this instance. The test for it will be very simple. We're just going to write the regular test. It will not even be the arrange, act, assert test because there is really nothing to arrange here. So we're going to test that initial state should be empty. And inside here, we're just going to basically assert that we expect the block's initial state to be empty. So equals empty. And once we run this code, it's going to, of course, pass. So if we open up the BLoC test, we can see that initial state should be empty, passes, which is nice. Now, this is sort of a special case of a BLoC test because we are not testing with streams. All of the other tests will be working with streams because BLoC works in a way that you dispatch events to the BLoC. They arrive inside this map event to state method. As you can see, it has a parameter of the event type. Here we are going to decide based on the event type. For example, if it's get random number trivia, we're going to get random trivia. If it's get concrete number trivia, we're going to get, of course, concrete trivia. So based on the event type, we're going to decide which logic we should run. And then we're going to emit states using this stream here. And usually the events will arrive inside this map event to state being dispatched from the UI. So from the widgets, we're going to dispatch events to the BLoC. However, inside tests, we're going to have to sort of mimic the UI because we are going to dispatch the events directly from the tests in order for us to be able to test the functionality of the BLoC, of course. In this part, we're gonna start testing with the get trivia for concrete number event. So we're gonna create a group for that. Get trivia for concrete number. And let's actually also set up all of the variables which are going to be needed throughout this test group. So get trivia for concrete number, if you've forgotten from the previous part, this event takes in a number string, which we'll want to convert to an integer using the input converter, which is a dependency on the BLoC, right? So we're going to need number string. The number string will be its name. And let's just set it to be a string representation of the integer 1. Then, of course, since we are mocking the input converter, we need to mock its output. And the output of an input converter is, of course, an integer because it converts strings, validates them also, and outputs a regular integer. So the real integer of this string representation will be 1. So final t number is equal to 1. Or let's actually call it t number parsed so that it's more clear. And lastly, the BLoC will output or emit states. And one of those states, if we take a look at it, needs to take in a number trivia instance. So we are also going to create an instance of that entity. So inside the test file, let's create final t number trivia, which will be equal to a new instance of number trivia containing the number, which will be 1, and text, let's just set it to test trivia. The most important thing to happen when a get trivia for concrete number event is dispatched from the UI is to make sure that the string gotten from the UI is a valid positive integer. We've already implemented this conversion and validation logic in the previous part inside the input converter, and we've already tested it with the input converter test. So we no longer need to test it again. We can rely that input converter is a fully functional and tested class. So therefore, we can just simply mock it and not care about its implementation details here inside this BLoC test. The first thing that should happen when this get trivia for concrete number event is dispatched, therefore, should be that the BLoC should call the input converter to validate and convert the string to an unsigned integer. So we're going to create the range act assert test, should call the input converter to validate and convert the string to an unsigned integer. We're gonna mock it as any other class. So let's just say when the input converter, or actually mock input converters method called string to unsigned integer is called. Here we can just specify with any argument because we are just mocking it. We don't care at this point which number string is passed in. Then we want to return, because it's a synchronous call, not asynchronous, but synchronous. We want to return write, because it's also using the either type. So we want to return success, that the number was parsed successfully. So we want to return the number parsed, which is the integer 1. Now we are still not testing with streams, because we are just testing whether or not this input converters method has been called. So for now, we are going to do things regularly as we've done them before inside all of the previous tests. So we're just going to simply call BLoC.dispatch. We're going to dispatch get trivia for concrete number and pass in the t number string, because UI only works with strings and all of the conversion logic is inside the input converter. And then we can just verify inside the assert part that mock input converter dot string to unsigned integer has been called with the number string, because this is all we are going to check for inside this test. So we should be good to go, right? Now when we run the test, it's of course going to fail. So we're going to go to number trivia BLoC and add this logic over here. So we're actually going to unusually immediately check for the type of the event. This may seem that we are implementing more logic than is necessary for this test to pass, but that is not so, because checking for a type of an event, so we're going to check for event is get trivia for concrete number. Doing this will perform a smart cast. So within this if block, we can already use the event as if it was the concrete number event and not just some instance of the base class number trivia event. And to fulfill the test, we just want to call the input converter dependency that get or that string to unsigned integer and pass in the event dot number string. So after we save this and rerun the tests, they should pass, right? But they do not. Why is that? Well, we trigger the logic for this map event to state method by dispatching an event from this test. And events arrive inside a sink, and which is basically a stream. And overall, all of this is asynchronous. So it takes some time for the block to start executing the logic present inside map event to state. And it takes long enough that if we do not await something inside this test, this verify call will be executed before the string to unsigned integer had a chance to run from within map event to state inside the block. So even though we are doing what the test prescribes, we need to await for this mocked method to be called from within the test. We can do that using Mockito's until called method, and we're going to await it. So we're going to await until called, and let's just await until mock input converters string to unsigned integer with any argument is called. And now this test will be halted until this call is performed. And once it is, it's going to continue. And this way we've just made this test to pass. We are now only testing if the input converters method is called, but of course the output of this input converter, something has to be done with it. If the conversion is successful, the code will continue with getting data from the get concrete number trivia use case, and we are going to test that thoroughly in additional tests, which we are going to write in the next part. But if the conversion fails, we need to emit an error state from the block saying that the input is invalid. We need to inform the user, for example, if he inputs ABC, that's definitely not a valid integer. We need to tell the user that, oh, you've done something wrong, you need to input a valid integer, right? If we take a look at the error state about which I was talking, we can see error state contains a message, which is a string. And as we are emitting this error state from the block, so we are gonna do something like yield error and pass in the message. We could always specify the message as a string literal, so invalid input. But doing this is not a good practice because like you're passing around magical strings again. So we're going to skip ahead a bit and create constants for all of the possible errors for every single failure that can occur inside the BLoC. So which kinds of failures can happen inside the BLoC? Well, we have the input converter, which can return the invalid input failure. And then we have the use cases, which both can return server failures or cache failures. So really, let's just skip ahead a bit so that we do not need to come back to creating these constants all the time. And we're going to create all of the constants for the error messages right now. So above the number trivia BLoC class, we're just going to simply create const string server failure message. And when something like this happens, we are going to tell to the user that some server failure happened. So we're just going to simply say server failure. And of course, instead of messages, you could also use some error code. So for example, 100, and this would mean server failure. And this would allow you to localize these error codes from within the UI, from within the widgets, because BLoC should not access localization. But since we are building only a simple app, we are going to probably stick with messages because it's just simple to work with. Then similarly, we want to have cache failure message, which will say cache failure. And finally, we are going to have invalid input failure message, which will say something longer. We're going to say invalid input. The number must be a positive integer or 0. And with these error messages set up, we can now finally test what will happen if the input converter returns a failure, because in that case, we should emit an error state. So let's create a new AAA test. So range act assert. And this test should test that the BLoC should emit error state. We're going to mark it with square brackets, so error, meaning that this is a state when the input is invalid. So inside the range, we are not going to do anything special. We're just going to again call that when input converter's string to unsigned integer method is called, we should return not right but left, because that's the failure side, and the failure will be precisely invalid input failure. And now we're finally going to do this testing a bit differently because we are using streams. Of course, inside act, we are going to again just call BLoC.dispatch, and we want to dispatch the get trivia for concrete number event and pass in the T number string. What's interesting here is the assert part. Up until now, all of the methods we tested returned value themselves. For example, when we call input converter string to unsigned integer from the input converter test, if we take a look at that, when we call this method, it returns the value itself. It returns either a failure or an integer. But dispatching events does not return value. Dispatch returns actually void. The value of this dispatch call will be returned from a completely different place. That place is the BLoC.state stream, which contains number trivia states. So asserting if the emitted values are correct is done a bit differently than we are used to. We are not going to say expect, but instead we're going to expect later. This will make it so that until all of the values which we are trying to test for are actually emitted, this test will be put on hold. Up to 30 seconds, of course, and then after those 30 seconds, the test will be deemed failing. So don't worry if you mess something up, the test will not just run forever. 30 seconds is the upper limit. And so we want to expect later that the BLoC state stream, and now we somehow need to match what the stream emits. Thankfully, there are a lot of very useful matchers already implemented inside the Dart test framework for working with streams. So we can test emits, and now there are emits any of, emits error, emits in any order, but we want to check if the state will emit in a precise order. So emits in order is the matcher we want to use. And what should this state stream emit? Well, of course, the error state, right? So we're going to provide a list containing error state, right? And this error should hold a message containing the invalid input failure message, right? So that should be cool. But is this enough? Well, it's not. That's because blocks will always emit their first state to be the initial state. And the initial state in our case is empty. So we always need to specify empty as the first state which should be emitted. That's just something that we have to do. And let's actually make this code a bit nicer by extracting this list into its own variable, which we are going to call expected, so that it doesn't clutter up our code here, and pass in expected list to emits in order. And once we run this test, of course, it's going to fail because we have not yet implemented it. And actually here you can see that it does not fail immediately. It instead runs and tries to run for 30 seconds because it's expecting these values to be emitted later. But if those 30 seconds pass, the test will fail. And it did. However, let's just notice one more thing before moving on to the implementation of this functionality. We are dispatching the event, and only after that we are registering the matcher here that we are expecting that later on BLoC will emit these events in the given order. So is this a safe thing to do? Is it safe to dispatch an event before registering the expectation? It could possibly happen that the BLoC will execute its logic faster than we can expect this later. I mean, it's never happened to me, but just to be on the safe side, we are rather going to move the assert part of the test above the act part, because we are going to register expect later before calling dispatch, and this way we can be absolutely 100% sure that we are never going to arrive in a situation where the logic inside the BLoC executed before we had a chance to register this expectation. So instead of assert, we are going to call it assert later. So basically nothing changed, but we just made this more bulletproof. Now let's move on to the implementation. This string to unsigned integer returns an either type. So we're going to store it inside input either. And now we are finally going to utilize the true power of this either type, because we are forced to deal with both the success case and failure case. With regular exceptions, you can just ignore the exception. You do not need to wrap your code in try-catch blocks everywhere. You can safely ignore them, or safely, so to say, and then you're going to get caught red-handed that you are not putting try-catch blocks everywhere, because your app is going to crash at some point. With either, we have to handle both cases, and that's going to happen with the fold method, which accepts two higher order functions. The first one will be run whenever the left side is present inside the either, so whenever we have a failure over there, and then the right side will run, of course, when the call to string to unsigned integer has been successful. So if it's left, we're going to create a function here which will accept failure, and from it we're going to want to yield, which means emit a state. and the state we want to emit or yield to the stream is error. So error, and pass in the message. And we can already see that we have some problems here because not even the IntelliSense wants to cooperate with us now. But anyway, we're going to finish this code. We want to emit the invalid input failure message, but something is not correct here. So what is that? Well, we are inside a higher order function, which is nested within another function, which is the async generator. But this async generator does not apply to nested functions, so we need to provide this async asterisk keyword even to this function. All right? We are nesting async generators within each other, and we need to provide this keyword for every single function which yields something. Now let's just handle the if right case, because we currently do not care about that, since we are only testing for the failure case here. It should emit error. We do not care about the successful part yet. That's gonna come in the next part. But we still have to handle even the right side of either, because that's the power of either. We have to handle every single case. So this will accept an integer, and we're just simply going to, for now, of course, throw an unimplemented exception or error, unimplemented error. And that's cool for now. We're not gonna get any problems from that because this success case will not even run with the tests we currently have set up. But now we are only yielding this error state from within the higher order function. This means that the fault function returns a stream, and we want this stream from this fault function to be also returned from a map event to state itself. And we can do that by doing yield an asterisk, which means yield each. So every time we yield something from this higher order function, it's also going to get yielded from this containing function map event to state, which in turn will emit it as a state to the state stream of our BLoC, and we can then check inside the test if the order of the emitted states has been correct. All right, so that's quite confusing to some of you probably if you've never tested with BLoC or even worked with BLoC. I really recommend you to check out my more basic tutorials on BLoC if you haven't already, and definitely go through the written tutorial, to which you can get from the link in the video description, because over there you can really go over this information at your own pace, and information in a written form like that is probably better and easier to comprehend than from a video. But anyway, let's now run the tests, and we should have successfully implemented this test. And surely we did. In this part, we've started implementing the number trivia block, doing test-driven development with streams. And you've also seen the reason why either is awesome, because it forces you to handle both cases, both the failure and the success. So there was definitely a lot to learn in this part, and there will be even more to learn in the next part, because we are going to finish the BLoC, making it handle both the concrete and random events fully. We started to implement the number trivia block in the previous part, and you learned the basics of doing test-driven development with streams. In this part, let's finish the BLoC implementation so that we can move on to dependency injection next. We already implemented an important part of the logic which runs whenever the getTrivia4Concrete number event arrives in the BLoC. That's the input conversion. However, after we have the successfully converted and validated integer for which the user wants to get some amazing number trivia, we aren't doing anything with it, we are just throwing an unimplemented error. So let's change that. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and go through this lesson at your own pace. What should happen after we have the successfully converted and validated integer is that we should call the use case get concrete number trivia in order to actually get the concrete number trivia. So definitely our naming conventions live up to expectations, because like really you can literally see what this use case should do when you call it. So again, as usual, we are first going to create a test for this functionality. So we are still inside the get trivia for concrete number group, because we are testing by events. And whenever this get trivia for concrete number event arrives inside the BLoC, after we have tested everything else regarding the input converter, the next test will be again arrange act assert test, where the BLoC should get data from the concrete use case. Here in the arrange part, we are again going to return what we've been returning from the input converter, the successful parsed number. So let's just copy that for now. And with this number successfully parsed, because if it's not parsed successfully, the BLoC should immediately emit an error state. So in that case, the execution of the BLoC's logic ends there. But if the conversion is successful, we continue on with the following code. And also, of course, we are going to have to mock the actual use case. So when the mock get concrete number trivia use case is called with any number, then we want to answer, because that's actually asynchronous, and we want to answer with the right side of either, because we want to simulate success, and it's going to contain the number trivia, which we've created in the last part. It's just simply an instance of our number trivia entity right here inside this group. And after we have arranged the test, we're going to act. So we're going to call BLoC.dispatch. We can just copy it from the previous test, and we're going to dispatch get trivia for concrete number with the number string. And then, similar to how we needed to await until called with the input converter, because otherwise the assert part would run even before the logic had a chance to be executed inside the BLoC. So we need to await until called, and this time we're gonna wait for the mock get concrete number trivia to be called with any argument. And now inside assert, we just want to verify that in fact the mock concrete number trivia use case was called now with a precise argument, and we are using the params object to pass in arguments to our use cases. So we cannot just specify that it should be called with the t number. No, we need to wrap it inside params, and the params for get concrete number trivia can contain a number, and that number will be the t number parsed, which is returned from the input converter. So whatever is converted inside the input converter and subsequently returned from it, the same number should be passed into the use case. That's what we are testing here. This is the simplest test of them all, because we are not expecting anything, we're just verifying if something has been in fact called. So of course this is now going to fail, and that's because we are currently only throwing an exception from within the number trivia BLoC whenever the conversion is successful. So let's now implement this functionality. It's pretty simple. We are just going to create a regular method with curly braces, or actually higher order function with curly braces to be more precise, from which we are going to call get concrete number trivia and pass in the integer which we have over here. But of course, I have even forgotten that we need to wrap this inside params. So params number is the integer. All right. And now when we run the test once again, it should pass. And surely it does. And before moving on to other tests, let's refactor our test code a bit, because over here you can see that we are mocking the input converter to return the successful response, the number parsed, and we are doing the same over here at the top. So let's extract this into its own method, which will be located inside the group It will be, of course, void, and it will be called setup mock input converter success. And it will simply return, or actually not return, just call this when. And now we can replace all of the occurrences of this long-winded when with our custom method call. So let's replace it in the first test here and also in the last test, which we've just created. So we should rerun the tests just to make sure that our refactoring did not break anything. It shouldn't have, but just to be safe. Now, of course, just simply verifying if the concrete number trivia use case was called is not enough. We actually need to display the trivia gotten from this concrete use case in the UI using states, which are emitted from the BLoC. But even before displaying the actual trivia, we should probably let the user know that something is going on, because of course, getting concrete number trivia from the remote API will take some time. And we want to show some progress indicator, something spinning on the screen to let the user know that the app is not just frozen. So which states should the BLoC emit when calling get concrete number trivia use case is successful? Well, it should emit empty first, because that's always emitted. That's the initial state. But then it should emit loading state and then loaded state. And the loaded state will actually contain the number trivia the user is interested in. So let's create another arrange act assert test, which will say should emit, and now the states, which we write simply in square brackets. The states will be loading and loaded when data is gotten successfully. So data should be gotten successfully. So again, we're going to mock input converter success, and also we're going to mock that the use case also returns successful T number trivia and not some kind of a failure. So let's just copy and paste it over here. Actually, now we're going to be testing with streams. So we're again going to, instead of arrange act assert, we are going to arrange assert later and only then act. So let's change this to assert later. And here, what we want to assert is that the expected emitted states, so final expected, is equal to a list of states which should be emitted from the BLoC. And again, the first state always has to be the initial state. So we are going to say empty. And also you could specify BLoC.initial state, maybe, if you like that better, but I just like empty better than specifying initial state always. It's shorter. And then the next state should be loading and finally loaded. And what should this loaded state hold? Well, of course, the number trivia, which we've set up in the test group. All right. And now, of course, we need to expect later. And we expect that the BLoC's state stream will emit our values. So emits in order, and the order of the values emitted or the states emitted will be the expected list. And now, after we have registered our expectation, we can call BLoC.dispatch with the T number string as we are already used to. So we are calling it or dispatching get trivia for concrete number event. Now let's run this, and it's of course going to fail. How else? So let's go right into number trivia BLoC and implement this. We should first return the loading state. So we need to yield loading. And again, similar to how we have to have the failure function be an asynchronous generator, we need to do the same for the success function. So now we can yield something from within this higher order function. And then this get concrete number trivia returns either. So similar to how we store the either inside a variable for the input either, we want to do the same for our final failure or trivia. And once we have failure or trivia object, which is of type either, of course, we want to yield a state. And currently we are testing for when the data is gotten successfully, in which case we want to emit loaded. But again, here comes the power of either, in that we have to handle both failure and success. So we cannot just somehow circumvent this. As I've said in the previous part, we have to handle both cases. So we want to yield whatever will be returned from the failure or trivia. Why cannot we specify that? IntelliSense does not want to cooperate this time again. Or actually it does want to cooperate, but I've just forgotten to specify await, because of course this is asynchronous, so pardon me. Now we can call failure or trivia dot fold again. And if there is a failure, because we are currently testing for success, we're just going to ignore failure again by throwing an exception, which will be unimplemented exception. So let's do just that, or unimplemented error as it's properly called. So we're going to throw this. And if the call was successful, so if right, we're going to receive the trivia object over here, in which case we want to simply return loaded and pass in the trivia as trivia argument. And so we return loaded state from the fold method, which in turn is yielded from our async generator and so on up the chain. Eventually it's gonna get into the stream of number trivia states. So now running the test should pass. And now we can move on to what should happen if the call to get concrete number trivia returns some failure. In this case, those failures can be cache failure or server failure. So we're going to create another test. In fact, it's going to be so similar to the last one we've created for the success that we're just going to copy and paste it below. And this time it should of course return loading still, because even when we get some error from the use case, it still happens asynchronously, so we have to show some kind of a loading indicator to the user. And then we are gonna want the error state to be present. And this is gonna happen when getting data fails. All right, so now we are still going to mock input converter success, because we are going to get to the point of calling the use case only when the input converter actually is successful, because if it's not, we are immediately going to yield error. So only if it is successful can we get to calling the use case here. But what we want to change is that the get concrete number trivia mock will not answer with right T number trivia, but instead left. And let's do server failure. So we need to import that over to this file. And now we should assert that the states emitted are not empty loading and loaded, but instead the last state will be error. And here it's pretty important to specify a correct message. So because we are emitting or getting server failure from the use case, the message should be server failure message, which we have created in the last part. This is simply the string constant. And all of the other code of this test can remain as it is. So let's now run this, and it's going to fail, of course. So let's go to number trivia BLoC, and instead of throwing an implemented error from the failure side of either, we're going to return error and pass in the server failure message as the message. So let's run this again, and this time it passes. But of course, the problem here is that we cannot just simply put the server failure message always into the error. What's going to happen when the get concrete number trivia use case returns a cache failure? Then there should be the cache failure message, right? But something like this is currently not in the tests. So let's create a test that will make sure that only the proper message for the failure is inputted into the error state. And it's very important to handle all of the possible types of failure inside the BLoC, because it's important to show the user a precise and meaningful message. It's not enough to just handle the base class failure and call it a day. We need to handle every single subtype. So let's do that right now. We're going to just copy and paste the test below. And we're going to call this, that should emit loading error, yes, with a proper message for the error when getting data fails. All right, that's quite a long name for this test. But anyway, instead of server failure, we are going to return cache failure from the concrete number trivia use case. And then the message which should be there in the error state will be cache failure message. So now let's run this test again, and it's going to fail. So now inside number trivia BLoC, we're going to spawn a monster here, but don't worry, we're going to fix it in just a little while. That's because, just to make this as simple as possible, we are doing TDD after all, so we are just writing the least amount of code possible for the test to pass. We're going to put a ternary operator in here. So if failure is server failure, we are going to, return the server failure message. Of course, we need to import server failure or failures.dart file to be more precise. And otherwise, we are going to put the cache failure message into the error state. So this code is definitely not good code. It's not even readable very much. But anyway, this should make the test pass. And only then later on we can go on to the refactor phase, because remember, with test-driven development we are doing red, test fails, green, test passes, and only after the test passes are we going to really refactor. Some exceptions may apply, but mostly that's what you should be doing with TDD. In addition to this being unreadable, this ternary operator is actually quite unsafe, because what if the failure type is not a server failure, nor is it a cache failure? Of course, we do not have any kind of other failure which can happen inside here. Still, if we had some unexpected failure here, the message would still be the cache failure message, which is not cool. That's because this last part of the ternary operator is basically an else clause. So now to make this safer and also more readable, let's extract this ternary operator into its own method, which will be private inside the BLoC. We're going to call it map failure to message, and it's of course going to return string. It's going to accept the failure. And sometimes I wish that the darts extension methods were already here, because we could do it really nicely with an extension method which would be local to this class, but still they're just working on it, so we have to create these kind of stupid helper functions as of now. But anyway, we are going to switch here, and we could of course do if failure is and specify server failure and so on, but we can also do it with a switch statement. I think it's nicer. The way we can do it with switch is that we're going to switch over the failure's runtime type. And now we're going to provide cases for this switch. So in case that the failure is server failure, we're going to return server failure message. In other case, when it's cache failure, we're going to return cache failure message. And finally, sadly, Dart still doesn't support any sealed classes or tagged unions or sum types or however you want to call it. So we have to handle the case when the failure will be none of these, and we're going to handle it with the default clause. And in this case, we are going to return a string called unexpected error. because it's really unexpected that this is going to be even returned, because there is no even possibility of having a different type of failure passed into this map failure to message method after all. And even though the Dart team, as of speaking now, is already working on adding sealed classes or something similar to Dart, if you want to learn how to work with sealed unions, which is a package fixing up missing Dart's functionality, check out the video from the card in the corner. And now, of course, we're just going to call map failure to message instead of this ugly ternary operator and pass in the failure. And that's basically all there is to do for us. So now, because we have refactored the code, we need to rerun the tests, of course, and they should still pass because we have not changed anything extreme. And now with this, we have successfully implemented the whole logic which should run whenever the getTrivia for concrete number is dispatched to the BLoC. But there is also another event, and that is getTrivia for random number. And as we are already used to, the random event, when that is triggered, will be very similar to what happens when the concrete event is triggered. But with one exception, it's going to be much simpler, because with getTrivia for random number, we do not have to handle input conversion, because there is no input. It's just a random number generated over in the remote API. So because of that, let's go over to the test file and we can actually copy the whole group for getTrivia for concrete number. So copy it, paste it below. We're going to again break the methods of test-driven development for the sake of us not getting crazy, because these implementations are really similar. But in addition to just renaming things to make them work with the random event and calling the random use case and so on, we can actually delete a lot of code in here, because the input conversion and validation will not happen. So we can remove the test should emit error when the input is invalid, and also the first test, which tests that it should call the input converter. So we can delete the first two tests. And of course, we no longer need to have input converter success here, because input converter will not be called from within getTrivia for random number. So let's rename that. And also, because we are not validating any input, we are not going to need tNumber string nor tNumber parsed, because they are not needed. We just need the tNumber trivia, because everything else is basically just generated inside the remote API. We do not care about the inputted number. So now let's fix up all of these tests one by one, and then we are going to implement the whole functionality of the random event inside the BLoC after we've modified these tests. So the first test should get data from the random use case. We're now going to mock input converter. So the use case will be mock get random number trivia. And the random number trivia use case does not take in any parameters. So what we've done is that when something does not take any parameters and it's a use case, we can specify no params, right? And of course, we would also need to import no params over here. But because we are just mocking it, we can still just pass in any and check for no params only in the verification part. The event which should be dispatched is of course get trivia for random number, which does not accept any arguments. We're going to wait until get random number trivia use case was called, and then get random number trivia use case, and we want to verify that it was called with no params. Now we're gonna do the same thing for the method below, so for the test below. So should emit loading loaded when the data is gotten successfully. That's correct. That's what should happen also from the random event, because the only thing that changes is that we do not convert the input. So let's copy the mocked random number trivia use case from above. The expected states can remain the same, and so expect later can remain the same as well. And the dispatched event should again be get trivia for random number, and that's about it for the changes to this method. Next, again, we're simply going to just mock the random number trivia use case again and dispatch the random event. So let's copy and paste it. And of course, you can get all of this code from the written tutorial, and over there you can also get the whole project. So definitely check it out from the link in the video description. Lastly, even for the last test, we're going to do the same thing. So mock the random use case without the input converter and dispatch the proper random event. And once we've done that, we can now run the test code, and it's going to fail, of course. And we're going to get to number trivia BLoC, and we're going to do the simplest thing possible, and that is to create an else if, and we're going to check if the event is get trivia for random number. And here we are simply going to copy and paste the code from above after integer was successfully validated and converted. So let's just copy it from within this integer higher order function and paste it into this event handler, so to say. So we're going to yield loading, and then instead of get concrete number trivia, we are going to call get random number trivia. And basically the only other change which will happen in here is that we're going to call it with no params. So let's also import usecases.dart. And with that, we can now run the tests again, and they should pass this time. Well, that's interesting that they do not all pass. So let's take a look at what happened. Should return empty, loading, and error, because we are in the test for testing the errors. But instead it returned empty, loading, and loaded. Oh, that's right. We are returning right side, not the left side, even from the error tests. So here you can see why test-driven development done the right way is awesome, but doing test-driven development with just copying and pasting code is actually pretty bad. It's still better than if we did not have any tests, but still, we've made a mistake in the test just because we were not following TDD precisely. We are going to return not right side of either, but left side, of course, which will hold the server failure in this case. And in the test below, it's going to return left with cache failure. And with that, we can now run the tests again, and they should pass this time. All right, so now it's time to remove the code duplication, because there is not a lot of it actually inside the BLoC, but still we can do better. If you take a look at this code, what we are doing in both of the functions or in both of the clauses of the if statement is that we are yielding failure or trivia.fault, and then we yield either or return an error or a loaded state. So let's extract this functionality into its own method. We are going to highlight it and say extract method. Let's call it, it will be private, so underscore either loaded or error state. And it's going to generate us a method, but of course its return type is wrong for some reason, so we have to change it manually. Let's also add a comma so that it will be formatted for us. And we need to change the void return type to be stream of number trivia states. And after we make this method to be an asynchronous generator, so async asterisk, we can now yield from it failure or trivia and return error or load it. And now we can call this method from both of the clauses of the if statement, but we should also yield each. So yield asterisk. And we are of course going to do the same for the random event. And with that, we can now run the tests again because we've refactored the code and they should still pass. And they do. So now we have the BLoC fully implemented. It has its dependencies in place. We are calling them from within the map event to state, and we have it fully tested, and the code is looking pretty decent. And also, because we are using the either type from the darts package, we are forced to handle errors or failures. Even though we might not want to handle them, we just cannot go around that. Unless we are really clever, but of course you can always go around something if you really want to, but it's much easier to go with the flow where you have to handle the failure, and at least you are definitely not going to forget about it as you would if you were just using regular exceptions all over the place. We are getting close to the finish line because now that we have literally every bit of logic implemented, it's time to put all of the parts together with dependency injection in the next part, and then, well, there will be nothing more for us to do than to create the user interface. We have all of the individual pieces of the app architecture in place. Before we can utilize them by building a UI though, we have to connect them together. Since every class is decoupled from its dependencies by accepting them through the constructor, we somehow have to pass them in. We've been doing this all the time in the tests when we mocked the classes and we passed them into the constructor, but this time we are going to pass in real production classes and not mocks using a service locator. So almost every class we've created in this course up until now has some dependencies. For example, if we go and see, first close all of this, and now let's see, for example, the number trivia local data source. It has dependency on the shared preferences class. And then we also have number trivia repository, and of course that has dependencies on remote data source, local data source, and also on network info. So there's really a lot to configure even in a small app like this number trivia we are building. And there are multiple service locators which we can use for Flutter. And as you may remember from the second part, when we set up all of the dependencies of our whole app in pubspec YAML, and we are going to be using getit. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code from this video and overall go through this lesson at your own pace. Let's now go over all of the classes from the top of the call flow downward. So in our case, this means going from the number trivia block and ending with the external dependencies like shared preferences or maybe the HTTP package client. We're gonna set everything up in a file called injection container, which will live at the root of the lib folder. So precisely where main.dart is, we are going to create a new file. So let's right click on lib. You can also do it with command line or whatever, but let's just stick with the simplest option. This file will be called injectioncontainer.dart. And over here, the structure will be very simple. It's gonna be basically just a single top level function, which we are going to call from main.dart. That function will be called init, so it's going to initialize everything, and we are simply going to call it from the main method of our whole app. Also, we're gonna need to get the instance of getit on which we can register individual objects, or more precisely how they are gonna be instantiated, so that when they need to be instantiated by getit will know what to do. And for that, we obviously need to get the getit instance. So if we import getit, after we create void init, which we are gonna call from main.dart, now here we can technically get getit instance like this. So getit.instance, and, for example, register something on it. But doing this is a bit long-winded, so that's why we're going to pull out this getIt.instance call and cache it inside a top level field final SL, which means service locator. And we're just going to set it equal to be getItInstance. And now we can just simply call sl.register something, so the code will be shorter. We're gonna start off with creating the first structure of this init method, because we want to have some structure in this init method, because otherwise it's gonna become a mess. So I'm using an extension for VS Code which colors the comments. It's called Better Comments if you're interested. And whenever I put an exclamation mark before or after these two forward slashes, it's going to change the color to be red. And with that, we're going to annotate this, that the first part will be dealing with features. So here we are going to register everything regarding features of number trivia feature. So this means repositories which are a part of a feature, use cases, and also the data sources will go over here. Then the next part will be dealing with core stuff. So here we are going to register the input converter, because that's a part of core, and also network info, right? That's also a part of core. And finally, we also need to tell getIt how to instantiate those external dependencies. So those are HTTP client and also shared preferences and all of that. So this will be for external. And instead of dividing this one init method with comments like this, of course, we could also create some children init methods. So void init features, and then we would call it from within the main init method. But I think that for what we have currently, just dividing the main method of initialization with comments is plenty enough. So we do not need to create even more methods to confuse us. As you've already seen, when I was just demonstrating the getIt instance, it has the possibility to register singletons and also factories. So if we do SL, we can register factory, lazy singleton, and also just regular singleton. Let's just first deal with registering a factory, and then I'm going to explain why we register this precise class as a factory. And the first thing which we are going to register is going to be the BLoC, because it's at the top of the call chain when we go from the UI all the way down to those external data related dependencies. So let's also provide a comment BLoC. And now we're going to register it as a factory. So here, this register factory method takes in a function which returns t. And this is simply going to be a higher order function which will register the BLoC by returning it. So let's return number trivia BLoC, and let's import it, of course. So we're going to import just the number trivia BLoC is enough. We do not need to import all of the other events and states. And this has to take in concrete use case, input converter, and the random use case. So currently we do not have them registered. We are going to register them later, but even now we can do something like this. So SL, invoke it, we're done. What's actually happening here? Well, let's first just register all of the other. So input converter will be also SL invocation, and then the random use case will be also done through the invocation of the service locator SL. And after we format it, let's actually take a look at what's happening here. Calling SL, of course, is just a shorthand for calling sl.call, because service locator, this getIt instance, is also a callable class, much like our use cases are callable classes. And inside this call method, what happens is that the getIt instance starts looking for all of the registered types. Very much like here we are registering number trivia block, we are also going to register the concrete use case. So sl.register factory, and we would do something like get concrete number trivia and so on. And as soon as this is registered, getIt will be able to resolve the type because it's going to infer that, oh, since concrete is of type get concrete number trivia, you probably want me to inject something which is registered under the type get concrete number trivia, right? So it's going to grab that instance, it's going to instantiate it actually for us, and it's going to pass that over to concrete. The same will happen with the input converter and with the random use case. But there is one important thing to talk about, and that's the difference between factories and singletons, because in addition to registering factories, we can also register lazy singletons or regular singletons. So factories obviously always instantiate a new instance of that given class whenever we request it. So for example, from within our first UI widget, from the number trivia page, which we are going to actually create in the next part, we are going to request that getIt gives us an instance of number trivia block. And since number trivia block is here registered as a factory, we're always going to obtain a new instance on every call to getIt. However, when you register something either as a lazy singleton or as a regular singleton, trying to get that instance from getIt will always, after the first time, grant you the same instance. getIt will cache it, and then on subsequent calls to it throughout the lifetime of the app, it's going to give out the same instance and not instantiate a new one since it's a singleton, right? And presentation logic holders such as BLoC shouldn't be ever registered as singletons because they're very close to the UI, and for example, if the app has multiple pages between which you can navigate, you probably do not want this to be a singleton because you want to do some cleanup like closing streams and all of that from the dispose method of a widget. And as you can probably tell, trying to close a stream but having a singleton will lead to problems because you would close a stream, but if you were to come back to the previous page on which that block is being used, and you would try to get an instance from getIt of this number trivia block, for example, and this was a singleton and not a factory, you would get the same instance of number trivia block as previously, which now has a closed stream because you closed it when the user navigated out of the page previously. So instead of creating a new instance with opened streams, you would get the old instance, the singleton, with closed streams. So that's why something like blocks or I don't know what else, when you have some disposal logic on your presentation logic holders, you should register them as a factory and not as a singleton. So as you already know, calling SL will do some type inference. It's going to infer that we want to have an instance of get concrete number trivia passed into that constructor parameter. So we also need to register all of these three classes: concrete, input converter, and random use case. So let's do just that, right? We're going to register use cases. This goes under the features comment because use case is still a part of the number trivia feature. And these ones can actually be singletons. That's because on them we do not need to close any streams. And even though we are going to get always a new instance of number trivia block, its dependencies are going to get sort of recycled by being singletons. We can do that because, as I've said, we do not need to close any streams on these use cases or anything like that. And also, all of these use cases and input converter do not hold any state. So there is no point in instantiating a new instance when we can have just one of them, and it will surely be more performant. Now getIt gives us two options when it comes to singletons, because we can either register a singleton, which is a regular one, or a lazy singleton. And the only difference between the non-lazy singleton is that it is always registered immediately after the app starts, while the lazy singleton is registered only when it's requested as a dependency for some other class. So in our case, it's not going to really matter much because like immediately after we are going to request that we get an instance of the BLoC from within the UI widget, it's immediately going to resolve all of its dependencies. And since we have really a simple dependency tree, all of the dependencies will be resolved at once because every dependency depends on all of the other dependencies below it. However, if you have multiple features, so for example, you would have a new feature settings right over here above it somewhere, and you would have settings BLoC or settings trivia BLoC, something like that. And the first page which you would display would be the regular number trivia page. The dependencies of settings, if they were registered as lazy singletons, would not get instantiated and resolved, and therefore they would not tax the system with some performance hiccups until the user navigated to the settings screen, to the settings page, and requested the top level dependency on that page, because only then it would kick off all of the resolving of those dependencies from that settings dependency tree. However, because we have just one tree, this really does not matter if we register it as lazy singletons or regular singletons, which get resolved immediately, but let's just stick with lazy singletons for the fun of it. So we want to register get concrete number trivia. So this is also going to need to be imported. And then of course, this also takes in another dependency, which is of the repository. So we are again going to pass in SL invocation, which will be resolved to the repository once we register it. Similarly, we also want to have get random number trivia, which of course needs to be imported and also takes in an instance of the repository. And finally, the number trivia BLoC needs an input converter, which is actually a part of the core folder. So we're going to register it under core. So SL register lazy singleton, and we're going to just register input converter, which is actually a class that doesn't take in any additional dependencies. So that's awesome. While the dependencies of number trivia BLoC are concrete classes like get concrete number trivia and get random number trivia, the dependency of the use cases is not a concrete class, but rather a contract, the abstract class, because our use cases, so that we do not go over the individual layers of our app, do not depend on the implementation of number trivia repository, but instead they depend on its contract, which is actually present in the domain layer right here. They depend on this, while its implementation is in the models layer right here. They do not depend on this one. So what we can do in order for the contract to be resolved to the implementation, we are going to use a generic parameter. So let's register repository. So sl.register lazy singleton again, and this time let's provide number trivia repository type over here. So let's actually copy it so that I do not need to type it out. Number trivia repository comes right here. So we're going to register singleton for that type, but whenever this is resolved, it obviously isn't going to instantiate the number trivia repository contract, because after all, it's an abstract class. It cannot be possibly instantiated. What it's going to do is that whenever it resolves number trivia repository type, it's going to instantiate its implementation. So we're going to return number trivia repository impl. Let's import that. And over there, we are going to need to pass in all of its dependencies. So local data source will be SL, then also network info will be SL, of course, and the last one, remote data source, will be also SL. And after we have that, the use case dependency of number trivia repository can be successfully resolved to its implementation. And this nicely demonstrates the usefulness of loose coupling and also why we created these contracts all along. In addition to being able to separate the domain layer and sort of, how they say, programming into the interface and not into the implementation, because our domain layer does not care how the repository is implemented. The domain layer, and in turn the use cases, only care that a repository provides its given methods, and how it's implemented, that's completely irrelevant to the domain layer, because a good repository has to fulfill its contract, right? You have to fulfill your contracts, because otherwise, like, you are not a good person. And sort of that's the same thing for classes. If they do not fulfill contracts, well, they're bad classes. So we can really trust ourselves in this case that the contract will be implemented properly. The same loose coupling and depending on contracts instead of implementations allowed us to actually test the class, because without it we would not be able to pass in the mocked classes as we were doing all along in this course. But also it allows for painlessly swapping the number trivia repository's implementation for a different one without the changes to the dependent classes. So for example, we can have another implementation like implementation special, and as long as this special implementation of number trivia repository fulfills the contract of number trivia repository, we're cool. We do not need to change anything in the use cases because they depend only on the contract. Now, of course, we need to register the data sources and network info. So those are going to be pretty simple. Again, they are programmed into the interface and not into their implementation. So we are again going to provide a generic parameter when registering that on the service locator. So data sources, those will be sl.register lazy singleton. And first, of course, let's just provide the type. So local data source, for example, or remote can go first. Let's copy that. It will instantiate its implementation. So let's just return impl, which is actually in the same file as its contract, so we do not need to import anything else. Let me actually hide the sidebar, although it's not going to help all that much. And this depends on an HTTP client, which we are going to register next in the external part, because HTTP is not our own class, it's an external package. And once we have that, we can now also register the local data source. So we're going to do just that. Number trivia local. The same goes for its implementation. And this one takes in not a client, but instead it's going to take in shared preferences. All right. And finally, the last dependency which we need to register for the repository is the network info. So this comes into the core package, and we're going to again register it as lazy singleton network info. Let's import that, and this actually has the dependency. Oh, and of course, this is an abstract class, so it has the contract also. So we need to register this network info as the contract, and its implementation is impl. And this one takes in the data connection checker. This is actually not a named parameter, so we're going to just say SL. Finally, let's go for the external dependencies, because we have now moved all the way down on the call chain, and we need to register the client of HTTP, data connection checker, and also shared preferences. Let's actually start out with shared preferences, because this one is a bit tricky. If we go as usual, SL register lazy singleton, and we would try to register it regularly, so shared preferences, so, and try to import that package here. We cannot just instantiate it like this because it doesn't have a default constructor. Instead, the way to get an instance of shared preferences is to call getInstance. But the problem is that this returns a future. It's an asynchronous call. So we probably need to await it, right? And for that, we need to make this whole higher order function asynchronous. So now we should be good to go, right? But the problem is that whenever you make a function asynchronous, it itself returns a future. So now we would not register a singleton for shared preferences like this, but instead it would be a singleton for future shared preferences. And actually, whenever we provide the type explicitly like this, even though it doesn't have a contract, but even classes which do not have a contract can have, of course, a type provided explicitly. Now we have an error here saying that the argument type future shared preferences returning function cannot be assigned to the parameter type shared preferences function. That's because it returns a future. So if we do something like that, we're cool. But of course, we do not want to register a future of shared preferences. We want to register just regular shared preferences. So how can we go about that? Well, we need to extract the await to get the instance outside of the registration of singleton. So this will happen something like this. We're going to just cut out this awaiting code, make this non-asynchronous, and now just create final shared preferences with lowercase s and get set it equal to be this awaited shared preferences instance. And of course, for that, we need to make this whole init function asynchronous. And now it works. So we can provide shared preferences to be registered as lazy singleton. And now these shared preferences are in fact of type shared preferences and not of type future shared preferences. All of the other singletons are going to be very simple. So let's just import up top HTTP as HTTP. And we're going to instantiate http.client here. And similarly, data connection checker. So let's import that. So we've gone from the top of the call chain, from the BLoC, which is registered as a factory, to the use cases, to the repository, to the data sources, and the same goes for the core classes and external classes. And basically everything is registered as a singleton because no of the classes which are registered as singletons hold any state, nor do they need to close some streams once they are disposed of or anything like that. The only class which has not even a state, but it needs to have closed streams on it is the number trivia block. So whenever you do some disposal logic, you should always register factory and not a singleton, because then you are going to get the same instance with the closed streams or closed, disposed, whatever else, and that's going to cause some problem. Now, of course, we have this init method over here, and it's not just going to get called auto-magically by itself. So as I've said in the beginning of this part, we're going to go over to main.dart, which actually still holds the main default counter app, which we are going to change in the next part, of course, with our own beautiful, sort of beautiful for my standard at least, UI. So now inside the main method, we're going to convert it to a body method, so BLoC body. And before running the app, we are going to call the init method. So for that, let's just import. And we're going to import injection container. And let's import it as di so that we know what we are doing. And let's just then call di.init. And now comes the question, is this enough? Well, it may seem like that, but over in the injection container, we are in fact awaiting to get shared preferences. This init method is asynchronous, but it itself does not return future, it returns void. So currently we cannot await the execution of this init method. And while I do not think that this is a huge problem, most of the time you're going to get away with it, let's just, for the sake of it, make this function return a future void. And now we can await it from the main.dart file. And of course we need to make the main function asynchronous now. We've now ensured that the UI running the app, so building the UI also, will not happen before every single dependency which needs to be registered has a chance to be registered. Again, you may get away with not awaiting when you have asynchronous calls inside the initialization function, but still, just to be on the safe side, whenever you have await inside the init, just await also the whole init method before running the app and building the UI subsequently. There have been a lot of registrations of all of those classes written in this tutorial, so to go through this at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And dependency injection was the missing link between the production code and test code, where we sort of injected the dependencies manually with passing in the mocked classes. But now that we have implemented the service locator in the form of getIt, nothing can stop us from writing Flutter widgets, which will utilize every bit of code we've written until now by showing a fully functional UI to the user. The time for putting all of our previous work into practice is finally here. This part will be all about building the UI and splitting it into multiple readable and maintainable widgets. The UI we currently have in our number trivia app is just the default increment a counter example, but what we are going to have at the end of this last part is the following, which you've already seen in the first part of this tutorial course. So we will have a text field with 2 buttons and then a message text, and we can input a number here. And then we're going to have another text displayed at the top containing the number itself, and then the actual trivia text will be below it. And of course we can also get random trivia and it's going to do the same, and actually this text here is also scrollable. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. We are going to create a new page under the features number trivia pages folder. So let's create a new file, call it number trivia page.dart. And let's just create a blank version of it for now, and then later on we are going to add stuff to it. So let's create stateless widget, number trivia page. Of course, we need to import material, impm, import Flutter material, and we are not going to return a container, but rather a scaffold. And let's just for now set up an app bar on it, which will have a title text, which will say number trivia. So now comes the time when we change what's happening inside main.dart from the default counter app to our own page. So let's actually just delete everything which is currently present inside main.dart, apart from the main function, of course. And we're going to create a new material app, which will say, of course, let's just delete this import and main. I'm using awesome Flutter snippets if you're wondering. And if you wanna know which extensions for VS Code you should definitely use as a Flutter developer, check out the video from the card in the corner. We're gonna return material app from it with the scaffold not specified right over here, but we're going to say number trivia page will be the home of our material app. So this is the page which we have just created a while ago. Let's import it and let's change the name here to say number trivia. Now I have launched the app, so this is how it currently looks like. Let's add some theming to this material app. And of course, it's going to be ResoCoder style theming, so it's going to be the green color. So theme, let's set it to theme data. And let's just set the primary color to be colors.green. And let's make it shade 800. We could also make something like 800. It's gonna be the same, but let's just set it to shade. That's more explanatory. And then also we're going to have accent color, which will be colors.green. And let's set this one to shade 600. And with that, we can move on to the number trivia page. In clean architecture, the only communication pathway between UI widgets and the rest of the app is the presentation logic holder. And in our case, the presentation logic holder is a BLoC. But of course, I'm not going to stop beating the dead horse and say that you can use any other state management solution out there, whether it's MobX, Redux, change notifier with a regular provider, whatever, you can use it completely fine with clean architecture because it's not dependent on your state management solution. The presentation logic holder is basically a trivial thing once you get the rest of the architecture correct. But regardless of your preferred state management method, you still need to provide your presentation logic holder throughout the whole widget tree. And for that, obviously, we're going to use the provider package. But since we are using BLoC, which is actually integrated with provider, and you can check out the tutorial dealing with that from the card in the corner, we're going to use a special BLoC provider, which has some nice BLoC specific features. In addition to the app bar, a scaffold can also have a body, and we'll want to provide the BLoC over to the body and to all of the other child widgets, which are going to be instantiated inside that body. So let's say BLoC provider. Actually, we can use a snippet coming from the extension of VS Code. So let's import Flutter BLoC. Inside this builder function, we're going to just return the BLoC, which should be provided down the widget tree from this BLoC provider. Actually, we do not need the context, so we can just make it an underscore, and the BLoC which we want to provide is obviously the number trivia BLoC. But we're not going to instantiate like this because that is completely wrong, since we need to provide dependencies and all of that. That's precisely why we have registered all of our classes and their dependencies in the injection container file right over here. So now we want to get this registered instance factory, we are going to call this factory, from within our number trivia page, which is going to resolve in turn all of its dependencies, and it's going to kick off the resolving of all of these, like this whole dependency tree. We can do that by calling SL, which is actually from the injection container file. And we're going to just specify number trivia BLoC to be the type which we want to get over here. And with that, all of the dependencies will be also resolved. Before reacting to states emitted by the number trivia BLoC, and there can be empty, which is currently being emitted, the empty state, then there is the loading state, then loaded, which is going to grant us the number trivia, which we are interested in. And finally, there is the error state, which we're going to handle by displaying an error message. Before doing all of that, let's first build out a basic UI outline using placeholder widgets. So the root of the UI will be a padded and centered column. If we take a look at that, it's a column because we need to have this top half and the bottom half, because the top half is concerned with output to the user, so it's going to output some text, and the bottom half is concerned with input. It's going to have a text field and also the search button and the random button. So we're going to first replicate that with placeholders. Let's just first extract the body of the scaffold into its own method. So we're going to say build body. So the child which we are going to have here will be a column, and this column will have children, which will be a container which will represent the top half of the screen, so the stuff where the messages are displayed and the number trivia is displayed. So this container will have to have a fixed size, a fixed height to be precise. If we take a look at that, no matter how long the number trivia is, so for example, if it can scroll, or even if it's shorter so it cannot scroll, the bottom half stays at the same place and we are still inside a column. And for that we need to fix the height of the top half of this display of messages, because otherwise the bottom half would start jumping around. For example, now it would be a bit more downward, it would be pushed downward because naturally, without fixing the height of this top half container, the longer text of the trivia would try to expand the container to fit its content. So because of that, we're going to fix the height of the container, and let's just fix it to be the third of the size of the screen. So we're going to say media query of context, which we currently do not have inside build body. So we're actually going to pass in context, and of course it's build context, and let's just pass in context to build body invocation from the body of the scaffold. So now we want to get size, of course, and its height, and divided by 3. So it's going to be the third of the size of the whole screen. And now the child will be only a placeholder. So it will look something like this. Of course, we do not want it to be flush with the top of the screen under the app bar. So let's just provide some sort of a padding in the form of a size box. So size box height, or FSZH. I have an extension of VS Code. It's called Flutter widget snippets. So if you want that, just install this extension in VS Code. And with that, you're going to be able to use those shortcuts. So the height should be 10. Of course, after we provide a comma here, it's going to be pushed a bit downward. After this, we want to have another sized box with height of 20, because now comes the bottom half of the screen, sort of, which will be concerned with the user input. So this will contain all of the text input fields and the buttons. So it's going to be another column. This one will not have a fixed height because the height will not be variable. It will have just 3 widgets inside of there. And it needs to be a column because we need to stack the text input field and the buttons below each other, and then the buttons will be inside the row, of course. So let's do just that. We're now going to implement it only with placeholders, but of course we're going to change that later. Bottom half, and let's put a column in here which will have children, and those children will be a text field which currently will be only a placeholder, but because this placeholder would not be constrained, otherwise it would just overflow this whole thing, we need to provide a fallback height. Let's just set it to 40. So now it's going to sort of represent the text field. Now for the next widget present inside this column, it will be a size box, so FSZH. The height will be 10, and with that we have a size box over here, below which we are going to place those 2 buttons. And because they are besides each other, we're going to place them inside a row. So this row will also have children. And now there are going to be placeholders again. And we're again going to need to fix their height to be 30, for example. So let's try and look how it looks like. And it's definitely not looking any good. It overflows, and the whole button is sort of unbounded because it's only a placeholder. Let's just try to add another placeholder besides it. And even if we fix their width, so fallback width will be, I know, maybe 100 is a good width for the button, or maybe 200, not 2000, but 200, all right? And we would do the same thing for the other placeholder. It's not a good way to do things. Even with the real buttons, we will now want to specify their width manually. We want to let them expand to whatever width they want to be, and also to whatever height they want to be. So for that, we're now going to specify fallback width, but instead do something row specific. We're going to wrap these placeholders, which represent buttons. So the same thing which applies to placeholders will also apply to buttons later on in this part. So we want to wrap them with a new widget, and that widget will be expanded. We want to do the same thing with the bottom button, which will be for the random trivia. So wrap with a new widget, expand it. And with that, after we provide commas here so that it's nicely formatted, it's going to be looking good without any overflow. And now another size box, but this time for width. And the size of the box will be 10. So we're going to have 10 logical pixels in between the buttons. But still, this whole column is not looking great because it's flush with the sides of the screen. So we want to provide some padding. So we are going to add padding. The padding will be not 8, but 10. And now we cannot see it because we are using placeholders, but later on we can have some problems that the contents of the column, its children, will be on the left side. So let's just, to be safe, center this whole padding. So we're going to say center widget. And now this outline of the UI with placeholders is finished. Let's now deal with the top half, and then we're going to move over to the inputs in the bottom half. So inside this top half, instead of having a placeholder, we'll want to react to different states emitted from the number trivia block. And according to the state which is currently present, we will want to display different UI. So for example, loading state will display a progress indicator, error state will display an error message, and so on. So building out different widgets according to the current state which is present in the block is possible with BLoC Builder. So instead of this placeholder, let's add a BLoC Builder, which is actually also a snippet coming from the extension BLoC for VS Code. And over here, we need to specify our number trivia block and also the state. So number trivia state. So let's actually import the barrel file for BLoC. Oh, and of course, we do not want to put this into the container, but we want to make this BLoC Builder to be the widget wrapping the container. So the top half will be comprised of the BLoC Builder, which from it will return the container with the fixed height. So let's just replace this default container with that one. And now the child will of course still be only placeholder. We're going to fix it later. Just let's put a placeholder here so that we can reformat the code. So nothing changed yet, but we're going to get there soon. And now we are inside the builder method of the BLoC Builder, which provides us with a state. And to react to the type of the state emitted from the block, we're going to do some simple type checking. So if state is empty, which is the default state, which is currently actually present, then we want to return a container, which will simply say text. And over there, we're going to say start searching. All right, now of course this text is not looking great, but we can see that it works and the state, the initial state of the block is indeed empty. This thing here is already becoming quite messy, so let's refactor it by extracting the container into its own widget. we're going to call it message display. And this message display, which is now present at the bottom of the file, will be a stateless widget, but it's not always going to say start searching. So instead of providing a hard-coded string in here, which still would work by the way, but instead of this, we want to have a string message, so final string message, and we're going to pass that into the constructor. So at required this dot message, and with that we're going to display the message and pass in start searching as the message from. Of course it's not working because data is null, so of course. So we need to pass that message over to the message display, and now it's going to work. All right, now let's actually style this message a bit. We do not want it to be just this small, we want it to be a bit bigger. So we're going to set the style, which will be a text style containing only font size, which will be set to 25. All right, and let's just make it aligned. So text align to be center. You could see that it moved a bit to the left. Not by much, but it did move. And also, to make this text scrollable when it's a bit longer, we are going to wrap this whole text inside a single child scroll view. So let's wrap with a new widget, single child scroll view. And now if the message becomes a bit longer so that it doesn't fit into that third of the screen height, which we've specified right over here, it's going to be scrollable. In addition to that, let's just wrap this single child scroll view inside center, just to make it also centered on the vertical axis, and now we are cool. And this message display does not need to only display the start searching message when the state is empty, but also if an error is emitted from the BLoC, so if state is error, we can also display the error message. So we're going to say, again, return message display, and it's not going to say start searching, but instead it's going to say state, which is now smart casted into being an error, which contains a message. So now if the user inputs ABC, which is not a number, we're going to return the failure, invalid input failure, and that is going to be propagated through the BLoC into a nice message being displayed. Now, technically, we could use the message display even for the state being loaded. So else if state is loaded, we could use that message display, of course, and pass in the state dot trivia, which is the number trivia dot text. But we also want to display the number nicely. As you can see in the example app, we want to display the number at the top. So because of that, we cannot just use message display even for displaying the loaded state. We're going to handle it a bit differently. For now, let's just leave this loaded clause empty. We're going to get to that later. First though, let's handle the loading state. So else if state is loading, in that case, we just simply want to display a circular progress indicator. So let's immediately put it into a loading widget. Let's extract that. We're actually going to just copy the message display widget, because still even the circular progress indicator needs to have a fixed height. Otherwise the bottom half would start jumping around because of the changing height of the top half. So we're going to just copy that message display below. Let's just call it loading widget. Let's rename that constructor. It's not going to accept any arguments apart from the key, which we can leave in there. And of course, it's not going to be scrollable, but it's still going to have a fixed height to be the third of the height of the screen. And the child will be simply circular progress indicator. And now we can use this loading widget and instantiate it over in the loading state. So return loading widget. Now let's go on to displaying the actual trivia, which is the most important part of the app. We're going to create a new widget, trivia display. So let's actually again just copy message display, paste it all the way down. We're going to call it trivia display. So let's change all of that. And of course, the constructor parameter will be number trivia, which is the entity. So let's import the entity. Let's just call it number trivia and make it be able to be passed into the constructor. So number trivia. The height will still be fixed, but instead of returning just the single child scroll view, we are in addition going to also return it inside a column with the number being on the top like this. So the message will still be displayed, and the message in this case will be coming from number trivia.text. But in addition to that, we're going to wrap this whole thing, this center widget, inside a column. So wrap with a column. And now the first children, or the first child to be grammatically correct, will be a text. And this text will contain only the number of the number trivia. So number trivia.number, of course we need to convert it to string. And then the style, which will be text style, will have font size of 50, so it's going to be 2 times as large as the message, the trivia. And then we're also going to specify the font weight, which will be font weight dot bold. And with that, we've just basically added a bolded text above the message, which is also present inside the message display widget. But let's actually test and see how the UI looks like right now. So we are going to just always return the trivia display from the top of the builder and just specify a made up number trivia. So we're just going to specify number to be 1 or 12, and the text will be ABC, just for testing purposes, of course. Or let's actually make it a bit longer. So we're going to say start searching, and paste it over here multiple times. I know it looks horrendously, but let's just test it. So we have just created number trivia, and we are always returning this trivia display. So what's going to happen is that the bottom overflowed by 36 pixels. Why is that even happening? Since inside the trivia display, we are wrapping the text inside single child scroll view, right? Well, yes, but in addition to all of this, because we are now inside a column, an additional column, in addition to the main column, which holds the bottom half and the top half of the screen, we have a nested column basically. And to make this center, which contains the text view, only take up an appropriate part of the screen and not to overflow, we need to wrap the center inside expanded. So let's wrap with a new widget, expand it. And now all of the overflow will be gone, because this expanded widget will calculate the appropriate size, in this case height of the child widget, which is the text, which it should take up so that it doesn't overflow its container. And in this case, the container is a column. Or I should probably not use the term container because that's a widget, but I hope you know what I'm talking about. It's not going to just overflow the column with the expanded widget. All right, so now we can stop testing with just some made up trivia, and instead we're going to return trivia display. Let's just delete it all. And this trivia display will be returned from the loaded state. So if it's loaded, let's return trivia display and specify the number trivia to be coming from state.trivia. All right. So with that, we have the top half completely implemented. And of course, you can get all of this code from the written tutorial from the link in the video description and go over it at your own pace. And over there, there's also the whole project on GitHub available. So, all right, we've already done a lot to keep these widgets maintainable by extracting them into their own classes. But there is one more thing which we can do, and that is to add them into their own files so that the number trivia page.dart file will not become just one long mess. So let's do just that right now. We already have the widgets folder created from the first part inside the presentation folder. So let's create a new file, and we're gonna create new files for every single widget which there is. So let's start off with the message display .dart, and while we are at it, let's also create all of the other files. So it will be trivia display .dart, and similarly, let's just use the advanced new file extension. So we're going to create loading widget .dart. So this is created here. And also we're going to create a barrel file so that we can import all of the widgets from this widgets folder in just one import. So let's create widgets.dart. And now let's first export all of the other files from the barrel file. So loading widget will be exported, then also export the message display and export the trivia display. And with that, the barrel file is done for now. And now we're just going to grab the message display from the number trivia page right over here. We're just gonna grab it, cut it out, and put it over to the message display.dart after we import material. So let's do just that. Now we have message display done. We can close it off. Similar thing will happen with the loading widget. Let's cut it, paste it into loading widget.dart after importing material. Done. And finally, the trivia display widget will be also extracted. So we can immediately see that the number trivia page is becoming more manageable. So let's paste it into trivia display after we import material. And also, of course, we need to import number trivia entity. With that, we can now come to number trivia page and hit Control and dot and import only the barrel file widgets.dart, and that in turn will import all of the needed widgets. So we are importing only the barrel file. Now for the bottom half, which is going to receive input, because we are using BLoC, we are going to dispatch events whenever a button is pressed. Because we are going to be using a text field, which needs to hold some local widget state in order to function properly, let's right now even extract the bottom half into its own widget. Let's just call it trivia controls. So let's change this from a stateless widget to be a stateful widget, because it's going to hold some local state because of that text field. That's because we are gonna need to store the string present inside the text field as a state variable. So let's create string input string. And let's replace this first placeholder with the actual text field. Now the text fields work in a way that we are going to provide an unchanged callback, which is going to grant us a value present inside the text field. And when this is called, we are going to simply store the value, the changed string value present inside that text field inside the input string, which we are going to use from the button presses. All right, and after hard restart, the text field is visible in the UI. But it's looking pretty horrendously in my opinion. So let's add some styling in the form of decoration. So the decoration will be input decoration, and we're just going to set the border to be outline input border. So it's not going to have underline, but instead an outline. So immediately it's going to look much nicer. And let's just also specify some hint to the user what he should do with this text field. So we're going to say input a number. Cool. But this, apart from the bottom being overflow, which we are going to fix next, there is also another problem, and that is that we can also input A, B, C even from the keyboard. We want this keyboard to be only numeric. And for that, we are going to set the keyboard type to be text input type, and not number with options, but just number will suffice. And now we can see that we can only input numbers. Let's now move on to the buttons. They're gonna be very simple. Still, they're gonna be wrapped inside expanded, but instead of being a placeholder, it will be simply a raised button containing a child text search. Of course, this is a string, and then the color of the first button will be coming from the theme, so theme of the context, and it will be the accent color. So it's going to be this nice green. Of course, this is going to only pop up once we override unpressed, because otherwise it's disabled. So now we can see that it works. And of course, the text theme should be displaying white text. So we're going to say button text theme dot primary. What's that going to do is that the text will be white. There are also other ways to change the text color, but this is the simplest one here. And now inside unpressed, we're going to want to dispatch an event to the BLoC, but we're going to come to that later. Let's just for now focus on the next raised button, which will be for the random number. So let's copy it and paste it instead of the placeholder. We're going to say get random trivia. Its color will not be accent, so it's going to be just a regular number, nothing fancy, or a regular button. I'm already going crazy with all these numbers. And from unpressed, we are going to want to dispatch the concrete event or the random event respectively. But just to make it more clean, we're going to extract that functionality into their own methods. So we're going to create void dispatch concrete. Which we'll simply call BLoC provider. And BLoC provider is an inherited widget, and just like with any provider, we need to get it from the context of the widget. And of course, we need to specify the type which we want to get. So the type of the BLoC which we want to get is number trivia BLoC. Of course, with lowercase r. And with that, we now have the instance of number trivia BLoC, and on it we can dispatch an event, and that event will be get trivia for concrete number. And here we're gonna pass in the number string, and that's cool because if this was an integer, we currently have only a string here, and we would need to perform the conversion from a string to an integer and also the validation that it's not negative integer inside this widget layer. And that's not a good practice. You should never put logic into your widgets. That's why we have that input converter class, which is going to handle the conversion for us. And here we just pass in the string, so input string. We do not care how it's converted over here. We're just dealing with the raw data, with the raw input data with the string. All right, so now let's specify dispatch concrete to be the function being called from unpressed of the first raised button. And with that, shall we test if this works? Of course, there's some minor bugs in here, but let's just ignore them for now. But when we input a number, it will be stored inside this input string. And we hit search, we see the number trivia, so that's cool. But wouldn't it be nicer if this number got cleared up after we search for it? Because now we input 1, 2, 3, search, and it still stays there. So if we want to input another number, we need to delete it and input a new one. And that's not a good user experience. So what we can do for that, we need to clear the text field. And this can only happen when we have a text controller. So we're going to create final controller, and it's going to be equal to new instance of text editing controller. And now we can specify this controller on this text field. We no longer need this comment actually. So the controller will be our controller coming from the class. And now, before dispatching the event over here, we're going to call controller.clear. And with that, after we input a number, 1, 2, search, it's gonna be cleared automatically. All right, now let's move on to get trivia for random numbers. So we're going to have to dispatch random. Let's just copy it below this function. Dispatch random will be its name. And here we're just going to change get trivia for concrete number to get trivia for random number, which doesn't take any arguments, of course. And we're going to call it from the onPressed of the random button. But also, it would be nice that in addition to pressing the search button, we would also initiate the search with this check mark, which currently does not happen. So in order for this check mark on the keyboard directly to work, we are going to, what's going on here? We are going to overwrite another property on the text field, which will be onSubmit or onSubmitted. So onSubmitted, which takes in a value, but we actually do not need it because all we want to do here is to call dispatch concrete, which gets the value from the stored input string. And with that, we can now test it. So if we hit this button on the keyboard, it's going to search for the number. We can also still hit the search button. And also we can now get random trivia. So that's cool, but still there is a problem because the bottom is overflowed by 57 pixels whenever the keyboard pops up. We can fix this pretty simply by wrapping the whole body. So this build body of the number trivia page, we're going to wrap this inside single child scroll view. And now when that's done, we can input a number and the UI will move a bit up. But also in addition to all of that, let's just fix this horrendously long number trivia page again by moving trivia controls over to its own file. So let's just copy or actually cut them out or together with their methods. So let's extract that, cut it out, and we're going to create a new file under widgets called trivia controls.dart import material and paste that over there. We're going to also need to import Flutter BLoC, then also our own BLoC. So BLoC.dart, the barrel file, so that we can also use the events without importing any additional stuff. And with that, we can now add these trivia controls over to the barrel file. So export trivia controls. And now number trivia page already imports the widgets barrel file, so that's cool. We also have access to trivia controls. And with that, after we just do hard restart to be safe, we can now input the number still. 12 goes there, 42 goes there. Again, 42 with the search button works. Get random number trivia works. And with that, we have just successfully implemented this whole number trivia app with clean architecture. So in these 14 parts of the clean architecture course, we've gone from an idea to a working app. And you learned how to architect your apps into independent layers, how to do test-driven development, discover the power of contracts, you learn dependency injection, and much, much more. So the number trivia app we've built may be on the simpler side when it comes to its functionality, but what's important though is that there are the principles which are present in every single app which you build with clean architecture, because what you learned in this course is applicable to all kinds of circumstances, and I truly believe that you are now an overall better developer because of this course. So practice the principles you learned here and build something awesome with them, right? To go through this tutorial at your own pace once again and to get all of the code and all of these widgets and extracted widgets, check out the written tutorial available from the link in the description, where there is also a link to the GitHub repository containing the finished project. And if you don't want to miss more tutorials and courses like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video and also this whole clean architecture test-driven development course helps you, give this video a like and also share it with other people, other developers who will surely benefit from it too. Leave a comment if you have anything to say, any suggestions or questions or really anything else, and see you in the next video.